हेलो चेक हेलो 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 चेक हेलो
एक्चुअली सर इसमें सर वो प्लैटिनम है एंड ये सर
ऊपर वायर वगैरह
नहीं वो तो वेयर बोलते तो है जो मेन है वो सेमीकंडक्टर का जो चिप्स होता है जो सुपर कंप्यूटर में जो लगता है इससे अलग सर वो इसका खासियत है कि इसको डायजेनिक टेम्परेचर रहता है
माइनस
-। तो एक चैलेंज होता है इसमें जितना प्रोडक्ट होगा उससे ज़्यादा हमको इलेक्ट्रिक कंज्यूम करना होता है पर वो अभी बैलेंस हो जाएगा इसका पोटेंशियल।
Ladies and gentlemen, the moment we all have been eagerly waiting has arrived. Our esteemed guest is about to grace the venue. I humbly request everyone to please rise in honor of our esteemed dignitary, Shri Arjun Modwadia ji, Honorable Minister of Science and Technology, Forest and Environment and Climate Change, Government of Gujarat. Please join me in welcoming our Honorable Minister with a big round of applause. Good morning and a very warm welcome to all. It gives us an immense pleasure to welcome you to the day 2 of the Conference on Public Understanding of Quantum Science and Technology. Yesterday's sessions laid a strong foundation, highlighting the need to demystify quantum science, the role of communication in emerging technologies, and the responsibility of institutions, educators, and communicators in shaping a quantum-aware society. Today, we take this dialogue forward from vision to pathways, from concepts to careers, and from communication strategies to future action.
It is our esteemed pleasure to invite our delegates to kindly take their seat on the dais as we announce their name. I would like to invite Shri Arjun Modhwadia, sir, Honorable Minister of Science and Technology, Forest and Environment and Climate Change, Government of Gujarat, to kindly take his seat on the dais. Shri Vimal K. Patel, GAS, Executive Director, Gujarat Science City. Professor Manoj Kumar Pataria, President, International Science Writers Association. Dr. Poonam Bhargava, Principal Scientific Officer, GUJCOST. Dr. Narottam Sahu, Advisor, GUJCOST. Once again, we extend a warm welcome to all the respected dignitaries on the dais. Now I request Dr. Narottam Sahu, Advisor GUJCOST, to warmly welcome Shri Arjun Modhwadia, sir, Honorable Minister of Science and Technology, Forest and Environment and Climate Change, Government of Gujarat, with a floral greeting symbolizing our respect and appreciation. Thank you, sir.
With this, I would like to invite Dr. Narottam Sahu, Advisor GUJCOST, to deliver the welcome address.
Good morning, everybody. Honorable Cabinet Minister, Science and Technology, Forest and Environment, Climate Change, Government of Gujarat, respected Sri Arjun Bhai Modhwadia sir, Dr. Manoj Kumar Pataria sir, President of Indian International Science Writers Association and former advisor and head Department of Science and Technology, Government of India. Sri Vimal Patel sir, Executive Director, Gujarat Science City. All our invited guests, dignitaries, panel experts, speakers, and our delegates. Today we are celebrating this International Year of Quantum Science and Technology, the Science Communication Conference on Public Understanding of Science and Quantum Science and Technology. So on this second day, we have a very interesting and exciting session to be graced by our Honorable Cabinet Minister, Sri Arjun Bhai Modhwadia sir, who is a very seasoned leader, public worker, and a great initiative of lots of new programs and activities which was imparting our lives, taking science into our lives and lifestyles in a very sustainable manner. So, as the theme is discussed, so sir is Honorable Minister sir will be discussed, giving the focus that how our department, our government or our policy is working towards quantum age, our shared future. As we have discussed that we are here at the three crossroads of these things. One is hardcore quantum science and technology. One part is our communicating our youngster and our younger generation. And the third part is like that how our society has developed that type of a constraint and that type of confidence on this new technology, emerging technology, which will be take care of all our challenges to our opportunity. As we are marching ahead with Honorable President's clarion call on Viksit Gujarat, Viksit Bharat, and the great mission of our Honorable Chief Minister, Viksit Gujarat, our Honorable Cabinet Minister of Science and Technology, Forest Environment and Climate Change, which is very integrated with the global problems that we are facing today. Starting from the climate change to the environmental, all types of sorts of problems and challenges, to taking science with the tools and the techniques, how we have to get rid of these types of issues and bringing the inclusiveness in all our programs and activities. We are very happy and we are very honored to have the uh, presence of Honorable Cabinet Minister, who will be not only giving that speed and that scale to our programs and activities. He is also a great visionary in taking that emerging technology to the common grassroots level as well as to the classrooms. So this session would be any quantum equations and quantum theory. It is just to quantum link with the quantum thought and quantum ideas. So how we have to, quantum should be the buzzword in our day-to-day activities, how our policy, our public practice and our classroom situations would be integrated with that things. So that would be the discussion and the take-home message. We are very happy with the very busy schedule, despite of very busy schedules and the engagements of honorable ministers, in fact, entire the government. Our honorable minister sir is so kind and so concerned about this 2 days program. So his presence and his brief interactions with all of our delegates, dignitaries, will be not only boost that aims and objective of this program, but it will be go a long way in taking this mission to a successful action point. So with this word, I once again very warmly welcome our Honorable Cabinet Minister and the guests of this very interesting session, Quantum Age, our collective future. What exactly we all can do together, irrespective of our position, irrespective of our work, how we have to take the common, this cause to the common goal of common people. So with this word, I once again welcome all of you and wish you and hope that this session would be very exciting and interesting and giving us lots of inspiration to take home a great message for these things. Thank you.
Thank you, sir. Ladies and gentlemen, we are honored to have with us on the dais Shri Arjun Modwadia sir, Honorable Minister of Science and Technology, Forest and Environment and Climate Change, Government of Gujarat, who is a seasoned public leader with rich administrative and legislative experience. Shri Arjun Bhai Modwadia sir champions science-driven, sustainable and inclusive development. He firmly believes that scientific temper must guide policy, innovation and public decision-making, empowering citizens and strengthening Gujarat's knowledge ecosystem. As a strong advocate of environmental conservation and climate resilience, he emphasizes responsible stewardship of natural resources while advancing innovation-led growth. Aligned with the vision of Viksit Bharat 2047, his leadership reflects a commitment to progress rooted in science, sustainability and societal well-being. Today, as we welcome him, we welcome a leader who inspires us to think scientifically, act responsibly and dream collectively for a future where science serves society and development walks hand in hand with sustainability.
May I request you all to join me in inviting with a big round of applause Shri Arjun Modwadia sir, Honorable Minister of Science and Technology, Forest and Environment and Climate Change, Government of Gujarat, to graciously address the gathering. We welcome you, sir.
On special session on quantum age, our collective future occasion, I welcome all of you, particularly dignitaries on dais, Narottam Sahu, who is advisor and member secretary to Gujarat Council on Science and Technology, Vimal Patel, Director of Science City, Poonam Bhargava, Senior Scientist, Manoj Kumar Patalia, who is a President of Science Communication Society, and all dignitaries. पुरानी पीढ़ी के लिए एक क्वांटम साइंस और क्वांटम टेक्नोलॉजी एक नया सब्जेक्ट है। मैं इंजीनियरिंग का स्टूडेंट हूँ, लेकिन उस समय तो कंप्यूटर भी नहीं आया था। जब मैंने ग्रेजुएशन किया उसके 8 साल बाद मैंने पहला कंप्यूटर देखा था। और ये क्वांटम साइंस, क्वांटम टेक्नोलॉजी, उनका तो सिर्फ एक चैप्टर ही पढ़ा था। लेकिन आज क्वांटम युग आ रहा है और ये युग को आप सबको, ये जनरेशन को आगे ले जाना है। आज एक कॉन्फ्रेंस है, उसमें it is a privilege to address this distinguished gathering at Gujarat Science City, an institution that reflects Gujarat's unwavering faith in science as a drive of development. This conference, held during a International Year of Quantum Science and Technology 2025, aligns perfectly with journey towards Viksit Gujarat, Viksit Bharat at 2047. हमारा प्रधानमंत्री ने संकल्प दिए हैं कि 2047 तक भारत को विकसित भारत बनाना है, डेवलपिंग कंट्री बनाना है। और ये डेवलप कंट्री बनाना है तो साइंस एंड टेक्नोलॉजी के बिना नहीं होगा। और ये जनरेशन बैठे हैं, उनको आगे ये ले जाना है। तो क्वांटम इज नॉट मियरली साइंटिफिक माइलस्टोन, इट इज ए civilization opportunity. India's vision for Viksit Bharat 2047 rests on knowledge-driven growth, technological self-reliance, inclusive and sustainable development. Quantum science and technology will be a strategic pillar in achieving these national aspirations. It will define India's leadership in secure digital infrastructure, advanced manufacturing, healthcare innovation, clean energy, and climate resilience. Gujarat science, technology, and innovation policy is rooted in clear belief that science must translate into societal impact, economic growth, and environmental sustainability. हमारी परिकल्पना है और बिलीव भी है कि साइंस एंड टेक्नोलॉजी, उनसे देश का भविष्य बदलना चाहिए। हमारा जीवन है उससे स्मूथ होना चाहिए और ईज ऑफ डूइंग और ईज ऑफ लिविंग उनमें बढ़ावा मिलना चाहिए। यही फिलॉसफी के तौर पर हमने हमारी पॉलिसी बनाई है। दिस पॉलिसी emphasizes strengthening research and innovation ecosystems, encouraging industry, academia, government collaboration, supporting startups, deep tech innovation, and indigenous technologies, promoting science, temper, and public engagement. Quantum technologies resonates strongly with Gujarat's science, technology, and innovative priorities. That is quantum computing for industry, logistics, and smart manufacturing. Quantum communication for secure governance and digital trust. Quantum sector for healthcare, environment monitoring, and disaster resilience. Gujarat aims not only to adopt quantum technologies, but to co-create solutions for national and global challenges. A defining features of Gujarat's approach is democratization of science. Through GUJCOST, quantum science has been taken beyond elite institution to the smaller institution like science centers, science cities, schools, colleges, teachers training institutions, rural and aspirational districts. This reflects the core philosophy of Viksit Bharat, progress that reaches every citizen. By 2047, today's students will be India's scientists, innovators, policymakers, and entrepreneurs. Gujarat's science, technology, and innovation framework's priorities are future-ready STEM education, skill development in frontier areas like quantum technologies, platforms for innovation, experimentation, and entrepreneurship. The quantum age must become a career pathway, not a distant concept. Gujarat development vision is deeply aligned with environmental responsibility. Quantum science offers powerful tool for climate modeling and prediction, energy efficient systems and green technologies, sustainable materials and resource optimizations. Innovation must always walk hand in hand with ecological balance. The Gujarat Science, Technology and Innovation Policy recognizes science communication as a vital enabler for innovation. Public understanding builds trust in new technologies, ethical awareness, informed participation in policy and progress. This conference strengthens the bridge between cutting-edge science and public consciousness. The quantum age calls for collective leadership. That is a scientist who engage society, educators who inspire inquiry, communication who simplify it without diluting, and policymakers who enable and protest. Together, we shape not only technologies, but the values that guide them. जैन जी भी यहाँ बैठे हुए हैं, उनके लिए भी ये मैसेज है कि an age of innovation with inclusion, growth of sustainability, knowledge with wisdom, that is a quantum age. The journey to Viksit Bharat 2047 will be written by your ideas. Quantum science is frontier waiting for your imagination and integrity. With Gujarat's strong science, technology and innovative policies, our foundation in India's whole national vision, we move confidently towards Viksit Gujarat, Viksit Bharat at 2047. I congratulate Department of Science and Technology, Gujarat, Council for Science and Technology, Gujarat Science City, and all national and international partners for their leadership in this important initiative. I wish the conference insightful deliberation and transformative outcome. Thank you. Jai Hind.
Thank you, sir. We invite the audience members to participate as the platform is now open for interaction.
Hello, Namaste, good morning to all. And my main question and one suggestion also is there. So today, coming to here from Pragati Hotel to here, one student was with me, and he was interested. He's a 11th science student. He's interested in the nanoelectronics. So I'm Dr. Tulsi Siani from Rajkot. So I'm running a we are running a Siani Research Institute in Rajkot. It is a not-for-profit organization. So I told him that we can create an innovation club, and student can join in that club. So right now, GUJCOST is not running that type of activities. Like we have the big centers in all districts. Here also, Gujarat Science City is also there. So we can create an innovation club, and we can join the school students, college students, those who have the innovations. So that type of bridge we can fill the gap, and we can create the more innovations. Okay.
Thank you, sir. In fact, both Gujarat has the, as we are trying our level best to have the best infrastructure in terms of science centers and science education popularization. So we are blessed with our government and our governance, our policy, that initially science city यहाँ पे एक ही था, and हम लोगों को प्लान था कि हम लोग राजकोट से लाना है, सूरत से लाना है, भूज से लाना है, इधर पोरबंदर से लाना है, कि बनासकांठा में लाना है, कि कोई ट्राइबल डिस्ट्रिक्ट में लाना है. So every day it is not possible that to force the student or bring that student from that place to this place. So इसी के लिए we have very privileged with our government's policy and practice. क्यों हम लोग साइंस को इनके पास ले जाएंगे? इसके लिए हमारा हर डिस्ट्रिक्ट में, हर रीजन में एक रीजनल साइंस सेंटर है जो मिनी साइंस सेंटर हो सकता है, एंड हर डिस्ट्रिक्ट में अभी रीजनल साइंस सेंटर भी बन रहे हैं. तो इसके अलग हमारे पास पहले से Gujarat also have the set a role model having this community science center, लोक विज्ञान केंद्र. विक्रम साराभाई कम्युनिटी साइंस सेंटर जैसे अहमदाबाद में रेस्पेक्टेड फादर ऑफ नेशन, फादर ऑफ स्पेस साइंस जैसे बनाए थे, तो ऐसे तरीके से गुजरात में हमारा लोक विज्ञान केंद्र भी है. एंड ये लोक विज्ञान केंद्र जो है CSE मॉडल को अभी डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी, गवर्नमेंट ऑफ इंडिया इनको भी अडॉप्ट करना चाहते हैं, क्योंकि ये ऐसा ही लोक विज्ञान केंद्र ऐसा कॉन्सेप्ट है, ये एक स्टैटिक ऑफिस नहीं है. तो यहाँ जा कर के रूरल एरिया में, तालुका लेवल में हमारा खेडूत लोग हैं, हमारा जो ग्रामीण वोमेन हैं, बहन लोग हैं, ओके, जो यूथ है, जो इन लोगों को एक्साइटमेंट करते हैं. तो इसके लिए हमारा जो साइंस सेंटर सिर्फ इतना नहीं है, हमारा 1000 साइंस क्लब भी होता है. गुजरात में हमारा 615 अटल टिंकरिंग लैब है, जो वहाँ पे कॉलेज, स्कूल एजुकेशन से कॉलेज एजुकेशन को ब्रिज करते हैं. हमारे पास 482 इनोवेशन क्लब जो है सिर्फ आर्ट्स कॉलेज एंड कॉमर्स कॉलेज में बनाया है. विथ द सपोर्ट ऑफ एजुकेशन डिपार्टमेंट हम लोग सोचा कि ये साइंस इनोवेशन सिर्फ साइंस स्टूडेंट का बात ही नहीं रहेगा, हमको इनको कॉमर्स को स्टूडेंट भी पढ़ा देना है एंड आर्ट स्टूडेंट को देना है. तो हमारे पास 482 इनोवेशन क्लब है, जो सिर्फ आर्ट्स कॉलेज एंड साइंस कॉमर्स कॉलेज में चलता है। इसके साथ हमारा थाउजेंड्स ऑफ इको क्लब हैं, जो हमारा फॉरेस्ट डिपार्टमेंट गिर फाउंडेशन के साथ हमारा कोलैबोरेशन में काम चल रहे हैं। एंड काफ़ी स्कूल में जो इनोवेशन क्लब भी हैं। एंड इसके साथ अभी ये साल में लास्ट ईयर में हमारा डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी एंड गवर्नमेंट ऑफ गुजरात के माध्यम से हम लोग जो इंटेलेक्चुअली प्रॉपर्टी है, आईपी है, जहाँ पे जो आइडिया को कैसे हंट करना है, इसमें हम लोग को अभी जो नेशनल का जो प्रायोरिटी था कि हम लोग सिर्फ एक दिल्ली, कोलकाता, चेन्नई, मुंबई और बेंगलोर में ऐसा इनोवेशन होता है, वहाँ पे बड़ा बड़ा माइंड होता है, वहाँ पे बड़ा स्टार्टअप होता है। ये कॉन्सेप्ट को आगे लेकर के हम लोग अभी तालुका लेवल एंड गांव का तक पहुँचाए। तो हर कम्युनिटी साइंस सेंटर में हमारा एक आईपी लैब बना हुआ है, जहाँ पे कोई भी नया आइडिया आएगा, पहले जाकर के लोक विज्ञान केंद्र में हमारा आईपी ऑफिसर हैं, इनके पास इनको हमारा प्रायर शॉट्स वगैरह है तो देखेंगे, इसके बाद फिर आईपी सेंटर आएंगे, तो ऐसे तरीके से आएंगे। इनफैक्ट हमारा ऑनरेबल मिनिस्टर सर के जो फर्स्ट इंटरेक्शन हुआ था, सर का एक एडवाइस था, हमारे यहाँ पे आई हब करके एक नेशनल मॉडल है, तो सर का आइडिया है कि हर डिस्ट्रिक्ट में हम लोगों को आई हब बनाना है। सर मुझे रिक्वेस्ट करता हूँ सर।
देखो, जो कोई नई थियरी आती है कभी, उसमें फर्स्ट मूवर कौन है, वही लीडर दुनिया में बनता है। इंडस्ट्रियल रिवॉल्यूशन आया, उस समय इंडिया एक कॉलोनी थी, तो इंडस्ट्रियल रिवॉल्यूशन की ट्रेन हम मिस कर गए। इतना ही नहीं, हमारा जो अपनी आर्ट थी, अपनी टेक्नोलॉजी थी, वो भी कॉलोनियल रूल्स आया, उसमें वो वेनिश हो गई। ठीक है, वो तो हम पिकअप नहीं कर पाए क्योंकि डिसीजन हमारे हाथ में नहीं था। उसके बाद आईटी रिवॉल्यूशन आया, कंप्यूटर रिवॉल्यूशन आया, वो हमने पिकअप कर लिया, तो आज दुनिया में हम लीडर बने हुए हैं। तो अभी ये टेक्नोलॉजी जो आ रही है नई नई, कोई बहुत सारी न्यू एज टेक्नोलॉजी आ रही है। ये टेक्नोलॉजी में अगर हमें लीडर बनना है, एआई है, ये क्वांटम टेक्नोलॉजी है, तो ये सभी में बनना है, तो स्कूल से ही हमें आइडिया कंसीव करना चाहिए, अंडरस्टैंडिंग उसी समय से आनी चाहिए। तो साइंस सिटी तो एक देश में एक मॉडल है हमारा यहाँ का, लेकिन जैसी तरह डॉक्टर साहू ने बताया कि हम डिस्ट्रिक्ट लेवल तक जा रहे हैं, रीजनल लेवल तक जा रहे हैं, उससे थोड़ी सी जो ये रेप्लिकेट होगा साइंस सिटी रीजनल सेंटर पर, वो थोड़ा छोटे पैमाने पर होगा, उसके बाद डिस्ट्रिक्ट में जाएंगे और बाद में हमारा इंक्यूबेशन सेंटर है, स्टार्टअप है, आई क्रिएट है, आई हब है, वो भी हम डिस्ट्रिक्ट तक ले जाएंगे। और तभी बच्चे एआई स्कूल में ही समझ पाए, तो आगे जाकर एआई है, क्वांटम टेक्नोलॉजी है, वो आगे ले जाकर उसमें वो लीडर बने। ये हमारी कोशिश है। इसलिए ही ये आज का जो थीम है साइंस कम्युनिकेशन कॉन्फ्रेंस, वही समझने के लिए, वहाँ लोगों तक पहुँचाने के लिए, इसके लिए ही रखी गई है। तो हम ज़रूर उसमें, गुजरात ही नहीं पूरा भारत उसमें लीडर बने, ये हमारी अपेक्षा है। प्रधानमंत्री भी वही चाहते हैं कि साइंस एंड टेक्नोलॉजी में हमें लीडर बनना चाहिए। और इसकी वजह है कि आज जो न्यू एज इंडस्ट्री है, न्यू एज मैन्युफैक्चरिंग है, वो हमने इंडस्ट्री में नहीं रखा है यहाँ। ये चाहे सेमीकंडक्टर मैन्युफैक्चरिंग पॉलिसी हो, ये इलेक्ट्रॉनिक्स कंपोनेंट मैन्युफैक्चरिंग पॉलिसी हो, डेटा सेंटर हो, आईटी हो, या सबसी केबल हो, सोलार सेल मैन्युफैक्चरिंग हो, ईवी बैटरी हो, ये सभी हमारे यहाँ इंडस्ट्री में नहीं है, साइंस एंड टेक्नोलॉजी डिपार्टमेंट में। वही प्रोडक्शन की, मैन्युफैक्चरिंग की वही पॉलिसी बनाते हैं। तो ये विज़न पहले से ही हमारे प्राइम मिनिस्टर जब गुजरात के मुख्यमंत्री थे उस समय रखा था, और आज हमारे भूपेंद्र भाई पटेल की सरकार उसको आगे बढ़ा रही है। थैंक यू।
Hello, good morning, sir. I am Jayaprakash Verma from Nirma University. Yesterday we attended the whole session, and we know that this quantum computing is completely parallel to traditional computer. Definitely, quantum computing will not going to replace the traditional computing, that we know that. The applications of for quantum computing and the quantum computing as well as quantum technologies are totally differ. They are all areas differ, all businesses differ. Here, we would like to know about the role plan of the government regarding the how to achieve, how to make it just like in a computer awareness. We introduce it in NCRT and all these things in school level, and then we have accommodate it parallelly to all education, all science and technology. Same, is there any plan for introducing quantum computing in that level? As well as the second question is, what the role of private institutions like Nirma and our as an educator working in institutions, private institutions, to contribute in this particular journey of government is planning, where we are accommodating us?
आप सर बहुत अच्छा प्रश्न बताया। ये कि हमारा एक्शन प्लान के लिए हम लोग हैं, जब ऑनरेबल मिनिस्टर सर हमारा डिपार्टमेंट का गाइडेंस दे रहे हैं, एंड वहाँ पे एक ही शब्द है कि इंक्लूसिवनेस। ओके, यहाँ पे कोई गवर्नमेंट प्राइवेट ये नहीं है। गुजरात गवर्नमेंट बिलीव्स इन पब्लिक प्राइवेट पार्टनरशिप। हमारा सारा प्रोग्राम, सारा पॉलिसी, सारा प्रोग्रेस सबको लेकर के चलना है। ओके, तो इसी के लिए आप जैसे बताया कि कल हमारा काफ़ी चीज़ हम लोग डिस्कशन किया। क्वांटम साइंस को कैसे स्कूल तक लेने के लिए एक हमारा डॉक्टर कामले साहब जो हमारा मेंटर हैं, तो इनके मार्गदर्शन में जो किट बनाया हुआ है 33 एक्टिविटी है, वो स्क्रोडिंजर का इतना बड़ा कॉम्प्लिकेटेड प्रिंसिपल है, माने वो जो बिल्ली है वो लाइव है कि डेड है, इस कंसेप्ट को लेकर के एटम को पार्टिकल कैरेक्टर एंड लाइट कैरेक्टर के साथ रिजेंबल करके क्वांटम एंटेंजलमेंट को भी बात करते करते ये सारा बच्चे अभी हमारा स्कूल का स्टूडेंट तक अभी पढ़ते हैं। सर वी आर बी वेरी हैप्पी। हमारा 2 स्टूडेंट हैं, 11 स्टूडेंट का एंड 10 स्टूडेंट का, 1 फ्रॉम राजकोट एंड 1 फ्रॉम बड़ौदा। आई थिंक आप दोनों थोड़ा खड़ा हुए ना, so that those students are particularly they are studying in deep माने in the quantum science research। हम लोग इनको ऑनर करने के लिए, हाँ आप लोग खड़ा हो जाइए दोनों, श्रीधर एंड शायद ये लोग आया नहीं अभी तक। क्या है? हाँ हाँ उत्सव है यहाँ पे। हाँ उत्सव एंड और एक के बड़ौदा से है। सर ये दोनों आज जो डिस्कशन करेंगे इनके पॉइंट का ऊपर में, तो ऐसे हमारा अवेयरनेस को हम लोगों को चाहते, तो ये सारा स्टूडेंट के तक पहुंचेंगे। इनके लिए हमारा जो साइंस सिटी एंड रीजनल साइंस सेंटर के माध्यम से हम लोग टीचर ट्रेनिंग प्रोग्राम करते हैं। पहले टीचर को भी हम लोगों को इनको ओरिएंटेशन देना ही है। इसके बाद फिर हमारा जो पॉलिसी है, STI पॉलिसी के बारे में जो हमारा ऑनरेबल मिनिस्टर सर बात किया, इसमें अभी हमारा क्वांटम साइंस का रिसर्च का एक स्टेट स्पेसिफिक सब्जेक्ट रखा गया है। तो इसमें सपोज आप निर्मा यूनिवर्सिटी में हैं, कोई दूसरा यूनिवर्सिटी स्टेट यूनिवर्सिटी है, और कोई स्पेशल एस्पिरेशनल डिस्ट्रिक्ट में जो भी यूनिवर्सिटी है, तो वहाँ पे भी कोई प्रपोजल आएगा तो हमारा गाइडलाइन के हिसाब से 50 लाख से ज़्यादा 50 लाख पर मैक्सिमम लिमिट के हिसाब से इनको रिसर्च करने पड़ेगा। एंड सपोज द प्रपोजल और भी ज़्यादा कंटेंट ओरिएंटेड होता है तो ये भी 50 लाख से फिर 1 करोड़ 2 करोड़ तक भी जाएगा एज पर द रिकमेंडेशन ऑफ द टेक्निकल एडवाइजरी कमेटी। तो ये रिसर्च में है, एजुकेशन में है, ट्रेनिंग में है, एंड इसी के अलग में भी हमारा गवर्नमेंट जो है इतने प्रोएक्टिव है, तो काफ़ी इंडस्ट्री को हमारा इनविटेशन दिया जाता है ताकि वहाँ पे एक हमारा क्वांटम पार्क करने का प्लानिंग है. तो वी हैव आवर respected and very dignitary Director General of Gujarat Biotechnology University, Dr. Professor Sujit Majumdar sir. Sir is very keen to take that biotechnology with the quantum technology. So that will be give that ecosystem and that speed, so that how best we can get that things. So we are very happy that we are working or we are developing that type of model in a state, which is also going to be a role model for others to think. In fact, in the other way around also, we are very keen to adopt any such technology which is be developed or designed or practiced elsewhere, कोई अदर स्टेट में है, अदर कंट्री में है, तो हम लोग इनको भी अडॉप्ट करके हमारा लोगों के लिए, हमारा सोसाइटी के लिए, हमारा स्टेट के लिए, हमारा नेशन के लिए भी हम लोग इनको जोड़ने के लिए चाहता हूँ. तो इसी तरीके से ये जो कॉन्फ्रेंस हुआ है, ये टुडे आज सिर्फ इनका ख़त्म नहीं होगा. दिस इज योर आई ओपनर एंड इट इज़ द बिगिनिंग ऑफ दैट टाइप ऑफ डायलॉग. आइडिया को हमको लेना ही है, आपसे कुछ सीखना है, और हमारे पास कुछ होता है तो हम लोग आपको बताना है. तो इसी तरीके के माध्यम से है. एंड आई वुड लाइक टू request also Dr. Manoj Pataria sir, who is also the mentor for this type of communication all across the country, as well as the connecting with the other countries, to say a few words.
Thank you, Honorable Minister, dignitaries and colleagues, scholars. It's my privilege and honor to be able to be part of this, a great beginning that is happening in the state under the leadership of Honorable Minister. Dr. Sahu is taking it forward. And I'm very happy since 2 days the discussion going on is very fruitful. I would like to make a some kind of my thoughts. You must be thinking also, as Dr. Sahu has said, हम लोग एक ये सोच सकते हैं कि जो एक स्कैटर्ड थिंकिंग अभी हुई है उसको कंपाइल किया जाए, सारे आइडियाज़ को लेकर के, छोटे से लेकर के बड़े तक जो भी आया है. एंड टू बिगिन विथ, सिंस ऑनरेबल मिनिस्टर इज ऑल्सो फ्रॉम द टेक्नोलॉजी बैकग्राउंड and all this, so I think you can think of having a high-level advisory committee under the chairmanship of Honorable Minister, including all experts from different organizations at state level as well as national level. And you have rightly said that like in international affairs, the organizations are very keen to include Indian scientists. So similarly, it could be two-way. While doing so, we can also invite people who are leading, who are the torch bearers in the international level. We can also have them on board. So that will give a lot of, I think, impetus for ourselves. Because generally what happens, the technology comes from outside and we generally try to take it forward. So this may be a good idea to develop the technology first here and it spreads all around the world. So this could be a kind of beginning. Number two, we can have such conferences, discussions, brainstorming, get-togethers in various districts. You already have the network involving all the people at grassroots level. Scientists meet with the students, school colleges meets, quiz programs, competitions with the students, essay writing on quantum science. So this will spread the word, this will spread the public understanding and general awareness on this emerging technology that is quantum science and technology. So I think this whole effort will give rise for innovation and technological development and shaping the future of the state as well as India, especially in terms of quantum science and technology.
Good morning, sir. This is Professor Sai Baba from National Institute of Advanced Studies, Bangalore. very happy to see the progress being made by Gujarat in different domains. Yesterday we were there at the Astronomy Center. It is as good as anything else elsewhere. I was there in Houston some time back and I was comparing. It is as good as. Congratulations to the initiatives. Your presence says that we would like to take this initiative seriously. And your talk was excellent. You raised certain issues. While my point is that while we are looking at a newer technology, we are now looking at academics, research, but then there's also excellent opportunities for new startups to take up newer technologies at a very early age. And I would briefly mention in my panel discussion about where that possibilities can be there. This realization of quantum technologies cannot happen without the industry involvement. I would suggest that maybe GUJCOST should take initiative and call for some of the entrepreneurs, startups and see where they can participate. I'm sure that the government would support it, and that would really take it spin-offs to involving all segments of people, both academicians, researchers and industry. Bigger industry will come much later. I think we would probably get involved the MSMEs, the startup ecosystems. I thought I should give this suggestion and then your thoughts on this.
आपकी बात एकदम सही है कि रिसर्च कभी सरकार की गोद में बड़ा नहीं होता और सरकार कभी रिसर्च को जन्म नहीं देती है, वो तो स्टार्टअप ही देती है या एंटरप्रेन्योर्स है वही देते हैं। तो वो आइडिया बहुत ही अच्छा है आपका, हम कर रहे हैं और ज़्यादा उसमें बढ़ावा भी देंगे।
Namaste to all. My name is Dipin Damodaran. I'm the co-founder and editor of 8 Publica. It's a multimedia news outlet on education, science and climate change. So I have 3 questions. One is, the Honorable Minister mentioned about the democratization of quantum science. So I think the democratization of science is still a work in progress in India. So is it an easy task to democratize a complex technology, emerging technology like quantum science? Especially there has been a great hype on quantum science in recent years. The National Quantum Mission has come. We have allotted around 6,000 crores, etc. That's one question. The second one is, has the Gujarat government conducted any comprehensive survey on science literacy levels to get an understanding on the science awareness of the public? I'm asking this because the government has been, I have a feeling that unlike many other states, the government has been conducting a lot of science awareness programs. So if the answer is no, how do we measure the impact of these initiatives? And the third question is, do you have any concrete or comprehensive policy or initiatives to support women in STEM? Because that's also an emerging and the need of the hour. So these are the 3 questions I would like to have the take on Minister and the honorary advisor also.
थैंक यू सर। आपका जो 3 क्वेश्चन है, पहला क्वेश्चन तो है हाँ, जो डेमोन्स्ट्रेशन था, जो डेमोन्स्ट्रेशन ऑफ क्वांटम साइंस एंड टेक्नोलॉजी तो था, डेमोक्राइजेशन एंड डेमोन्स्ट्रेशन बोथ वी आर वर्किंग फॉर। डेमोक्रेटाइजेशन मीन्स जस्ट अभी मैं बताया, हमारा ऑनरेबल चीफ मिनिस्टर एंड ऑनरेबल मिनिस्टर, कैबिनेट मिनिस्टर जो है साइंस एंड टेक्नोलॉजी, वी आर हैविंग दिस डेडिकेटेड साइंस टेक्नोलॉजी पॉलिसी. In that policy we have 12 thrust area, major thrust area, including semiconductor, electronics, IoT and quantum science, and all the traditional sciences like new materials, biotechnology, nanotechnology, energy, storage, sustainability. All these 12 major areas are there, and this was all open for inviting problem statements. So we are inviting the startups the principal investigators from our state university, private university, premier institution like IIT, CUG. So they are, once our college open, so they can invite, they can submit the application. So that has to be evaluated by a panel of experts, very eminent expert across the country, from IIC Bangalore to IITs and NITs, ISOR. So all these things, government has constituted that very robust policy and evaluation mechanism also. So the committee has to recommend, and also to not like reject. We don't have that policy of a rejection. We have all the recommendations. Suppose if any project is not to the mark, so our the TAC member, technical advisory committee, so kind and so generous, इनको बताएंगे भाई आप ये change करके next cycle में इनको submit करो. We are not rejecting, but we are advising that you work on this point, which is the limitation. So फिर next cycle में डालेंगे, so it would be approved. So in that way they are helping us. So that way we are democratizing the either government fund, public fund to the research, and getting and handhold till their technology has to be coming to as either a new product, new process, or benchmarking with the product available elsewhere. So ये तीन चीज़ के लिए government and department is very keen and working with all other thing and support collaboration and promote collaborations also. Institutional, दो institution है, interstate है and interdisciplinary है, ये सारा चीज़ को हम लोग को कर रहे हैं. That the thing. Demonstration के part में we are the first in the country जहाँ पे क्वांटम कम्युनिकेशन ऊपर में हमारा जो दो प्रीमियर इंस्टीट्यूट हैं, एक है फिजिकल रिसर्च लेबोरेटरी जो कल आए थे, यहाँ पे डायरेक्टर साहब थे, एंड इसके बाद स्पेस एप्लीकेशन सेंटर जो हमारा हार्ट ऑफ द आवर इसरो का जो यूनिट है. तो ये दोनों इंस्टीट्यूशन लगभग 5 किलोमीटर डिस्टेंस है दोनों इंस्टीट्यूशन के. दोनों इंस्टीट्यूशन के अंदर में इनका कम्युनिकेशन हब बना करके क्वांटम क्यूबिट के माध्यम से ये एक एस्टेब्लिशमेंट लिंक किया, which would be going to with the link with the कल जो हमारा PRL डायरेक्टर सर बताए कि यहाँ से सपोज जो कम्युनिकेशन जाता है मार्स को, इनको 45 मिनट लगता है रिस्पॉन्ड आने के लिए. सपोज मार्स में हमारा कोई शटल है, कोई हमारा सैटेलाइट है, वहाँ पे कुछ ब्रेकडाउन हुआ तो इनका इंफॉर्मेशन हमारा आते आते 45 मिनट लगेगा. इनको कैसे मिनिमाइज करने के लिए दे हैव सक्सेसफुल इन द क्वांटम कम्युनिकेशन विच इज ऑल्सो गोइंग टू ऑनबोर्ड ऑन द नेक्स्ट मिशंस. इनफैक्ट हमारा जो स्टूडेंट के साथ हैं अभी नवंबर 15 से नवंबर 23 तारीख तक 9 दिन तक हमारा जो गुजरात का रूरल स्टूडेंट का बच्चे को हम लोगों को सैक इसरो के कैंपस में 9 दिन का इनका ट्रेनिंग दिया था, जहाँ पे ये दो स्टूडेंट वो क्वांटम कंप्यूटर का वहाँ पे क्वांटम क्लिक किया. एक ग्रुप एक यूनिट में रुके, दूसरा ग्रुप दूसरा PRL में रहे. ये दोनों मिलकर के वहाँ पे क्वांटम क्लिक करके ये लोगों का अपना सपना को एक नया ऊंचाई तक लिया. Not only they understand the quantum technology, they experience it, that how quantum is going to be changing their future. The third part जो था आपके third question था impact जो था, impact and assessment जो था, इसमें we are also working because being a government organization we are accountability for such audit and such type of things. हमारा पे काफ़ी पब्लिक अकाउंट कमेटी है जहाँ पे हमारा वी आर आवर डिपार्टमेंट एंड आवर एक्टिविटीज इज बीइंग रिव्यूड. स्टिल द बेस्ट थिंग इज दैट द evaluating our activities, our awareness, our capability and the impact. The United Nations itself has declared GUJCOST and the Department of Science and Technology as the patron institute for the year-long quantum science and technology awareness and activities. We are so proud and so privileged with the patronization of Government of Gujarat and Government of India. GUJCOST and DST is the only institution in the country for this awareness program. So that shows that our evaluation is being taken care by anywhere, somewhere this thing. So ये program में भी हमारा जो एक student थे and we have started a state level program on quantum science, opportunity and challenges. This is a program we conducted through class 8 to 10 students, and I think 10 to 12,000 students participated across the states. And at the state level, one girl from standard 10, Khushi, na? खुशी करके है के बलसाड़ के हैं. So she stood first and she was selected to represent Gujarat at the national level. It was in BSS Visvesvaraya Science Museum, PSM Bangalore में था, and she also stood second there. Okay, second with the lot scholarship. So that shows that यहाँ पे जो inclusiveness है, जो ट्राइबल डिस्ट्रिक्ट हैं, एस्पिरेशनल डिस्ट्रिक्ट्स हैं, वहाँ का भी स्टूडेंट जाकर के नेशनल का विनर होकर के आते हैं. एक दूसरा स्टूडेंट है हमारा भावनगर का 100 किलोमीटर दूर का गांव का स्टूडेंट है, प्रथम करके. ही वाज आल्सो among 15,000 state students from the rural school. He has competed for the National Rural IT Quiz, and on November 19th at Bangalore Tech Summit, he stood first and become the National Rural Quiz champion. He got 1 lakh prize, cash prize, as well as lots of incentive and scholarship for his future studies. So every year also Gujarat के एक और 2 स्टूडेंट हमारा नेशनल इंटरनेशनल साइंस ओलंपियाड को पार्टिसिपेट करते हैं एंड वहाँ से मेडल लेते हैं. दिस ईयर वी गॉट 2 मेडल, वन फ्रॉम आगम करके एक हमारा स्टूडेंट है, हु इज जस्ट कंप्लीटेड 12th and now a computer science student at IIT Mumbai. He stood second gold medal at the Paris International Physics Olympiad, and other student is Rudra Pethani. He is from Rajkot. He was also he stood first in the International Biology Olympiad at Philippines. So these are the success indicator that how science, technology, innovation or education is going through in our district level, and we are not seeing that it is only concentrated in the city like Ahmedabad or Baroda. So we are getting the student all across the state as well as the rural and urban things. So still we are not satisfied. We are trying our level best. So our department also giving lots of more task that how this thing to be also percolated to much more this thing. So that's the reason the Honorable Minister, despite of his busy schedule, he is also here to see that how the things is going on. It is not like that Minister sir baat kar diya and wo chala gaya. That shows the concern, and that shows the implication part of the things. That's the way the Gujarat machine and machinery are working here. So still we are looking forward that to look all where are the gray areas, कहाँ पे हमको और भी आगे बढ़ना है, सीखना है. We are not like that we are the best or something like that. Every day it's a learning session, and every program we seek organize as a better or innovative way. Not like that it is a government program, फाइल में ऐसा लिखा है तो ऐसा करके इनको रिपोर्ट करके इनको कंप्लीट करना है. Not like that. Every program, every activity has some sort of innovation, some sort of newness, freshness, so that it will be leading to some new hopes and new process and new product finally. So we welcome your message, and we will seek in that process for democratization, demonstration, impact, as well as the policy to practice. Thank you.
Good morning, sir. Myself Pratik, and I have a question for GUJCOST regarding patent. How to reach GUJCOST for patent? Because I wanted to patent. So I approached many guys, like there are several agencies, or I can say. They are charging many, like 70K for one patent. So for as a PhD scholar, that is too much. So if I have about 2 or 3 patents, that is too much money. So how I can reach GUJCOST for patent? Because I am a blank in that field.
Yeah, thank you. Your query can be solved right here. We have our patent information cell team sitting right here in this audience, so you can directly approach them. We are helping, we are facilitating patents at our patent information cell. And recently, in the presence of Honorable Minister, we also filed more than 200 patents in a single day. So that's all going on. So you can immediately get your query solved here itself. During the breakfast, lunch, anytime. You can just meet the team. Thank you.
Second, I just add, this is a very historical moment for us. एक दिन में 2 दिसंबर में ऑनरेबल मिनिस्टर सर के काइंड मैंने एडवाइस गाइडेंस एंड प्रेजेंस में हमारा एक रोबोटिक कंपटीशन चल रहा है. इसमें 218 प्रेजेंस हुआ. सर इसको जो वाइपो है वर्ल्ड इंटेलेक्चुअल प्रॉपर्टी ऑर्गेनाइजेशन, दे हैव रिपोर्टेड on the next day, like India make a milestone with 218 projects. They have not stated like a GUJCOST, DST or Gujarat. They reported as the India story. So एक दिन में 218 पेटेंट किया हुआ. एंड सारा का जो कॉस्ट है, इनका जो कंटेंट है, ये सारा हमारा पेटेंट इंफॉर्मेशन सेंटर का साइंटिस्ट लोग किया है. एक पेटेंट का फाइल करने के लिए 8,000 रुपीज़ चाहिए इनका पेटेंट फीस. ये भी हमारा ऑफिस इनको दे रहे हैं. एंड इनका जो अटॉर्नी को सपोज कोई प्राइवेट में जाएगा, जैसे हम लोग को केस के लिए एडवोकेट लगते हैं, जैसे पेटेंट अटॉर्नी के लिए जाएंगे तो इनका भी फीस होता है. इनका फीस भी हमारा इन हाउस तैयारी होता है. तो इसमें कोई पैसा एडिशनल फी वगैरह भरना नहीं है. ओके. थर्ड पार्ट इज लाइक दैट सिक्योरिटी. सपोज आपका आइडिया है, कोई आप प्राइवेट के अटॉर्नी के पास जाएगा, पैसा तो लेगा, हु नोज दैट ही कैन ऑल्सो लीक योर आइडिया. ओके. जैसे हमारा प्राइवेट सर्वर में हम लोग डाटा रखते हैं, हम लोग हर टाइम में लगता है कि वेदर वी आर सिक्योर और नॉट. बट हियर यू आर पुटिंग योर ट्रस्ट एंड कॉन्फिडेंस ऑन ए गवर्नमेंट ऑर्गेनाइजेशन, जहाँ पे हम लोग NDA साइन करके फिर इनको करते हैं. सपोज इनका आइडिया में कुछ सुझाव करना है, कुछ मॉडिफिकेशन करते हैं. सो आवर टीम इज ऑल्सो गाइडिंग. सो वी हैव ऑल्सो पैनल ऑफ एक्सपर्ट एंड 100 IP सेल्स हमारा है, IP दिस थिंग. So with that way, so that the GUJCOST is also helping, DST is also helping, and that is also mandate of our science, technology and innovation policy.
Good morning, sir. I am Nishil and I am a master's student from Ahmedabad only. So my question is very simple. The title of this conference says Quantum Science and Technology. So there is word quantum science. So science is basically done by pen and paper. So what policies are there for the guys who are doing active research in theoretical fields, in physics or any subjects? Because most of the policies are either focused on startups or technologies. So my question is, what policies are there that help guys like us who are spending quite a lot of time on calculating things on pen and paper? Because at the end, pen and paper are what started the physics journey from Newton to this quantum age. Thank you, sir.
Yes, that is the fundamental idea, and already we have witnessed the progress of physics took place like this. Even Albert Einstein, you know, that he was working on theory of relativity, and he did not get the Nobel for theory of relativity, but got for the photoelectric effect. So that is true. Incidentally, the government of India has come up with a national quantum mission under the aegis of the Department of Science and Technology, and they are also putting together a number of centers for promoting research in quantum science and technology, including all these areas, entanglement, quantum communication, quantum computing. So all these are just coming up very soon. And apart from that, there are small centers, some national centers as well as some regional centers are also being created on different areas. So, of course, the Gujarat Council of Science and Technology is also partnering with Government of India. So, I think very soon this vision of quantum science and technology is going to be realized through National Quantum Mission, and that has all these verticals on these areas. So, very soon, I think you will find yourself as part of doing something tangible on that aspect. Wish you all the best.
Thank you. I am Abhinay Kamble. I have a couple of suggestions. You see, when it comes to, say now, teaching or say explaining, say concepts of quantum science and technology, especially to children or say common people what we really lack is the resource material in some various ways. For example, publications or films for the target groups, we really don't have that kind of resource material, neither in English nor in Gujarati. I think one thing that Gujarat Council of Science and Technology should take up is the production of material for students and also the general public, both in English and Gujarati. Especially now targeting these groups, because quite often we really mistake quite often science, technology for science. That should not happen. The technology is really applied science. Whatever when we talk about quantum technology, we should not confuse it with quantum science. So what's really important is the basic concepts, ideas of the quantum science or say quantum physics. So now these are really important. Unless students have to understand that, it's very difficult to understand and appreciate the technology. So I think this is very important. I think one step that Gujarat Science and Technology has already taken is this quantum science and technology kit. That's really good. But some of the publications, films and TV programs, PPTs, so which will help these students and teachers. Next suggestion would be that say we need to really, now organize training programs for teachers. Students interact most with teachers. If that is the case, that it is the teachers who should really understand some of these concepts and some of these ideas so that they can pass on these to students. We don't have that kind of programs. Neither at school level nor at college level or something like that. So I think now it's really very necessary. One thing is that we do have people in Gujarat and also elsewhere who can really transmit these concepts of quantum science and technology. I agree, there are few, not many, but still there are quite a few. So I think now we should really take up these two things in right earnest. Okay. So I think these two things I think we should take up with priority.
Thank you so much, sir. Sir, Dr. Kamble sir is a very great support to our Gujarat because he belongs to Gujarat and he served a long time at Department of Science and Technology, Ministry of Science and Technology, Government of India. After his retirement, luckily he settled in Gujarat in Ahmedabad and we are taking maximum guidance and mentoring from him. As sir suggested two things, like developing of resource material in a regional language Gujarati, we have taken care of. हमारा quantum kit है, so 5,000 हम लोगों को इनको गुजराती करके भी सर इनको distribute किया, training किया, and that is one of the mandate of all regional science center and district science center. They are all our day-to-day activities, not in like English or something. That is Gujarati, but we will be taking it a policy and a practice that we will be developing much more and more these things. Communication, resource materials and things. And the second point, sir, जो teacher training program, it's a very authentic, sir, very requirement. Unless until we can't train the teachers, we can't reach thousands or millions of students. So that, sir, we have taken. In fact, with our team, we have given that mandate that every year we have to, through our Science City and district regional science center, we have at least 10,000 teachers qualitatively across the year. So to train qualitatively and quantitatively also in different aspects of science, technology, innovation, STEM, all these things, so that they can be resourceful to their schools and campus. We'll seek your guidance, and in fact this we have taken all the database of all our esteemed delegates and dignitaries attending this program. And our team and department is open also to such ideas, and any time we have to take the support and expertise of yourselves. Thank you.
ये मैं डॉक्टर राजीव कुमार सरावगी, BHU से PhD किया, फिर प्रोफेसर भी रहा, रिजाइन करके संघ का प्रचारक हो गया था, और फिर 8-10 साल आध्यात्म में मतलब रमन महर्षि, तिरुवन्नामलई, गंगोत्री वगैरह साधना में 10 साल घूमता रहा। फिर मैंने, शायद आप लोगों ने सुना होगा, मैं दूंगा नया भारत करके हमने मूवमेंट पूरे देश में शुरू किया था। मैं दूंगा नया भारत 2012, और पूरे देश में, गुजरात में भी हमारे उस समय 2007 में काफ़ी लेक्चर हुए पब्लिक। फिर मैं 12 से टोटली इंट्रोवर्ट होके 12 साल से पहली बार कहीं बाहर निकला हूँ। सन 12 से 25 तक मैं टोटली रिसर्च, जो भारत का अध्यात्म और सब चीज़ों को ये इंटीग्रेटेड फॉर्म में एक नए उसमें लाना चाह रहा था। इस सब पूरे हमारे 25 साल का रिजल्ट हम एक शब्द में बता दें तो बिहेवियर इज इन्वर्सली प्रोपोर्शनल टू ऑनटिक, ये हमारा पूरा हमने निकाला। ऑनटिक यानी एसेंस ऑफ कॉस्मोस इसको कह रहे हैं, और मैं इसको E=mc² को चैलेंज करने वाला हूँ। आगे आपको मजाक लगेगा कि मैं ये कह रहा हूँ कि क्योंकि उसमें उन्होंने ये ऑनटेक जो एग्जिस्टेंशियल मेन चीज़ है उसको इग्नोर किया है पूरा, और इसमें इस बात को हम इसमें हर चीज़ को वेयर ये इन्वर्सली प्रोपोर्शनल टू और ऑब्जर्वर इफेक्ट है, हाँ, और वेयर कांस्टेंट है ऑनटेक इसमें। तो बिहेवियर के अंतर्गत सारा स्पीसीज और जितने भी पदार्थ हैं सबको इसमें लिया है, क्योंकि कॉस्मोलॉजी कॉस्मस फॉर्मूला है ये कि बिहेवियर ये कॉस्मस की हर चीज़ को एक्सप्लेन करेगा कि बिहेवियर इज इन्वर्सली प्रोपोर्शनल टू ऑब्जर्वर इफेक्ट वेयर ऑनटिक इज कांस्टेंट। इसको अब मैं बच्चे के बारे में ये बताऊं कि उसने वाई कॉम्बिनेटर में उन्होंने इनवाइट इसलिए किया है कि उसने कहा है कि हम एक नेक्स्ट स्टेज ऑफ AI बना रहे हैं। तो 3 महीने से उससे कांटेक्ट चल रहा था, वो कंटिन्यूस इंटरव्यू में था। हमें नहीं लगा कि भारत में हम किसी को अप्रोच करके उसे बता सकते हैं, उसका यहाँ यूज़ कर सकते हैं, उसको अपॉर्चुनिटी मिलेगी। तो मैं रोके हुए था, संघ का बैकग्राउंड है आप समझ सकते। अंत में मजबूरी में हमें उसको कहना पड़ा कि जाओ तुम अमेरिका। अब आपके पास है, अगर आप सही जगह तक बात पहुंचा सकें, उस बच्चे को बुला के सही उसका इंटरव्यू वगैरह, जो मैं जहां तक जानता हूं इतनी नॉलेज के हिसाब से, डॉक्टर राजाराम यादव जी और हमारा पहला अपॉइंटमेंट एक साथ हुआ था, और इन्होंने ही कहा कि आप आइए यहाँ, आपकी बात कहने का मौका मिलेगा। और तो जब रिजाइन किया तो यही मार्गदर्शन के रूप में इनसे हमारा कई दिन डिस्कशन चला। तो इन्होंने हमसे एक बात कही कि देखो, छोड़ने के पहले एक बात सोच लो, जीवन में सफलता असफलता दोनों मिल सकते। और ये बात 92 की है जब दोनों का अपॉइंटमेंट हुआ था। आज इतने समय बाद हम संतुष्ट हैं। इन्होंने हमसे एक बात कही थी, और ये बात हम सबको सुनाते रहे 30 साल तक, कि आप छोड़ना छोड़िए। ये बात सोचना, जीवन में कुछ भी नहीं कर पाए, सब जगह फेल हो गए, तो भी ये समझना कि आप पश्चाताप तो नहीं करोगे कि हमने छोड़ दिया। क्योंकि मैं 24 साल में फर्स्ट अपॉइंटमेंट था पूरी फैकल्टी का, आप समझ सकते कहाँ होता हमारा। 24 साल की उम्र थी और फैकल्टी का, फाउंडिंग यूनिवर्सिटी का फाउंडर अपॉइंटमेंट था। और बाकी संबंध के हिसाब से तो आप बाकी अंदाज लगा ही सकते हैं आप लोग को कि क्या बैकग्राउंड रहा होगा। तो भार्गव जी के कहने से हुआ था सीधा हमारा। तो अब मैं आपको इतना बताऊं कि उस बच्चे के लिए आप क्या कर सकते, उसे रोक सकते। और वो एक दो महीने में ही वाई कॉम्बिनेटर की तरफ से उसको इनविटेशन हो गया। 5 करोड़ उन्होंने अभी दिया है और कहा है कि 50,000 करोड़ रुपए हम दे देंगे तुम्हें रिसर्च के लिए, हमें कुछ बेसिक करके दिखा दो इतना। और फर्स्ट स्टेज में तो उन्होंने हो ही गया है। तो वो AI को नेक्स्ट स्टेज ऑफ AI संक्षेप में, और सोवरन AI की तरफ बढ़ने की बात कर रहा हो। बाकी इस बात को सही जगह पहुंचाने का शायद ये मौका हो आपको।
थैंक यू प्रोफेसर डॉक्टर राजीव सर। हम लोगों तो आपको बधाई देना चाहते हैं कि आपका जो जर्नी है इट्स ए लर्निंग लेसन फॉर एवरीवन। 12 साल तक आप BHU जैसे प्रतिष्ठित यूनिवर्सिटी को छोड़ करके आप इतने लाइफ का रियल फ्लेवर को ढूंढते आप फिर आए हैं। एंड वी आर वेरी हैप्पी दैट आपका नेक्स्ट जो ऐसे पब्लिक पार्टिसिपेशन हमारा गुजरात साइंस सिटी में हुआ, तो मैं आपको बधाई देना चाहता हूँ एंड आपका पूरा सीखना चाहता हूँ। एंड आप जैसे बताएं जो स्टूडेंट हमारा प्रदेश में हैं, काम कर रहे हैं, मैं आपसे आपके इनके डिटेल ले लूँगा, इनका ईमेल, इनका कॉन्टैक्ट नंबर डिटेल सब ले लेंगे। एंड हमारा काफ़ी जो प्रोग्राम के हिसाब से एंड इनका जो डोमेन एक्सपर्टाइज जो है, इंटरेस्ट है, इनके साथ हमारा यहाँ पे जो यूनिवर्सिटी जो इंस्टीट्यूशन जो काम करते हैं, तो इनके साथ में इनका ये बातचीत करा करके तो इनमें जो नतीजा निकलेगा तो ये हम लोगों ऑनरेबल मिनिस्टर साहब के सामने में हम तो इन गाइडेंस के तो जैसे हमारा तो काफ़ी पॉलिसी वगैरह चलता है, मैंने रहता है, तो इसमें सपोज कहीं पे फिट होता है तो वी आर विल बी वेरी हैप्पी टू ब्रिंग बैक आवर यंग टैलेंट फ्रॉम द अब्रॉड टू इंडिया। एंड सपोज मिनिस्टर साहब, ऑनरेबल मिनिस्टर, हमारा गवर्नमेंट पे जो भी हमारा मार्गदर्शन रहेगा तो इसके हिसाब से, बिकॉज ऑनरेबल पीएम साहब भी वही बोलते हैं, जो ब्रेन ड्रेन था अभी वो ब्रेन गेन हो रहे हैं। जो हमारा ब्रेन ड्रेन के हिसाब से जो पहले हमारा टैलेंट बाहर जा कर के काम करते थे, अभी वो हमारा गवर्नमेंट में, भारत सरकार में, स्टेट गवर्नमेंट में, वो सारा हिसाब से अभी वापस आ रहे हैं। एंड यहाँ पे काफ़ी इंस्टीट्यूशन होता है। वी विल बी वेरी हैप्पी ऑल्सो टू शेयर दैट हमारा जो गिफ्ट सिटी है वहाँ पे 4 फॉरेन यूनिवर्सिटी का कैंपस वहाँ पे है। तो हम लोग इमेजिन नहीं कर सकते कि हमारा बच्चे तो जाते थे, नाउ फॉरेन का यूनिवर्सिटी हमारे यहाँ पे आ रहे हैं। तो दैट द रिवर्स इंजीनियरिंग का रिवर्स ट्रेंड अभी चल रहे हैं। तो विल बी डेफिनेटली सर सीक योर support to understand and to have establish a contact with our young boy, and we will try our best that what thing can be possible. Thanks.
We sincerely thank our esteemed dignitaries for addressing the audience question with such clarity, also the audience for their active participation. Now, I would like to invite Dr. Narottam Sahu, Advisor GUJCOST, to present a memento as a symbol of our gratitude to Shri Arjun Modwadia Sir, Honorable Minister of Science and Technology, Forest and Environment and Climate Change, Government of Gujarat. Thank you, sir. To formally conclude the session, I now invite Shri Vimal K. Patel, GAS Executive Director, Gujarat Science City, to deliver the vote of thanks.
आज गुजरात साइंस एंड टेक्नोलॉजी डिपार्टमेंट की एक HOD गुजकोस्ट द्वारा ये साइंस कम्युनिकेशन कॉन्फ्रेंस फॉर पब्लिक अंडरस्टैंडिंग ऑफ क्वांटम साइंस एंड टेक्नोलॉजी का 2 दिन का वर्कशॉप सेशंस आयोजन किया गया है, जिसमें हमारे निमंत्रण को मान देते हुए यहाँ पे हमारे बीच में उपस्थित साइंस एंड टेक्नोलॉजी डिपार्टमेंट गुजरात गवर्नमेंट के माननीय कैबिनेट मंत्री श्री अर्जुन मोढवाडिया जी सर, अर्जुन मोढवाडिया सर जितने भी हमारे ऐसे प्रोग्राम्स रहते हैं उसमें उनका जितना भी एक्सपीरियंस है साइंस रिगार्डिंग, उसमें हमको इतना अमूल्य मार्गदर्शन देते हैं। और आप सबने देखा कि इन एडिशन टू दैट सर हैज़ स्पेशल कंडक्टेड इंटरेक्शन सेशन। अगर हम यहाँ पे 7वीं साल के बच्चे 7th स्टैंडर्ड के बच्चे से लेकर कोई भी हायर लेवल तक का यहाँ पे सेमिनार होता है तो हर एक लेवल के पार्टिसिपेंट के साथ सर खुद इंटरेक्शन करते हैं और इतना अमूल्य समय देते हैं। तो सर कंटिन्यूसली गाइडिंग अस एंड ये मार्गदर्शन के लिए हम बहुत आभारी है। थैंक यू वेरी मच सर। साइंस एंड टेक्नोलॉजी डिपार्टमेंट की जितनी भी HODs है उन सभी HODs को एक पर्टिकुलर लेवल तक ले जाने के लिए सर कंटिन्यूसली हमको गाइडेंस देते हैं सर, रियली थैंक यू। साथ में नरोत्तम साहू साहब जो गुजकोस्ट के एडवाइजरी है, पहले इन गुजरात स्टेट ओनली साइंस एंड टेक्नोलॉजी डिपार्टमेंट द्वारा ये साइंस सिटी रची गई। उसके बाद गुजकोस्ट का जब से निर्माण हुआ है, गुजकोस्ट ने गुजरात स्टेट के जितने भी जिले हैं उस हर एक जिले में एक रूट तक ये साइंस एंड टेक्नोलॉजी का जो गुजरात साइंस सिटी है उसका एक स्मॉल स्केल पर ले जाने का निर्धार किया है और काफ़ी हद तक साहू साहब इसमें सफल हुए और आने वाले बहुत कम सालों में ऑलमोस्ट हर एक डिस्ट्रिक्ट में ये सेटअप करेंगे। इसका सबसे बड़ा बेनिफिट ये है कि जो साइंस स्ट्रीम में पर्टिकुलर जो ड्रॉप आउट होता है उसमें साहू साहब गुजकोस के माध्यम से हर एक लेवल तक पहुंचते हैं। ऐसे ऐसे ट्राइबल डिस्ट्रिक्ट में ऐसे पहुंचते हैं कि जो साइंस का रियल यूज़ यहाँ पे होता ही नहीं है, वहाँ पे भी उन्होंने इस चीज़ को उजागर किया है। तो साहू साहब, फॉर योर ग्रेट इनिशिएटिव एंड कंटिन्यूस एफर्ट, वी आर रियली थैंक यू। हमारे साथ मनोज कुमार सर है, जो इंटरेक्शन में आपने देखा कि सर का वैल्यूएबल गाइडेंस हमको मिला है। सर, वी आर थैंक यू। साथ में साथ यहाँ पे अक्रॉस द इंडिया जितने भी स्टेट्स के डिग्निटरीज आए हैं साइंस एंड इंजीनियरिंग पार्ट से, और हमारे स्टेट से भी जितने भी डिग्निटरीज हैं, उन सबको इस 2 दिन के कार्यक्रम को सफल बनाने के लिए, इसको सक्सेस देने के लिए जितने भी पार्टिसिपेंट किया है, उन सबका मैं आभारी हूँ। थैंक यू वेरी मच। थैंक यू ऑल ऑफ यू।
Thank you, sir. I request everyone present over here to kindly assemble outside for a group photo.
A tough, wonderful occasion. And if you carefully notice that morning when the minister spoke, he mentioned one line: science communicators should simplify science without losing the intricacies of the content of science. That is a very crucial thing in science communication. And when the new technology comes, we also, as science communicators, we take to new technology and we simplify it. That's the purpose of this conference. Quantum technologies for society and challenges in public communication. Have you put that? Next slide. Yeah. We have, I'm skipping some of the portions that bit versus qubit. A normal bit is like a switch on and off. A qubit is like a dimmer, many states at once, like a coin with head and tail tossed in the air. We won't know that which is head or which is tail. What is it? It's not working? Some problem? It's not working? Okay. Quantum technologies, just set it right. Quantum technologies harness quantum mechanics, superposition, entanglement for computing, communication, and sensing. Superposition, that is existing at both 0 and 1 at the same time. Entanglement, 2 or more qubits get linked. Tunneling can pass through energy barriers. Just can I operate from here? It's not working. Go to the previous slide. When I move the slides or show like this, you go to the previous slide. Quickly, sitting there. Can I operate from there? Go to the previous slide. Yeah. Operate it. I'll go ahead. It's, I think, third or fourth slide, and come to that. And branches of quantum technology, we say that quantum computing uses qubits to solve complex problems. Quantum communication uses quantum state, often photons, to transform information with unbreakable security. Then quantum sensing takes advantage of quantum properties to measure physical qualities like time, gravity, and magnetic field with high precision. And the last one is the simulation. We can, by using simulation, even the drug discovery, we can combination of molecules. We can discover new types of drugs. Social impact of quantum technologies. Can you go to the slide? Social impact, fifth slide or so. Fifth slide or so. You moved from there. It's not moving, I think. It's now moving? Moving slowly, I think. Let's go ahead, go ahead. And the simple thing is that if you say that slightly a fast stretch before fifth or sixth slides as moves faster. Slightly a far fetched of quantum tunneling is that example is that in the Harry Potter series we get a scene always that platform 9 3/4. Harry Potter enters the wall and without spending energy he crosses the wall to enter the train, to catch the train to go to his place, to his boarding school. Quantum impact of social impact of quantum technologies. One thing is that the detection of cancer at an early stage and neurological disorders at an early stage is very much there. And quantum enhanced sensors can improve prediction like earthquake, tsunamis, extreme events by detecting subtle geophysical changes. Improves water resources and underground water resources and movement of water we can find. Helps locate minerals and energy resources. Strengthens national security even without GPS. Enables high accuracy medical imaging. And MRI and quantum technology. And if you see MRI and quantum, MRI is one of the earliest version of use of quantum technology. MRI scan is one of the, and it uses the real world application of quantum technology by the magnetic field, and the signals depend on how long nuclear spins maintain quantum coherence and how they relax, which determines image contrast between tissues. And as quantum technology advances, the magnetic field, even with the reduced magnetic field, you can have MRI scan. Now with the high magnetic field, some people find it difficult to undergo the process. Public communication, why it matters? The quantum technologies are complex and is misunderstood by the general public. Often it's misunderstood by the public. Clear communication is needed to foster trust, encourage ethical use, and ensure equitable access. Can solve problems which were previously considered insurmountable. Concept like teleportation, that is moving from one place to another, skipping a particular portion of the distance, parallel universe, as we see in Avatar and other movies, and time travel are impossible in classical physics, are deemed possible in quantum physics. And in the realm of fiction, starting from H.C. Wells' time, entropy means that noise or disorder in communication. Reverse entropy lets objects or people move backwards in time. That is already shown in movie. And next, if you take example of Ant-Man, suggests particle exists in multi-state at once, inspiring the idea that multiple realities can coexist. That realities exist in multi-state, and the idea that multi-realities can coexist. The many worlds interpretation proposes that every quantum outcome creates parallel universe instead of a single collapsed result. And the parallel universe, starting with Avatar, we have often faced that, seen that. Quantum decoherence explains why these parallel worlds do not interact and appear as one stable reality to observe. And in this film, depicting a character accessing many possible lives across universe. Next, Avengers Infinity War. Dr. Strange sees 4 lakhs odd possible futures, quantum entanglement, connection across distances. Future depends on many possible outcomes. that has been shown in this movie Avengers Infinity War. In the film Primer, widely considered as one of the most scientifically rigorous time travel films, Primer features a box that creates a recursive time loop. This film is more rigorous as far as the science is concerned. Example from film, that another example is that quantum gravity, this interstellar quantum gravity suggests there must be higher dimension beyond length, width, and height. Interstellar attempts to reconcile quantum mechanics with general relativity. The protagonist enters tesseract inside a black hole, a 5-dimensional structure where time is represented as a physical spatial dimension. He communicates with the past via gravitational waves, which are theorized to be able to cross dimensions. The convergence, the next big leap, and some of the scientists are saying that within 3 years, the quantum technology will take a great giant leap, and there will be convergence with artificial intelligence and its application in the terms of robotics. And quantum sensors will revolutionize health, early disease detection, navigation, Earth observation with extreme precision. The quantum and AI, faster training of complex AI models and improves optimization. Even AI itself is fast, but we can have a very fast thing. To start with a simple example, if an ambulance wants to reach a particular spot, the multivariate routes can be very easily given by quantum technology, much better than AI. AI and robotics, robots that learn, reason, and adapt like humans, that is an additional thing, AI and robotics. Now combined with quantum, AI and robotics, intelligence systems for space missions, climate actions, national security, and smart cities. For instance, even morning it was referred that climate modeling, how the climate change will, even it's still, in spite of the advancement in the knowledge of climate change, still we are not very sure that how the climate modeling will really work in the real world situation. We may predict a particular model, this will how, in this particular scenario, this will work, this is the situation. But still it may go haywire because of some other variables which we might not have taken into account while predicting. But with the quantum technology, these loopholes can be seen. Quantum technology offer transformative potential but require responsible public communication. Addressing communication challenges is vital for societal acceptance and ethical deployment. Quantum technology is shaping the future of computing, communication, sensing, and science itself. With thoughtful collaboration between scientists, educators, industry, society, quantum technologies can be harnessed for a secure, equitable, and sustainable future. Last slide. Science communication. When it comes to science communication, how the quantum technology has to be dealt with, science communication discusses ethical implication and societal impacts. The focus of science, instead of just talking about the science, how the society accepts it, and including context and culture, the science communication deals with. Explain what technology does and does not do. Clarifies appropriate use, risks, and limitations. Helps counter misleading claims about quantum technologies. Treats public as partners, not as passive recipient. Public, they like to engage with public, and that's how that's to be. And we had an excellent discussion in the previous section, And I conclude with the same point the minister said, science communicators should simplify science, but they should not lose the intricacies of science when they do it. Thank you so much. Taking a few questions. Yeah, are we taking a few questions? Okay. How do you? With communication. Public communication. And it has been the great, Manoj Pataria ji was my mentor. And as communicators, we have always taken to science, whether it's green revolution or probably the space science, the all dominant community, or it's a climate change, new area has come. We have always taken to that thing, which we have taken to those areas and we have done. Now the quantum technology has come and artificial intelligence, many of the communicators are now working in artificial intelligence. Now this new technology has come. There's science communication people should take to it in popularizing it and do research, what are the intricacies in that and what are the misconceptions people have and what way if it's communicated, if it's a role play or probably if you simplify with a certain analogy, people can understand it better. We should devise mechanism to simplify and take it to the people. So we can, science communicators, we can get across the correct information to the people. Next thing is that certain misconception people have about the technology also, we can clear it. Sometimes people do not take to technology because they are skeptical about it. That as AI, the recent previous technology is AI. Now many communication organizations have trained the communicators to talk about AI so that people take to AI. That has made a difference. The same thing, it should be passed on to quantum technologies so that communicators take it and simplify it and so that people's acceptance is there. Thank you.
Thank you, sir. Despite of technical issues, you managed the situation seamlessly and presented your keynote address with great clarity, sir. Thank you very much. Now I would like to invite Professor Manoj Kumar Pataria, President, International Science Writers Association, to felicitate Professor Arul Aram, Anna University, Chennai. Thank you, sir.
We now proceed to an expert talk to be delivered in virtual mode. It is an honor to welcome Professor Puneet Kumar, University of Lucknow.
आवाज आ रही है तो मीटिंग के लिए
Okay. Uh, Shall I start now? Shall I start? Hello? Shall I, shall I start now? Good afternoon. So, uh, at the outset, I would like to apologize for not being there with you in person. And I would like to thank the organizers for allowing me to be before you on in an online mode. So, as you all know, today I will be talking with you on a quantum revolution, since it has completed a century. So, the title of the talk is A Century of Quantum Revolution and Communicating Science and Technology in the 21st Century. That is how we can utilize the quantum technology in science communication and why science communication is necessary for the quantum technology. So basically, quantum theory is the one of the most accurate scientific frameworks that has been created. And over the journey of 100 years from atoms to the information theories, we are transforming from understanding to engineering quantum systems. And the quantum technologies that are in development will shape the computing, security, sensing, and all the artificial intelligence technologies. So basically, quantum science is the study of basic particles, treating matter as a bundle of particles. And the core idea is the quantization, that is, energy comes in bundles. And these bundles of energy have some uncertainty properties in them. And a superposition of such system can exist in multiple states simultaneously. And these states entangle. So why these quantum seems strange? Because sometimes the matter behaves like a wave, sometimes it is like a particle. And in terms of physics, if I say it travels in the form of a wave and is absorbed and emitted as a particle. So whenever we measure changes in a system, the observer is important. Quantum mechanics gives importance to an observer. It's the observer who perceives the thing. In this way, it is quite close to the biocentric theory, where it is believed that it is the human beings who have created the universe as per their requirements. And similarly, the Indian philosophy also says that it is the human being which is more important. So let's start our journey. There were some basic physics phenomena that were not being able to be explained on the basis of the wave theory. And these were the photoelectric effect. That is, when light strikes a metal surface, electrons are emitted from the surface. And similarly, there was one Compton effect. Whenever light falls on a is scattering material, its wavelength changes. And the third one was that the spectrum of a black body radiation was not explained on the basis of the wave theory. So Max Planck, he was a German scientist from the Kiel University, which is near to the Denmark border. He came with an idea that energy comes in discrete quanta or bundles of energy, that he called quanta. So on this basis, he was able to explain the energy spectrum of coming from a radiation source. Adding to it, Albert Einstein explained the photoelectric effect on the same principle, treating light to be a bundle of energy. And for this, he also got the Nobel Prize. And later on, Niels Bohr gave the atomic theory, that is the quantized atomic orbits that you have read that only those orbits are allowed whose angular momentum is an integral multiple of h by 2 pi. Further, Louis de Broglie came with the concept of matter as a wave particle properties. Then Heisenberg and Schrödinger gave the matrix mechanics and treating it as a particle. And here I would like to add that Heisenberg and Schrödinger were quite influenced by the Indian philosophy, and they were in association with Rabindranath Tagore, wrote some books on Indian philosophy in 1922. So their research was also based on the concepts that the Vaisheshik school of Indian philosophy shows. Then Max Born gave the probabilistic interpretation of the wave function. The wave function is a closed envelope of the energy of the particles. So then, after the final structure of the atom came into existence, it started the first quantum revolution, which was on an atomic scale. It unlocked the structure of the atoms and molecules and explained the chemical bonding, and the periodic table was constructed, and it revealed why matter is stable and doesn't collapse. So this was a foundation for the semiconductor physics and the solid state theory. The time period for this was between 1920 to 1950. And during this period, the semiconductors, that is the transistors, the microchips, and the computing revolution came into existence. The lasers were invented. The magnetic resonance, the NMR, MRI, medical imaging came into existence on the same principles. The nuclear physics advanced, and the reactors, detectors were developed, and the quantum optics also came into existence. So the everyday technologies that we are empowered in the first quantum revolution were the transistors, the LEDs and the laser diodes, the GPS clocks, the digital cameras, the use of the photoelectric effect in the solar cells, and the quantum conversion of photons to electrons, and medical imaging that we just. After this, the second quantum revolution came, which was slightly different. It started in about 2000, and it transformed the first quantum revolution into the second through the amalgamation of the information theory. It exploited the ability to manipulate the individual atoms, ions, and photons, and creating the information in a new unit called qubit. And the applications of such information technology lies in the quantum computing, quantum cryptography, etc. So I would start with the very first basic principle, that is the quantum superposition. Basically, a quantum system can exist in a multiple states simultaneously. On the right, you can see there is in this figure, there is an electron spin. I can align it in any direction by varying the field around it. In classical computers, you have 0 and 1. The only two binary digits are possible. Here I can have any number of orientations of the electron spin. It can have multiple orientations at the same time. So this enables more memory, more precision, and more capability of transforming the information. And the two qubits can be superimposed like this. This is a block sphere representation of the qubits. The other phenomenon is quantum entanglement. It gives a strong correlation between particles regardless of the distance. If I am sitting in India and one of my colleagues is sitting in US, and if I do some process here classically, and he is also getting the influenced by it, like you can see, there are two spheres. When one switch is pressed, the other automatically does the same phenomena. In some early movies in Indian cinema, they were movies that they are twins. And if one starts sweeping, the other also starts sweeping. So that is a kind of content entanglement. We can transfer the property of the system from one place to another without actual motion. And such a technology has been demonstrated. It has not come into practice right now, but it has been demonstrated in one of the experiments which was conducted in IIT Delhi in about August this year. Now let's come to quantum computing. Like I said, the unit is qubits. The information unit is qubits. And in the classical, it was bits. And it is due to the infinite number of the alignment of the spin, electron spin. Here, some special algorithms have been created. These are Shor, Grover, and quantum simulation algorithm. The second one, Grover, needs a special mention here because this algorithm is based on the Sanskrit grammar. The grammar which was given by Panini, the Sanskrit grammar, the algorithm has been constructed on the basis of that Sanskrit grammar notations. Now, why quantum computer matters? Like I said, we can have any number of orientations of the electron spin. So we can have more switching states limited to 0 and 1 in the classical sense. So this will accelerate the calculations. So the complex calculations involved in simulation of the drug designing, material engineering, chemistry, weather forecasts and all will become much easier because the processing will be much faster. The other application will be the quantum communication, the quantum key distribution, which will secure keys in the quantum state, the dropping due to the measurement disturbance, and the long distance quantum repeaters and entangled satellite links. The quantum sensing and the meteorology, the atomic clocks, the standardization of the time will be more accurate with these kind of quantum devices. The gravity, quantum gravitometers will be there to map the earth fields, all the fields, especially the magnetic fields. The quantum materials, like we are getting into nanochips now, the miniaturization of the devices in our hand. The mobile is getting lighter and lighter, smaller and smaller, and the functions are also increasing. So we need a micro level chips. So we need high density semiconductors for those. And in that high density semiconductors, the interparticle distance will be very much less, and it will be on the scale that the wave functions of the two particles will overlap. And at those scales, the quantum mechanics come into picture. The statistical distribution of the particles become quantum. And if we talk of the interstellar medium or the semiconductors, the medium is quantum in all those scales. So the key milestones of the 21st century are the quantum supremacy demonstrations by Google and IBM, and the rapid progress on scalable qubit architectures, satellite-based quantum communication. This satellite-based quantum communication requires the ability to communicate through high-density ionic medium present in the interspace. So that high-density medium is quantum in character. It is in physical sense degenerate. And the industry growth has been given by IBM, Google, Intel, and other startups. Especially, I would like to mention about IBM. If you want to work on an want to test how a quantum computer will work, you can go on the IBM supercomputer through your desktop, and about 10 or 15 minutes, you can work on that quantum computer. It's free of cost, and you can see how it works, what is the speed and all. So now we are in an era of quantum race. All the nations are investing billions in quantum technologies. US Nation is quantum initiative supports. A European Union has also given projects on quantum technologies. China has also given is spending huge on quantum technologies. And as far as the Indian scenario is concerned, it was started in 2017 by the Interdisciplinary Cyber Physical Systems Division of the Department of Science and Technology, and they launched the Quantum Information Science and Technology Program. And later in 2018, they renamed it as the Quantum Enabled Science and Technology. And a capital outlay of 8,000 crores was provided for a period of 5 years. And the nodal agency for this is the Center for Development of Quantum Technology. And this is still going on, this project. Now we come to the role of the science communicator here. Since we are in the age of information technology, high speed computing, information is there everywhere, all kinds of information. So ethical and societal implications are important in such a scenario. And the potential to break widely used encryption systems is required. So in such a huge data availability, the question arises about the data privacy and secure communication. So this requires a quantum ready workforce to avoid the complexities. And there is a need for the responsible development and regulation to ensure a fair access to transformative technologies. So the challenges ahead are the error correction and decoherence, the scaling up systems from tens, thousands, and millions of qubits, the cryogenic infrastructure. The cryogenic infrastructure, I mean to say that these quantum computers and quantum devices require a low temperature to work optimally. So I will be discussing it later in detail. And the public and policy maker education, which is essential for informed decision and funding. So this aspect of public and policy maker education is where the science communication comes into picture. How? Because we need to communicate the use of analogies to the simplifying complex ideas, tell stories that show why quantum matters, connect the concepts to everyday technologies, address myths that the quantum computers will replace classical computers. Here I would like to emphasize that quantum computers are not going to replace the classical computers in your homes and offices. A quantum computer, like I said earlier, will require a very low temperature to work. So that is not possible in room conditions. Only specialized systems and specialized warehouses and computer centers will be designed for those. And they will be for high scale algorithms, that means high end calculation, which are today not possible even by supercomputers. Or supercomputers, they take 3 or 4 days to give the output. So such simulation codes can be run on these quantum computers. So for using these quantum computer, you have to give the input data through a physical computer that exists in your office or in your home, and you will retrieve the data from the supercomputer through the same device. So the classical computers will always be there. They are not going to replace. The quantum computers are going to assist these classical computers in high-end performance calculations and simulations. So the myth that quantum computers will replace these and there will be lesser manpower required is all myth. and science communicators should come forward for communicating this to the public. So, keeping this, the quantum literacy is quite important. Public needs to know about this quantum technology because these are the technologies that will drive future industries and jobs. When seeing about 20 years back, nanotechnology was a watchword. Everywhere people used to talk of nanotechnology. And it was said that all the effects are quite observed on the nano scale, but the reason why they are significant at the nano scale was not known. When people worked on it, they realized that these are the atomic, we are talking of the atomic dimensions, and this is nothing other than the quantum mechanics that has been developed about a century ago. So that nanotechnology has transformed itself into quantum technology, what we are using today. So quantum technology is not a new word. It is not a new miracle that has come overnight. It has taken over a century to develop from the concept what Max Planck gave to the present state of the technologies. So a public understanding is quite necessary and it will shape the policy, investment and regulation. Like last week, the nuclear policy, the Shanti Bill has been passed. That is for the nuclear technologies. Similarly, a policy for the quantum technologies will come out of the National Quantum Mission in future. So before it comes, the masses have to be told about exactly what is quantum technologies, what will be the effects, how we have to prepare the students for the STEM and the quantum careers because it will encourage the innovation, entrepreneurship, and economic growth. Because in the era of these quantum technologies, the students will develop skills for these quantum devices. And this is possible only when they are equipped with the information that why quantum and how quantum and will it now be replacing the classical devices or they will be advancing the classical devices. So the future will be a fault tolerant quantum computers capable of practical large scale tasks aided through the classical computers. And the quantum enhanced artificial intelligence and machine learning, improving the pattern recognition and optimization. Low loss quantum networks enabling secure global data transfer. And the commercial quantum sensors for navigation, health, and earth science. And new quantum materials enabling breakthrough beyond classical limits. All these technologies will be aiding the classical technologies. They will not be replacing exactly because we cannot directly intervene with the quantum devices. We need a classical device to communicate between a human being and the quantum device. So basically, it is a century in perspective from the abstract theory to the global technology industry. And the quantum revolutionized our understanding of light and matter because it has developed into a theory that light and matter have a dual nature. And this is now reshaping our computing networks and measurement tools. And the next century will bring deeper insight into it. So basically, what I talked about is the quantum revolution is accelerating these days, and the technology built on quantum principles will reshape every sector, right from the small mobile phone to the supercomputers and the quantum computers. Everything will be reshaped on these quantum scales. But the classical devices will be required to communicate between the human being and the quantum devices. And the result will be a clear communication that will empower the society to adopt and guide these changes. And the breakthrough will come from today's learners, researchers, and innovators. And the role of science communicators is necessary to educate the masses about the myths that are being spread altogether. So I would request all the science communicators present here to design their communication skills in such a way that the exact quantum information is given to the public, be it any kind of media. So the exact information is necessary to be delivered, because in the era of quantum technologies, more than 50% of the information that is being communicated to the public is not right. So I would request all of you to give the transfer the exact information through whatever information channel you are using to the masses. And I would like to end here with this request to you all. If you'd like, we can have a short discussion. I can't get. Can you deliver it to me? I didn't get the question. No, what I can guess is that he's talking about the uh, time aspect of this quantum computations. Actually, since I said that it will be based on a structure of a wave function, so wave function is a mathematical notation of a quantum phenomena. It's like every energy particle, there is a particle distribution and particle aspect that has been described by the wave function. And the mechanics already exist. It's a theoretical physics, and full mathematics exists. We can predict the nature and all through the quantum calculations. But like you said, the uncertainty is there. The uncertainty is always there in quantum physics. The uncertainty principle, like you pointed out, the uncertainty will be there. but the quantum mechanics is now quite advanced. The quantum field theory and quantum electrodynamics, we can predict the exact nature, which is quite accurate. So, in the developed quantum systems, the uncertainty that it used to be earlier will not be there now. I think because he is not audible. So I don't know. Thank
And we noticed something in the website of International Year of Quantum Science. So when we are going through that website, there is something is missing. Actually, this session and this topic that is actually designed for that. This is not at all a technical session, and I am not going for it deep into the technical details. As I am representing the organization which is called Vijnana Bharati, that is a societal organization working for the science popularization with a tagline, स्वदेशी साइंस मूवमेंट ऑफ भारत. हमारे देश में कैसे साइंस का डेवलपमेंट हुआ, उसके लिए हम लोग क्या कर सकते हैं टू प्रमोट दैट स्वदेशी साइंस, to promote that Swadeshi science movement, what we have to do. So that is the main objective of Vigyan Bharati. So when Vigyan Bharati went through this International Year of Quantum Science website, which is hosted from the international level, when we are going through that website, there is so many articles, so many podcasts, so many things are there. But something is missing there, which is very much deeply connected with our system or our nation or our contribution. That is nothing than the one of the famous person and the entire universe, the half of the particles in the entire universe which is known in his name. So I can, from the title you can understand his name, that is Dr. Satyendranath Bose, who is the one of the greatest scientists ever produced from our country. So this session actually is a tribute to Dr. Satyendranath Bose, who is the one of the person who gave the guide, new foundation in the field of quantum science. Next. Yes. So this is the first slide which I will present in front of you. So you can read from here. This is one of the famous letter which is wrote by Albert Einstein to Satyendranath Bose before he publishing that paper which is prepared by Satyendranath Bose and he sent to Albert Einstein. This was a reply by Dr. Albert Einstein to Satyendranath Bose. In my opinion, Bose's derivation signifies an important advance. The method used here gives a quantum theory of an ideal gas as I will work out elsewhere. So this is the starting of the communication. This is the starting of a connection between Dr. Satyendranath Bose and Albert Einstein. So why this connection is established? What is the reason? And how this connection changed the world? How this is reshaped the field of quantum science, the journey. Now we are discussing about the 100-year of journey of quantum science and the relation between Satyendranath Bose and Albert Einstein, how it is influenced and how it is reshaped the entire world. So as we all know that Satyendranath Bose, one of the greatest scientists, which is greatest son produced by Ma Bharati, his birth happened on the first date of Gregorian calendar in 1894. The 1st January is his birthday in 1894. Satyendranath Bose took his birth in Kolkata, which is one of the, we can say, from where we started our all modern sciences. So in Kolkata, Satyendranath Bose got his birth, and like that he's indicating like his birthday. He was always stood first. When he took birth on the 1st day of January, he always kept that keeping in the first day of standing in the first position in his life. Like in his education, when he started from the Hindu school in Kolkata, when he took admission, and after that when he completed his admission from he took his admission from Presidency University. There is a record in Calcutta University when he completed his education. And still that record is not broken. The person who is scored the mark in his MSc degree, that is still is a record. And how it is happened? There is so many students are sitting here and teachers are sitting here. How this Satyendranath Bose life, which is a blessed life I can say, how it is impacted in his life. That is the example is, the reason is, when a person is coming to his education life or in his studies life, two things are very much important. That is, first thing is, where he is sitting. The students, the friends group where he is sitting. So Satyendranath Bose is a blessed person when he was sitting and the left and right, the students, the friends group there were sitting, they were also bright like Satyendranath Bose. That is the story of Satyendranath Bose school life or college life. When we are talking about Satyendranath's life, there is so many other names as a friends group. That is Meghnad Saha, one of the another great scientist produced from West Bengal, the Kolkata, and another great son Gyanendra Ghosh and Sailen Chatterjee. Like so many great personalities were the classmates of Satyendranath Bose in that period. And when this student, the brightest student sitting in the classroom, who will take the class? Who will give the lessons to them? There is another importance. So we can imagine that era, when we can imagine that classroom, when these brightest students are sitting in that classroom, when Satyendranath Bose, Meghnad Saha, Gyanendra Ghosh, all these students are sitting, who is coming to there to teach them? Who are the teachers in that period? So when Satyendranath Bose and they were sitting in the classroom, they were blessed because of their teachers. So here we can see the first picture, that is Acharya Prafulla Chandra Ray. When Satyendranath Bose started his classrooms, when he started his studies in Presidency College, the first year, the teacher were there to teach Satyendranath Bose, that was Acharya Prafulla Chandra Ray. When Acharya Prafulla Chandra Ray came to in his first year college life, and when he taught the basics of chemistry in his college life. And the third year, another great personality came into the picture, that is Acharya Jagadish Chandra Basu. So we can imagine that life, imagine that era when Acharya Jagadish Chandra Basu and Acharya Prafulla Chandra is giving the lectures in the classroom, and like Professor Satyendranath Bose and Gyanendra Chandra Ghosh and Meghnad Saha, they were sitting and they were studying the basics of modern science. the modern science which is started from the Western country, and when there is starting in our country where this is started from Kolkata. So that is the basic time where we started studying the modern science. And this is not the period where their contribution is started. When they completed their studies, when another person came into the picture, that is Ashutosh Mukherjee, one of the great visionary who was there in that period as a vice chancellor. Because I am telling all these stories, all this background, because when now we are sitting in this period and in this time, we have all the facilities. We are all sitting here and we have the access to everything, and we can access any international things, and we can go to anywhere for getting the knowledge. But in that era where we were there, that is in the sometime before when we are discussing, I use that word, that is the darkest period of Indian history. Recently, I got one book, and when I was reading that book, the title of that book was The Golden Road, written by one of the greatest historian, William. And the Golden Road describing about the India's contribution to the world in the best period, from the Vedic period to the 15th century. But when the 15th century is completed, or when the starting of the 16th century, the invaders from the outside our country, they came into India and they started to ruling our nation, like Mughals, like Britishers. So we can say that period from 15th century to the pre-independence era, that is the darkest period in our country. In that time, all these things are happening. In the darkest period of our country, they started to contributing. Like Acharya Prafulla Chandra Ray, Acharya Satyendranath Bose, Acharya Jagadish Chandra Basu, all these people are started working in the modern science, in modern theories. They were starting in the darkest period in our country. And their contribution, in that period, what they contributed, that is still is important, that reshaped the world. That is the story of Satyendranath Bose's legacy in the field of quantum mechanics. When he completed his studies from the Calcutta University, that is an offer from the great Ashutosh Mukherjee. They called Gyan Chandra Ghosh, Meghnad Saha, and Satyendranath Bose in his chamber. And they asked to Satyendranath Bose to start his teaching in Calcutta University. They joined in the mathematics and physics department in Calcutta University in the period of 1915 to 1920. So there were the journey of quantum, the discussion in the field of quantum mechanics is starting. In this picture, you can see the luminarities, the great personalities from Kolkata in that period, like Meghnad Saha, J.C. Bose, J.C. Ghosh, and Snehmoy Dutt, all these people, S.N. Bose and D.M. Bose. This was the group. They were studying in Calcutta University. They were the teachers in Calcutta University in that period, from 1910 to 1925 in that period. In the same time, in the other part of the world, in the western world, in the western side of the world, like Albert Einstein, Schrodinger's, all these people are working in the field of quantum theories, and their debate, their discussion is also started. So how these people are connected with this great scientists from the western world of the western side of the world, and how they establish this communication. That is the second part, that is the important part for the science communicators, science researchers, science practitioners sitting over here. These are the main foundation, these are the main contribution by Dr. Satyendranath Bose. You can see here, what is the main contributions by Satyendranath Bose. I am not going to deep into that things, because all these sessions which we are completed over here is mainly focused on that. What is quantum science? How is quantum science journey? The last session which is conducted by Puneet ji, they were deeply discussing about the last 100 years journey of quantum science. So in that quantum science period, how Satyendranath Bose is contributed? These are the main key points, like indistributable quantum particles, Bose-Einstein statistics, Planck's radiation law from quantum statistics, or how Einstein extension and Bose-Einstein condensation. All these things is already mentioned over here. But how this journey is established, how this communication is happened? That is starting by when Satyendranath Bose wrote his first paper. And there we can see, when I told the darkest period in our country, in that period there is a racism also. Still we can feel that racism. In Satyendranath Bose's life also there is some examples. When Satyendranath Bose prepared his first paper in the field of quantum theory and he tried to publish that, so many journals, so many publishers were not ready to accept that paper. That is why Satyendra Bose wrote this first letter to Albert Einstein to mentioning about his theory, his viewpoints on the quantum theories. And this was the letter, you can see here. And yes, in this letter he mentioned that you will see that I have dealt with the problem of thermal equilibrium between radiation and matter in a different way, and I have arrived at a different law for the probability for elementary processes, which seems to have simplicity in its favor. This was the letter from Dr. Satyendra Bose to Albert Einstein. And what was the reply from him? Einstein's reply you can see here. He is giving thanks to Dr. Satyendra Bose, and here is that wordings. In my opinion, Bose's derivation signifies an important advance. The method used here gives the quantum theory of an ideal gas size I'll work out elsewhere. This was the first communication between Albert Einstein and Dr. Satyendra Bose. From there, the Bose-Einstein condensate, which is one of the important theory, which is the important derivation, important contribution in the field of quantum mechanics or quantum science. And what Albert Einstein did, he translated Satyendra Bose's paper. He wrote that paper in English and he sent that paper to Albert Einstein, but Albert Einstein translated that paper into German language. That is the way Albert Einstein reacted to that. He translated that paper in the name of Satyendra Bose. He published this paper in that magazine, Scientific for Physics. This was the magazine which is publishing from France in that period. He translated into from Germany in that period, and he published in that journal. That was the first acceptance for Satyendra Bose in the field of modern science because of Albert Einstein. When the entire world, the superior people were not ready to accept Satyendra Bose's paper, but Albert Einstein came into picture and he accepted, he identified that this is a paper have an importance and we have to publish it. That's why Albert Einstein translated into German language and he published it. From there, this journey is starting. And after that, they were starting to working together. And here we can see there is one paper that is the original papers by Albert Einstein, and that is translated to English. Now we are celebrating the theory which is principle of relativity by Albert Einstein. But the entire modern world, those who are the so-called English people, the English-speaking people, how they get into this picture, how they understand Albert Einstein, this theory of principle of relativity, that is translated by Satyendra Bose into English. Albert Einstein wrote this paper in German language, but the entire world, when they were understanding that paper in English, that is because of Satyendra Bose. And here you can note there is three people, that is Meghnad Saha and Satyendra Bose, and there is another great personality, that is P.C. Mahalanobis. So here you can see the collaboration between three great scientists from our country. When Meghnad Saha and S.N. Bose, they are sitting together and they are writing a paper, and to that paper, the introduction remarks is given by P.C. Mahalanobis. So this is an example for our lifetime, in our life also. When we are trying to do something, we have to collaborate with the best people, best personalities available in that time, and to get that ideas for the guidance, we have to approach that same level of people. That is here P.C. Mahalanobis. So there were no other paper we can see in the history of modern science in India. There is three great personalities are coming together. In this level, scientists are coming together and they were published one paper. So this is one of the great example in our modern life history, modern science history. When after that, Satyendra Bose started his career in Calcutta University from 1950 to 1924. In 1924, Satyendra Bose decided to travel to Europe. He wanted to meet the new scientists, modern scientists, those who are working in the Western world. So in the year of 1924, in the first day of October, he started from Mumbai to Paris. He wanted to meet the scientists, those who are working in that period, those who are Madame Curie and other scientists over there. He wanted to work with Madame Curie in radio laboratory in France. So when he reached in 18th October in 1924 in Paris, he went to meet Madame Curie. That was an important meeting. When he met Madame Curie, they were starting to interact together. But that time, Madame Curie can't communicate Satyendranath Bose in English because she were only talking in French language. So she denied to Satyendranath Bose. Politely she denied, I can't take you into this radio laboratory in this time. You have to work with some other personalities or any other scientist, please. We can talk later or we can sit later. But Satyendranath Bose, his main induction, primary induction was to work with Madame Curie. But he never disappointed with that meeting. He stayed in Paris, he stayed with the Indian students who were studying in that France that period, and he started working with the other scientists, those who are available in that period. But after 6 months, Satyendranath Bose came back to Madame Curie after he learned the language French. After learning the French language, he came back to Madame Curie and he started to communicating with Madame Curie in French language. There were the collaboration started with Madame Curie and Satyendranath Bose. So you can, the students, those who are sitting here can make it an example. If you want to get the knowledge, if you want to get the ideas, if you want to get the new theories, principles from any language, that is the importance of science communication. Yesterday I was talking with Manoj Pataria ji. He were talking the importance of translating the science theories from different languages, from Chinese language, Japanese language, or any other languages to India, in Indian languages. And at the same time, we have to translate our ancient knowledge into different languages like Mandarin or Japanese, all these languages. That is a science communication. And we have that example from Satyendranath Bose, which is he is shown in France in 1924 to get the knowledge, get the ideas from Madame Curie. So here you can see the another one great scientist, R.A. Fisher is the left side, he is sitting, and the P.C. Mahanlabhi is in the right side. And after that, in 1924, 1 year he completed in France. He left France and he traveled to Germany to meet Albert Einstein, one of the great personality, always helped Satyendranath Bose. He reached in Germany in 1925, and he started to working with other great scientists like Niels Bohr, and he met several times Albert Einstein in Germany. And 1925, he worked around 6 months in Germany, then he returned back to India. So after returning back to India, he went to University of Dhaka. He joined in University Dhaka, which is what that time the part of the Akhand Bharat, when now it is situated in West Bangladesh. So he started his working in University of Dhaka. He established the best laboratory in that period, which is available in our country. And in 1945, Satyendranath Bose returned back to India. So this story, all these contributions of Satyendranath Bose happened in that period up to 1945. That is the main contribution. That is the legacy of Satyendranath Bose in the field of quantum science or quantum mechanics or quantum theories. So the story is not ending here. When Satyendranath Bose, maximum he contributed in the field of quantum theory of quantum sciences, and he returned back to India in 1945. How Satyendranath Bose started his other area of his interest, and how he started to working in other field in our subcontinent. When Satyendranath Bose returned to India, so before going to that, I would like to explain this slide also. How one personality, I started mentioning about the racism which was practiced in that period in the scientific community, and Satyendranath Bose was never considered for the Nobel Prize, never awarded for Nobel Prize. That is the true thing. He never awarded Nobel Prize. But his works and his theories, how it is influenced the modern scientific community. Here you can see the different scientists, including Albert Einstein, those who helped Satyendranath Bose, who co-worked with Satyendranath Bose. All these people received a Nobel Prize. And how it influenced the other person. There is 7 Nobel Prize awarded those who are worked on the theories on Satyendranath Bose. So you can see what is the importance of Nobel Prize. Nowadays, people are in any scientific conference, when the questionnaire is started, the people are studying why India is not getting Nobel Prizes. But here you can see one person who is produced 7 Nobel or Nobel Award winners because of his contribution. He never got the Nobel Prize. The Nobel Award Committee never considered him. But because of his theories, because of his works, he produced more than around 7 Nobel Award winners. This is the legacy of Satyendranath Bose. But this is not the end of Satyendranath Bose's legacy in the field of scientific contribution. When Satyendranath Bose returned to Kolkata and he started working with the different science communicating organizations like National Science Congress Association, one of the leading science movement in our country. And he started with the Asiatic Society. He selected as the president of Asiatic Society, which is situated in Kolkata. He started working with other different organizations. So the importance of mentioning Satyendranath Bose, the importance of talking about Satyendranath Bose is important because we are all science communicators. In the international era of quantum science, if we should have a role model, if we should have a icon to celebrate, that is Satyendranath Bose. Because of that, Satyendranath Bose established one of the best science organization in Kolkata, that is called Bhagya Vigyan Parishad. When he established this organization in Kolkata, he wanted to communicate science in his mother tongue. That is the importance. Yesterday when we are discussing in different sessions, all we are talking about the importance of science communication is mother tongue. So here we have the role model. When Satyendranath Bose returned to Kolkata, he started his organization, that Bhagya Vigyan Manch, and through that Bhagya Vigyan Parishad, he started to communicating science. He started to working with the different personalities, with the different session in the society. So this is the best reward for that. If somebody is from Kolkata, those who can read Bangla, he can read that wordings. That is Vishwa Parijay. The Vishwa Parijay is one of the book which is written by the greatest poet in our country, that is Rabindranath Tagore, who wrote the 2 national anthems for India and Bangladesh. The same person wrote only one single book on science, that is Vishwa Parijay. And that book he wrote because of the influence of Satyendranath Bose. When Satyendranath Bose started to working in the science communication, when he started to working to promote science, he influenced everyone in the field of science in the society, every session in the society. The friends of Satyendranath Bose were not only scientists. He influenced the filmmakers, he influenced the musicians, he influenced the persons, those who are working in the field of literature. And his connection is like this, and that because of his science communication, the great poet ever in our produced ever from in our country, that is Rabindranath Tagore, wrote this book Vishwa Parijay, and that book dedicated to Satyendranath Bose. Because of Satyendranath Bose communication in the field of science and technology, I am writing this book and I am dedicating this book to Satyendranath Bose. So if we should have a role model as a science communicator, if we should have a role model, that will be Satyendranath Bose, and we have to remember his contribution in the field of quantum sciences or quantum mechanics or quantum theories, and same time as a science communicator we have to tribute. The last 1 year we celebrated, but how many times we repeated this word Satyendranath Bose, we have to count that. And if this is not the end, we are starting. The journey is starting. When we are started this year, we celebrated the International Year of Quantum Science, and our journey will continue. In all this journey, we have to remember and we have to tribute to this great personality, Satyendranath Bose. So I thanks to all our organizers for giving this platform to remember Satyendranath Bose. Satyendranath Bose's legacy in the field of quantum sciences and his legacy in science communication. So when you are going back to your field, when you are going back to work, we have to communicate, we have to remember Satyendranath Bose to convey this. So there is a great personality who lived in our country. He contributed to the entire world. He reshaped the world in the field of quantum sciences in his way, and he is an example for us. Thank you. Thank you very much.
Thank you, sir. Now I would like to invite Dr. Narottam Sahu, GUJCOST, advisor, to felicitate Mr. Sri Prasad Amke, Regional Organizing Secretary, Vigyan Bharati and Coordinator, Gulf Countries. Thank you, sir.
For our next plenary talk, I invite Dr. Shashi Prabhakar, Assistant Professor, Physical Research Laboratory, Ahmedabad, to deliver the plenary talk. We welcome you, sir.
Good afternoon, everyone. So, I am Shashi Prabhakar. I like to work in the lab, make things work, and sorry, but I am not a science communicator, but I will try my best to communicate what I do in lab and what we try to deliver, the effort that we put in the lab. So, uh, first slide. First. Yes. So I work at Physical Research Laboratory, and I have a lab the lab name is Quantum Science and Technology Lab. And in the next few minutes, I will try to show you what we do in the lab and what we try to deliver. So why we are talking about so much of quantum science and technology? One of the aspect is due to these three gentlemen who got Nobel Prize in year 2022. And they are Alan Aspect, John F. Clauser, and Anton Zeilinger. And since I started my PhD in 2009, I appreciate what Anton Zeilinger sir was doing, and it's all due to his contribution due to the field of quantum entanglement, which includes all degrees of freedom and the effort, the thought process, the innovation that he has brought to this field. So these three gentlemen were awarded Nobel Prize in year 2022 for their contribution to quantum entanglement. Few years later, this year, UNESCO recognized this year to be the International Year of Quantum Science and Technology. Why? Because they want to bring out the awareness that everyone, which includes not only the people who can communicate science to the general public, it also put a effort, or they also putting extra belief on us that we are the person who can deliver and that can go to the society and make change to them. So the goal of this was to increase public awareness on quantum science and technology, bring the whole world where we have US, Europe, and many other nations are contributing and giving a lot of fund for the research and development in the field of quantum science and technology. So it is bringing all of them to a common platform to work. Then why? Because its application of quantum science and technology for sustainable development, and also to bridge the gap between the society and how we do science in the lab. Moving forward, there is also an initiative from Government of India. So in 2023, there was a mission announced, which was National Quantum Mission. 6,000 crore of Indian rupee were promised. And the objective of this mission was to bring all these 4 verticals, like what we do in quantum science, can we break down these 4 verticals. And what these verticals are doing is they are trying to bring new products to the ecosystem so that the quantum science will go to the society sooner
and it has 4 objectives. One, the first one is to build a quantum computer with 50 to 1000 physical qubits to have a secure communication either through fibers or through ground to satellite, or quantum sensing and metrology to have quantum advantage on how we do sense some of the parameters from the system, and quantum materials and devices. So moving forward, this is our research group, or the Atomic, Molecular and Optical Physics Division at PRL. So we have 9 labs where my lab, Quantum Science and Technology lab, is working from last 2 decades. The Photonic Sciences lab is working from last 1 decade. And then we have other labs, they have recently started or quite old, where they are working on new and different types of technology. So it's always our effort. If you want to know more about what we do in quantum science, you can refer to the website down there. So moving forward, we all talk about quantum technology, but it all comes down to the first image where we talk about classical bits, where we have, in electronics, we have TTL pulses, where we have high and low. In terms of atoms, we have ground state, excited state. But in terms of quantum, we have all the superposition states. We can, like it's on the whole Earth, we can point to each and every point on the Earth. In the same way, due to the quantum superposition principle, all these states are accessible to us. This is one of the fundamental principles of quantum technology. The next one is the mutually unbiased basis. The example is, if somebody wants to know my name, they should ask my name, not my weight, because that may be random. So it's like another mutually unbiased basis. If I and you are talking in the same language, that will make a sense. But if we are talking in a different language, it will not make any sense. So this mutually unbiased basis is another principle. And we have another thing, which is the no cloning theorem, that we cannot clone any state. Like my presentation was there. I transferred that pen drive to a lady. She put in the computer. It's now getting copied, and it may get copied thousands of times. But by using this quantum technology, your state cannot be copied fully. Okay? So these 3 principles forms the basis of any quantum technology. Moving forward, as we are talking about more and more quantum science, we need to talk about in which frequency or in what wavelength region or what property we are talking about. So we will talk about light. Light means all visible wavelength. And when it comes to light, there are few properties. You have intensity of light, you have polarization, you have these fancy modes, and we can talk about phase. So these light medium who can carry our state from one place to the other, these are the degree of freedom which is accessible to us. In terms of electronics, you have, or in terms of photons, if you do in fiber communication, you have those light in pulse form. Okay? So what we actually build upon, it's one of the entangled photon source where we have 2 photons entangled in polarization degree of freedom. So this is what we do in lab. The heart of this is a PPKTP crystal in an oven. This is a nonlinear crystal. And what it does is, if one photon hits this crystal, it gives you a pair of photons. And with some clever use of those optics, we can generate polarization entangled photon pair. The quantum state of that photon pair is HH plus VV, which shows that if first photon is horizontal, the other has to be horizontal. If one of them is vertically polarized photon, other has to be vertically polarized photon. And this plus sign in the middle actually represents the superposition. So this is one of the things that we built on the optical table. And on the right, we can see that there is a characterization which shows that we get a 97% fidelity, means the state that we are trying to generate, it is very good. And we can see it's flat, so it can generate around maybe moving forward. So this is one of the entangled photon source, which is now in a product form, which will be sellable soon. So you can see the timeline. We generated the first polarization entangled photon source is 2015. In 2017, you can see that this scientific result was published, where we have made the source in the best form, and few days back, on 10th of December, this product was released from Physical Research Laboratory. So you can see that this can generate up to 2 megahertz, means 20 lakh photon pairs we can generate at the same time, which can be used for n number of applications that you might have talked about, like quantum key distribution and all other stuff. So this product is now available. I want to highlight. So the name given to is Jonaki. Jonaki in Bengali, it's a firefly. And firefly is the brightest in dark. So this source is one of the brightest entangled photon source that is commercially available from the whole world. Okay? It is very compact, 15 centimeter by 10 by 10 centimeter product, kept on. You can put this in a small bag, travel very rigid. So this is one of the product that we have come up. Next, I want to show you so the polarization entangled photon pair they are called heralded single photon pair source. But for some of the application, we need real single photon source. So for that, this is a new activity that has started in our division, where we work on deterministic single photon source. So it's like a quantum material we put inside a cavity, the resonance is enhanced, and we get a deterministic single photon source out. So this is one of the things that we have started, and we are making good progress from this, and maybe sooner you will get another product where you get a very good single photon source from here. But why we are actually trying to develop all these sources? So these sources are just one step. We wanted to have one of the application in cryptography. So in classical cryptography, this is what does. Let's assume Alice wants to send a message to Bob. What she will do? She will encrypt it using some password, some random number, whatever, send it through the channel, and finally, on the Bob side, it will be decrypted and received. But one of the bottleneck is this random number. So, and second one is the channel. Let's assume somebody copies that encrypted key, so maybe not now, but when quantum computers will be available, what will happen? They will be surely able to copy the message and decrypt. So, our task is to make this system secure. What we did is, we removed the method of generating random number which can encrypt the key, which can be used as a key, but we want to share the key by using this quantum key distribution. So Alice and Bob will generate their own key, which cannot be known to anyone. So what we did is, what are the things we need? We need source, we need a channel, we need a protocol. In classical sense, we have TCP/IP protocol, we talk about HTTP, HTTPS, all sorts of protocol. We do research on also these protocols. We need detectors, so this is how we assemble. So we have two buildings on the Thaltej campus where we consider two rooms, one as Alice, other is Bob. Alice send to one of the reflector, the signal comes back to Bob. Here is the experimental setup. You can see that it's on a breadboard, and we have been able to demonstrate it. So this is, you can say, schematic of the experimental setup. And what we did is, we obtained the key rate of 140 kbps, which is somewhere in so it's 140 kbps, which is good enough to share the key between Alice and Bob. So here we are not trying to do the communication between Alice and Bob.
we are only sharing the key between Alice and Bob so that these key can be used later for application, for whatever communication they want to do. In this BB84 type protocol, there is always a challenge, you need a random number. But by using entangled photon pair source, we even have removed that challenge. And here, there is a person who will, so these photon pairs we can send to two persons who want to share the key. They do not have any communication in between. They have only get the photons and they will be able to share the key between them and they will be the correct ones. So here we have the same entangled photon source in the middle. One photon goes to Alice, the other photon goes to Bob, and there is a classical channel which is the normal internet will work. And what we obtained is that at some point, can you move the camera to the right side? I can see the camera feed. This camera feed to the right side, or can you remove? So here we obtained a key rate of around 1 kbps, which is again, it is also good for sharing the key purposes. And all the scientific results are getting published in well-known international peer-reviewed journals. So here I can say it was 1 kbps and other was 2 kbps. So this experiment we performed on the 8th May and 10th May of 2021. So this is even 4 years back we have demonstrated this for the 200-meter channel. So as I talked about quantum random number generator, this is one of the best quantum random number generator that we have been able to work. And here we have, so there are two things we need to have on a quantum random number generator. First, random number, and second one, we need to certify that that random number generator is good. So this system or this product which will be soon, it will be there. So this can certify both, and we got a key rate of 2 Mbps random number, and it passes all the randomness test available. So from this graph, if the value is more than 0.01, it is passing the test. So these random numbers doesn't need to be certified by anyone. These are device independent. There is no seed available, and it can just work. You can trust these devices. Moving forward, so this is one of the time tagger that we have developed. You know, getting an oscilloscope which has a resolution of gigahertz is costly, but this is one of a very economical time tagger that we have built, where each and every arrival of pulse, we can tag it with the accuracy of 1 nanosecond, okay? And it can take a rate of 100 megahertz, so it can handle a lot of pulses that is given to it. And it was also released on 10th of December. Not only in quantum optics domain, we also work in attosecond physics, where we try to control the reaction of two molecules at the attosecond scale, okay, where we can control the reactions, and this lab, quantum physics lab, is working on it. So they try to control these wave packets or matter, light. When they interact, they have two wave packets, one for the matter and one for the light, and they are in the superposition state. So this type of science we are also doing in the division. We are also working on a quantum network, because we know we can set up quantum key distribution between two parties. But this is not sufficient for a network. For a network, For a network, we actually need that we can store the quantum state and we can release at whatever time we want. So for that, we have another medium where the quantum state of the light comes, it is stored, and whenever we want, we can release it. And the earth ion minerals are going to help us for this type of study. So this is also a new activity that has started in our division. So in summary, we have the legacy of working in the quantum science and technology from last 2 decades. Here I have showed you 2 products, but soon we are going to come up with more and more products, and numerous scientific results are available in scientific journal. These 2 photos are taken at 2 different times, one in 2020, one in 2025. And you can see that previously Professor R.P. Singh, who is sitting there, and here Professor Gautam Samanta, and I am not here because I was busy with something else. So this shows that with limited number of people, we are able to deliver what we do in the lab and which can be used away from the lab. So with this, I thank you. Here is my email ID, the top one. If you need some information, you can contact me. And the bottom one is the email ID of our division head. If you want to know something, you can forward it to him, and then it will be, the question will be forwarded to the someone who can answer. With this, I thank you.
Thank you, sir. Now I would like to invite Dr. Narottam Sahu, Advisor GUJCOST, to felicitate Dr. Shashi Prabhakar, Assistant Professor PRL, Ahmedabad. Thank you, sir. We now begin with our panel discussion 2, a session of particular relevance for students, early career researchers, and aspiring professionals. The theme of the panel is Opportunities for Young Researchers in the Field of Quantum Science, Technology, and Industry. This panel seeks to highlight how quantum research is translating into real-world technologies, creating new pathways in academia, national research laboratories, startups, and industry. It will address the skills, interdisciplinary knowledge, and research orientations required for young scholars to participate meaningfully in this evolving ecosystem. We are honored to have Dr. N.T. Lan, Vietnam Institute of Science Information, Hanoi, as the chair of this session. I invite you to the dais, ma'am. Joining the panel are senior academicians and researchers, Dr. Sachin Parekh, Joint Director, CTE. I request all the delegates to please come on the dais as I announce their names. Dr. Chirag S. Thakkar, Professor and Head, Computer Engineering, LD College of Engineering, Ahmedabad. Dr. Sai Baba, Professor, National Institute of Advanced Studies, Bangalore. Professor Rasananda Panda, Mudra Institute of Communications, Ahmedabad. Help us in welcoming all the panelists with a warm round of applause. Dr. Raja Ram Yadav, former VC, Purvanchal University, Uttar Pradesh. With this, I welcome all the panelists and the chair again. Now I invite Dr. N.T. Lan to kindly take over the proceedings.
Good afternoon. My name is Lan. I'm from University of Science and Technology of Hanoi in Vietnam. And I'm very great pleasure to chair panel discussion two, opportunity for young researcher in field of quantum science and technology and industry for future workforce. And today, science and technology, especially quantum, AI, and advanced technology, change the way you work, you learn, and you research. And its panel when discuss how young researchers can prepare themselves, what opportunities are available, and how academia and industry can work together to build the future workforce. And in this panel discussion today, I'm very pleased to bring together our five distinguished speakers who have the experience in academic research and education relationship. The first, I would like to introduce Dr. Jakin Parekh, Joint Director, Commissariat of Technical Education, Government of Gujarat. We not here? Okay. Jane. Is it? Okay. Dr. Sachin? Is Dr. Sachin? Dr. Sachin, okay, thank you. Sir. And Dr. Chirag Thakkar. Okay. So sorry, in India, I can't read your name. Yeah. And Dr. Panda, yes. And Professor Sai Baba, and Dr. Zara Ram Yada. Okay, nice to meet you. So now, I think that we went to sought information from you to share with the own people about the topic. So the first, you can introduce Dr. Sachin Parekh, right? Okay.
Distinguished co-panelists, academicians, and future scientists, it is my pleasure to stand before you today as a representative of Directorate of Technical Education, Government of Gujarat, Gandhinagar. We are at a unique crossroads in history as we navigate through 2025, the International Year of Quantum Science and Technology, and celebrating the centenary of publication of the foundational papers on modern quantum mechanics in 1925. We are not just discussing a new subject in the syllabus, we are discussing the foundation of next resolution. So, as per my understanding and attending the previous sessions, National Quantum Mission has been established, where in India, 4 thematic hubs have been identified. These are IISc, IIT Madras, IIT Delhi, IIT Mumbai, and 43 premier institutes pan-India, which joins hand with these 4 thematic hubs. So in Gujarat, ISRO Ahmedabad and IIT Gandhinagar have been given the of Gujarat, and the topic which is relevant to our panel discussion, I would like to say that, and there was one question by one of the researcher in the morning. So give you the answer of that question. For the youth of Gujarat, there are various encouraging and very motivating motivating schemes of education department, government of Gujarat. So I would like to highlight in a brief few of the schemes. Startup, we have this startups schemes, which we call it as SSIP 2.0, where 2.5 lakhs rupees is given for the grant of for POC, 75,000 for the national patents, 1.5 lakhs for international patents, and 25,000 rupees for school students. And under this, we have this setup of iHub, which is one of the unique setup, and I would suggest and request Sahu sir, those who have come from outside Gujarat, to have a visit of this iHub, at least for an hour, if possible today evening. It would be a wonderful setup of 1.5 lakh square feet in the campus of KCG, and which provides Srujan seed support up to 10 lakhs for the prototype to market reach, and mind to market active technology. As yesterday the Secretary of Tamil Nadu Science and Technology mentioned about the compulsory subject has been introduced in Tamil Nadu. So we are also in process of, not kind of a compulsory, but it would be a minor subjects for our students studying in Gujarat. We have MTech in quantum technology proposed in the next year. This quantum computer requires, as I learned, a very low temperature in the range of cryogenic range. As mentioned in the previous panel, it was somewhere around 2.3 millikelvin, and which requires helium-3 and helium-4, where these are the rare earths, or we call it as an isotopes. So there is a race for, these are not available, it's very rare. Rare earth is very rare on the surface of the earth. So there is a race, it is available in some good quantity on the surface of moon. So there is a race for finding this on the surface of moon. And I would like to very happily inform you that at our LD College of Engineering, we have a master's program in cryogenic. It was started by one of our professor who is happened to be sitting here, Professor Shreya Mehta of Mechanical Engineering Department. Thank you so much.
So please you can.
Yes. Namaskar. Thanks for having me here. Thanks, Commissioner of Technical Education, for providing this opportunity. I'm an academician, and I'll represent the case of academician and researcher. I'm a faculty by training. I'm a computer engineer, and I'm a researcher by choice. And that is why when we say the global workforce, and when we want to create the workforce in the area of STEM, for this young generation, I would like to share some statistics first. If we categorically analyze the numbers first, and then I'll come to the theme that I'm proposing. We are 23 to 25% of IT workforce globally. And if we say AI, we are 14% of the AI global workforce. And this 23% of the computer, that is IT and IT-enabled services global workforce, actually fetches 210 plus, that is 210 plus $billion every year to Indian economy. And our fuel import is somewhere around 100 plus $billion. And our defense is somewhere around 150 to 170 $billion. That means only the IT-enabled services fetches this 200 plus $billion revenue year after year since last 23, 25 years. And this actually is very good figure. But now because the entire world is shifting towards AI and quantum computing related this, I already shared you the figure that 14% of AI workforce is in India. That means if you really want to create the workforce opportunity, because this 14% is not going to work, we need to anyway bring it to 25 to 30% of the global workforce. So when we look at this, there is one doctrine which I propose, and people who know me very well, they know that I keep on telling this since last 2 years, and I call it AIR. AIR. A stands for academics, I stands for research, I stands for innovation, and R stands for research. Now when I say academics, if you look at the global north or the developed countries, the technology transfer is from academic campuses, research campuses to industry. So the technology transfer is from academia to industry. Unfortunately in India, it is the other way around. The technology transfer is majorly, barring some exceptional cases, is from academia. So that's the issue. So how to address this issue? We need to understand this, that this technology transfer has to be made through AI literacy, through quantum literacy. And when I say literacy, it is the know-how, and then skill upgradation. So this is all about academics. Now the second point, which is innovation. Now Satya Nadella very rightly said that our industry or the modern industry does not respect tradition. It respects innovation. And because you are a very bright, young lot, you will definitely ask me to give the proof. So I give you two short proof, considering the time limitation. Number one is Google, which has started search economy. Now Google was basically a research topic. Two young professionals were doing their PhD, and they were working on page rank algorithm, which is a very core research area. And through this, they came up with search engine optimization. And this search engine optimization has started search economy. And this entire search economy has propelled a very novel kind of industry, which right now US is dominating. So that is one example. The second example is, I just went through one video in 2011. Stanford University professor Andrew was working on a project, and he was working with 20,000 plus TPUs, that is equivalent to CPUs, 20,000 CPUs. And they were not getting the results they wanted. And here you need to understand the innovation part. And then he, in one international conference, he met with one of the NVIDIA person, and the NVIDIA person said that, can we try this problem? He said, fine, you try this. And they could solve this problem only using 47 GPUs. Now you can understand 20,000 versus 47. So this is the power of innovation. So this we need to understand. And the third point is research. Now when I say research, I just give you one very simple example. There was a very seminal paper. The title of that paper is Attention is All You Need. And that paper got published in, if I'm not wrong, June 2017. And that paper talks about language models, and it talks about transformer architecture. And this paper was written by some 7-8 people. 3 belong to Google Research, 3 belong to Google Brain, one was a professor of Toronto University, and one was Ilya. And this paper got adopted by a non-profit organization called OpenAI. And they made a product out of this research paper. And that product is ChatGPT. which has started the entire large language model revolution. And today, that company, OpenAI, is a $500 billion plus company. So we need to understand the impact of research, and we have to prepare the young generation, the future generations, ready to embrace AIR, core academics, innovation or innovative mindset, scientific temperament, and research. And once we do this, what is the solution? So in last 2 minutes, I'll just try to tell you or sum up my point that when we embrace this in full totality, basically, if you really want to build mega structures, giga factories, and tech giants, basically what you need to focus is, you need to focus on atomic and subatomic level. If you want to be a cheap giant like Taiwan Semiconductor Manufacturing Company, which owns 35% of the Taiwan GDP, they are working on chip manufacturing. So we need to focus on photocell, quantum, quark, nanotechnology, DNA computing, quantum computing. So if you want to very big, large structures, tech giants, we need to focus on very micro and storm level entities. And once we adapt this, I think we can be the next superpower. Thank you for this opportunity. I hand it over to my senior esteemed colleague.
So invite Professor Sai Baba.
Yeah, thank you for setting the platform. Good afternoon. I know that we are all waiting for lunch. The society always looks for technology to find solution to the problems. But then, as the technology becomes available to the people, two things will happen. We'll somehow ignore telling people that this technology is to help you. That's where the science communication plays an important role. The other thing is, this technology which is created to help the society can also be used by the miscreants to create problems. So when the technology came, computer networks have come, internet has come, WhatsApp has come, it brought people closer. But it also created problem of security. Cyber security became an issue. Then we started working on how to secure your network, cyber security. When all these things are happening, suddenly AI appeared, and that's what my Dr. Chirag mentioned. And AI will do most of it what you can do by yourself. Then the worry comes to the people. All these communications are happening between 0 and 1. And suddenly the thought came, why 0, 1? Why not use the continuum from 0 to 1? That's where the quantum communications have become. Today, one thing is very good about what is happening in our country is, when the quantum is started, India is also there. You know, I'm sure very nice presentation by the PRL person there. I think we were there. We are there along with the development. That's a very, very positive sign for this country. India has given money. India has brought together people. But then, one thing is clear. Something fantastic is going to happen with quantum technologies. This idea is there in the minds of all the people. But as a young person, an aspiring researcher, an aspiring academician, the question will come, what is there for me in that? If I'm a student, if I'm a researcher. So what I want to say is that this is a very unique case of multidisciplinary contributions that will grow quantum technologies. To start with, it is physics. Understanding physics, understanding mathematics, understanding electronics. Ultimately, you need to put there in a device. And then what is not being emphasized is all these advancements that are being done today at milli-Kelvin temperature. That means you need to have technology to bring down the temperature to that low level. There are a lot of cryogenics are there. I'm happy that a lot of initiatives are being done in cryogenic engineering. The other issue will be, one should not forget about the materials that are required for this. If you are looking at a material which can operate at such low temperatures and also come to the room temperature, the cycling would happen. You have to ensure that you have materials to withstand these challenges. The opportunities are enormous, but then I think I remember one of the student, I think Satpati is here, I think he's the 11th standard student, he told he wants to work on quantum electronics. I think, no? Suddenly I was just engaging him with yesterday and today also. What does it mean is, it is not that tomorrow you'll have a course of BTech in quantum technology. No, that is not what we are looking at. The quantum technology or quantum science and technology will build on already established disciplines and then enhance it further. I think that mistake should not happen that can I study BSc or BTech in quantum technology. That's a mistake is happening in AI already. I think somebody wants to do BTech in AI without realizing AI is not a standalone technology, but people do it because presuming that you will get a better job. So it built on sound physics knowledge, sound mathematical understanding to solve the problems, and sound electronics, of course the computer science, sound materials, and very rugged engineering. If you want to really have, India has contributed to ITER program, a large cryostat. I know, I'm sure that you know that India has the capability. So I would say, start doing your undergraduate course in any of these disciplines. Parallelly, AICT is offering some minor course on quantum technologies. Try to learn about how this quantum technology, science and technology is growing. Then try to specialize in master's level. That is where already IISc offers an MTech in quantum technologies. IIT Madras offers something. Many others are offering. So if you are a student, please try to pursue this path, but keep the awareness about the development of quantum science and technology when you are growing. This is something which I advise. And if you are a researcher, see whether your expertise can be enhanced by learning about these two new domains. And of course, in the morning, I was also mentioning the large potential for entrepreneurs to come in and then pitch in for any one of those things. Any one of those developments that can be done, that gives you employment, that also give you money to make out of these new technologies. The opportunities are enormous. Preparedness is important. Preparedness with realism is what is the way forward. I'm sure all the students who are here, aspiring researchers who are there, and one thing good happened in the quantum mission was, IITs take care, but there are 43 institutes are coming together. Researchers from 43 institutes across this country are coming together. It's a very unique way of exploring new technologies. I'm sure a very bright future is there. I'm very happy that we're also bringing public awareness ahead of time, and that's something which is unique. We congratulate GUJCOST for taking this initiative. With all this, we should see India being there in the top, and then competing with the best in the world, and finding our own way to be the experts where we can contribute for the welfare of our society. I'm sure that, best wishes for all those who are aspiring to contribute towards this.
Okay. Thank you. So next week is Panda.
Yeah.
So you can share.
Thank you very much. Now I will pass on the mic to Radharam sir, because he is a scientist and also senior, so he will speak. After that I will come back my 2 minutes talk on the communicating the science policy, quantum and everything. So I have already spoken to him, so I will give it to him.
Hello. सबसे पहले तो मैं प्रोफेसर नरोत्तम साहू जी को और डॉक्टर मनोज पटेरिया साहब को कृतज्ञता ज्ञापन करूंगा कि साहू साहब ने इतना अच्छा मेल लिखा मुझे, और पटेरिया साहब ने मेल पढ़ने के पहले ही मुझको फ़ोन कर दिया कि तुमको अहमदाबाद की इस कॉन्फ्रेंस में जाना है। तो रिलेशन जब कायम होता है तो अच्छी रिसर्च होती है। एक बहुत बड़े साइंटिस्ट ने कहा कि स्टूडेंट्स को, रिसर्च स्कॉलर को अच्छे साइंटिस्ट से फर्स्ट इस्टेब्लिश द रिलेशन, देन यू कैन डू द बेस्ट रिसर्च। तो आप सबका तो रिस्पेक्टेड चेयरमैन एंड अदर डिग्निटरीज ऑन द डायस, आप सबका परिचय कल हुआ था, लेकिन मेरा मैं अपने को इंट्रोड्यूस कर दूं, क्योंकि बैकग्राउंड जब आपको थोड़ा पता हो जाएगा तो मेरे से एक्सपेक्टेशन क्या होगी ये ठीक रहेगा। नाम तो ठीक ही है, डॉक्टर राजाराम यादव। मेरी एजुकेशन इलाहाबाद यूनिवर्सिटी से हुई, बीएससी, एमएससी एंड पीएचडी। 1983 to 88 I was in ONGC as a geophysicist wells। इसके बाद आपको थोड़ा इंटरेस्टिंग लगेगा, आफ्टर 6 years in ONGC I resigned from the ONGC। क्यों रिजाइन किया, इसका एक इंसिडेंट है। आसाम में मैं था तो केंद्रीय विद्यालय में फिजिक्स का कोई टीचर ही नहीं रहता था, ट्रांसफ़र करा करके चला जाता था। तो जनरल मैनेजर ने कहा, यादव जी आप कैंपस में रहते हो, 2 महीने हमारे स्टूडेंट्स को फिजिक्स पढ़ा दो। एक दिन मैंने स्टूडेंट से पूछा कि आप में से टीचर कौन बनना चाहता है, क्योंकि मेरा इंटरेस्ट तो था टीचर बनने में, क्योंकि मेरा इंटरेस्ट तो था टीचर बनने में, क्योंकि मैंने इलाहाबाद यूनिवर्सिटी में कभी आईएएस, पीसीएस और इंजीनियरिंग का एग्ज़ाम नहीं दिया, मैंने तय कर लिया था। तो जो मेल स्टूडेंट्स थे, बॉयज़ थे, उन्होंने कहा जब सर कुछ नहीं मिलेगा तब टीचर बनेंगे, तभी प्रोफेसर बनेंगे। लेकिन जो फीमेल स्टूडेंट्स थीं, उन्होंने कहा सर हमारे लिए सर्विस कोई ज़रूरी नहीं है, जब कुछ भी नहीं मिलेगा तब भी हम प्रोफेसर या टीचर नहीं बनेंगे। तो ये स्ट्राइकिंग मोमेंट था। तो मैंने कहा इस चैलेंज को मैं स्वीकार करूंगा कि भाई कुछ स्टूडेंट्स को तो टीचिंग लाइन में जाना चाहिए। फिर मैंने और 2017 to 20 मैं वीर बहादुर सिंह पूर्वांचल यूनिवर्सिटी उत्तर प्रदेश की स्टेट, उसमें मैं वाइस चांसलर रहा 39 मंथ्स। माननीय राम नायक जी और श्रीमती आनंदीबेन पटेल जी के साथ मेरा कार्यकाल रहा। फिर मैं 4 साल सोशल वर्क किया, आरएसएस प्रचारक रहा। फिर माननीय नानाजी देशमुख जी की यूनिवर्सिटी चित्रकूट ग्रामोदय विश्वविद्यालय में कि जब तक विलेज का डेवलपमेंट नहीं होता है तब तक इस देश का डेवलपमेंट नहीं होता है, इसलिए साइंस फैकल्टी। फिर मैंने 20 पीएचडी प्रोड्यूस किए अपने कैरियर में, 150 रिसर्च पेपर्स इन द जर्नल्स इन अब्रॉड। इसकी भी एक घटना है। मैंने एक पेपर इंडियन जर्नल में भेजा, मेरा पेपर दबा करके ही बैठ गए 3 महीने। फिर मैंने स्ट्रॉन्ग लेटर लिखा कि आप या तो एक्सेप्ट करो या रिजेक्ट करो। तब बड़ी मुश्किल से 4th मंथ में एक्सेप्टेंस आया। तब से मैंने प्रतिज्ञा कर ली कि कोई भी पेपर इंडियन जर्नल में नहीं भेजूंगा। इस चीज़ को हमें बदलना पड़ेगा। फिर मैंने मोर देन 5 करोड़ DRDO DST UGC के मेजर रिसर्च प्रोजेक्ट पूरे किए और इन अब्रॉड कनाडा, USA, जर्मनी, इटली, जापान, स्पेन, सिंगापुर, बेल्जियम, ऑस्ट्रिया। मैंने प्रतिज्ञा की थी कि मैं अपने देश के पैसे से चाइना नहीं जाऊंगा। लेकिन भगवान ने मेरी प्रतिज्ञा भी रखी और मैं चाइना भी गया। चाइना की नानजिंग यूनिवर्सिटी ऑफ साइंस एंड टेक्नोलॉजी के डायरेक्टर ने कहा आप किसी भी समय आ जाओ, हम टोटल आपका रिटर्न एयरफेयर, फ्री फूडिंग, लॉजिंग सब देंगे। और आप कहोगे तो हम 1 लेक्चर मिलता भी था, तो उन्होंने कहा हम एक की जगह 3 लेक्चर को आपको एकोमोडेट कर देंगे। तो इसलिए मैं चाइना गया। तो फिर मैंने रिसर्च में जो कि इस टॉपिक से रिलेटेड है, क्वांटम साइंस एंड टेक्नोलॉजी, कि मैंने कॉस्ट इफेक्टिव अल्ट्रासोनिक स्पेक्ट्रोस्कोपी मेथड से नैनो पार्टिकल का साइज डिटर्मिनेशन इस्टेब्लिश किया, जो कि पहले आवश्यकता आविष्कार की जननी होती है। पहले नैनो साइज डिटरमिन करने के लिए टेम कराना पड़ता था, जिसमें हाथ पैर जोड़ने पड़ते थे अच्छे इंस्टीट्यूशंस के। ये परेशानी थी, 3-4 करोड़ का तो आता ही है। फिर हमने जो है अल्ट्रासोनिक स्पेक्ट्रोस्कोपी मेथड से नैनो पार्टिकल का साइज डिटरमिन करने की इस्टेब्लिश हमने किया। अब टेम की रिप्लेसिंग ट्रांसमिशन इलेक्ट्रॉन माइक्रोस्कोपिक मेथड। फिर अवार्ड रिकॉग्निशन, मैं टीचर हूँ तो इंडियन नेशनल साइंस एकेडमी का 2012 का मैं टीचर अवार्डी हूँ। डॉक्टर एस भगवंतम अवार्ड, MS नारायणन फेलो ऑफ इकोस्टिकल सोसाइटी, अल्ट्रासोनिक सोसाइटी ऑफ इंडिया का मैं प्रेसिडेंट हूँ इस समय। और ये चूँकि अभी विज्ञान भारती के भी हमारे स्पीकर आए थे, उसका मैं विज्ञान भारती का भी अवार्डी हूँ। और एरीज नैनीताल जो स्पेस साइंस का, उसका मैं गवर्निंग काउंसिल का 3 इयर्स मेंबर भी रहा। फिर मैं आज के टॉपिक पर आता हूँ। 1980 में मैं जब मैंने PhD प्रोग्राम ज्वाइन किया तो कॉन्फ्रेंस के लिए मैं कोचीन जा रहा था। तो मेरी बर्थ नीचे की थी, ऊपर एक छोटा सा बच्चा सोया हुआ था। बच्चे ने पेशाब कर दी तो पेशाब मेरी खोपड़ी पर गिरी। तो मैं एजिटेट होकर के बच्चे को कुछ डांटने ही वाला था, लेकिन बगल में एक मैडम, उसकी माँ बैठी थी, मदर। तो मदर ने एक ऐसा सेंटेंस कहा कि बहुत इम्पोर्टेंट है, इंटरेस्टिंग है। मदर ने कहा, दैट मामा के ऊपर पेशाब कर दिया। आप जानते हैं कि जब मदर ने मैटरनल अंकल मामा बना दिया तो मैं क्या करता। तो रिलेशन बहुत इम्पोर्टेंट होता है और यही हर चीज़ का सॉल्यूशन होता है। तो मैं साइंस में, रिसर्च में, इसमें अपॉर्चुनिटी फॉर यंग रिसर्चर्स, उनके लिए ख़ास तौर से मेरा कंसंट्रेशन है कि एक्सपेरिमेंट और एक्सपीरियंस एक जैसी चीज़ होती है। ऑब्जर्वेशन बेस्ड ऑन एक्सपेरिमेंट एंड एक्सपीरियंस। जो मशीनों के द्वारा, ऑपरेटर्स के द्वारा एक्सपेरिमेंट करते हैं उसको एक्सपेरिमेंट कहते हैं नाउअडेज। लेकिन जहाँ पर मेजरमेंट नहीं हो सकता, ऐसी इंद्रियों के द्वारा जो एक्सपीरियंस लेते हैं वो भी एक प्रकार की साइंस है। जैसे वेलोसिटी ऑफ लाइट को तो मेजर कर लेते हैं, लेकिन मन की गति को हम मेजर नहीं कर पाते, इसलिए साइंस के परव्यू में नहीं रखते। लेकिन स्पीड तो है ही, उसको हम एक्सपीरियंस से रियलाइज करते हैं। इसलिए अभी इस मॉडर्न साइंस में तो नहीं आती, लेकिन साइंस अप टू सम एक्सटेंट कह सकते हैं। तो ये क्वांटम साइंस तो एक प्रकार से ये है कि होल यूनिवर्स इज इंटीग्रेटेड, उसको कहते हैं परमात्मा। लेकिन ईश्वर, अंश, जीव, अविनाशी, हम अलग अलग बैठे हैं, तो दिस इज द फोनोन ऑफ परमात्मा। ये क्वांटम है, हमारे जो परमात्मा है होल यूनिवर्स में इंटीग्रेटेड है, उसका क्वांटम क्या है, हम सब बैठे हुए हैं। तो इस तरह से, तो इस प्रकार से, और रिसर्च में यंग रिसर्चर्स को मैं बताना चाहता हूँ कि जब हम कितना टाइम है हमारे लिए? नहीं, पहले आपने बताया ही नहीं। तो जब हम किसी साइंस को टेक्नोलॉजी में लाते हैं और उसको एम्प्लॉयमेंट के साथ जब तक हम जोड़ते नहीं हैं, तब तक उसका डेवलपमेंट जैसा हम चाहते हैं नहीं हो सकता। मैं वाइस चांसलर था तो 9 मंथ एक टेक्निकल ट्रेनिंग दे करके, और जो स्कूल स्टूडेंट्स थे, नॉट मोर देन इंटरमीडिएट क्लास, 60 स्टूडेंट्स को मैंने रिलायंस जैसी कंपनी में परमानेंटली एब्जॉर्ब कराया। तब जो है तो आसपास के क्षेत्र में रिसर्च और टेक्निकल मतलब स्टडी के लिए एटमॉस्फेयर क्रिएट हो गया। 4000 हमने कैंपस सिलेक्शन कराया। ड्यूरिंग 3 years माई टेन्योर एज ए वाइस चांसलर, 90 कंपनीज को मैंने बुलाया और 4000 फाइनल ईयर के स्टूडेंट्स को कंपनियां ले गईं, तो वहाँ पर स्टूडेंट्स की संख्या बढ़ने लगी। रिसर्च के लिए, इंजीनियरिंग के लिए, कैसे हर एक एरियाज के लिए स्टूडेंट्स की बाढ़ आ गई। और साइंस कम्युनिकेशन का आपको एक एक्सपीरियंस बताता हूँ। एज ए वाइस चांसलर मैंने पूरी यूनिवर्सिटी को इस कलर से रंग दिया मैंने। तो 150-200 जर्नलिस्ट पत्रकार सम्मेलन में एक पत्रकार पूछता है कि आपने पूरी यूनिवर्सिटी को भगवाकरण कैसे कराया? तो मैंने आंसर दिया कि इस कलर की जो स्कैटरिंग पावर है वो बहुत कम होती है, इसलिए दूर से आने वाले व्यक्ति को हमारी यूनिवर्सिटी शाइनिंग दिखाई देगी, इसलिए हमने भगवाकरण बताया। तो विलेज के, गांव के कॉमन मैन की लैंग्वेज में आप जब साइंस को बताते हैं, स्कैटरिंग पावर को मैंने बताया, उनकी समझ में आ गया। तो इसी प्रकार से ये कोई हमारी परंपरा आज की नहीं है साइंस कम्युनिकेशन की, ये प्राचीन काल की है। एक आपको एग्जाम्पल देता हूँ। हमारे भारत को, प्लीज 1 मिनट 2 मिनट, हमारे भारतवर्ष को सोने की चिड़िया कहा जाता है। क्यों कहा जाता है? नॉर्मली लोग सोचते हैं कि सोने का खजाना था, तो उसके लिए तो और कुछ कहते। सोने की चिड़िया इसलिए कहा जाता है कि एक बार मुझे, जब मैंने नैनो पार्टिकल पर पहला लेक्चर दिया तो प्रेस ने बहुत निकाला, टीवी ने इंटरव्यू लिया। तो मेरे दिमाग में आने के लिए भारत को, इंडिया को सोने की चिड़िया कहा जाता है। तो दिस इज द टेक्निक टू पॉपुलराइज द साइंटिफिक इन्वेंशन, साइंटिफिक डिस्कवरी एंड द टेक्नोलॉजी। इसी प्रकार से अब यहाँ पर हमारे एडमिनिस्ट्रेटर बैठे हैं, उनके माध्यम से मैं एक बात कहना चाहता हूँ कि कोई ना कोई मैकेनिज्म, मिनिस्टर साहब तो चले गए, जो किसी भी स्टूडेंट्स को अगर रिसर्च करनी है तो उसकी कोई ना कोई फाइनेंशियल व्यवस्था होनी चाहिए। और पहले हिंदुस्तान में होती थी। मैं इलाहाबाद यूनिवर्सिटी का स्टूडेंट भी हूँ, प्रोफेसर भी वहीं फिजिक्स में रहा। तो एक बीएससी की क्लास में 1968 में एक बीएससी में सुनील रॉय नाम का स्टूडेंट था, जो बीएससी करता था और गवर्नमेंट ऑफ इंडिया से उसको रिसर्च की फेलोशिप भी मिलती थी। इसलिए मैं गुजकॉस्ट को और मैं एक सजेशन देना चाहता हूं कि इस प्रकार की व्यवस्था और गुजरात सरकार को और इस लेटर लिखना चाहिए कि किसी स्टेज में बीएससी, कम से कम बीएससी की स्टेज में अगर कोई रिसर्च करना चाहता है उसको फेलोशिप की व्यवस्था होनी चाहिए। रिसर्च के लिए कुछ ज़रूरी नहीं होता है। आजकल मुझे बड़ा आश्चर्य होता है कि रिटायरमेंट के 3 साल पहले आप पीएचडी सुपरवाइज नहीं कर सकते। जब लेटर का ज़माना था तो पीएचडी का रेजिडेंसी पीरियड 18 मंथ था, मेरे कार्यकाल में ही था। लेकिन जब बटन दबाते ही पीएचडी की थीसिस लंदन चली जाती है तब 3 इयर्स है। वाई? टेक्नोलॉजी का फ़ायदा क्या, तो कैसे हम जाने? तो उसके पीछे कुछ दूसरी चीज़ है, मैं बताना नहीं चाहता। एज ए एडमिनिस्ट्रेटर मैं जानता हूँ उसको। रिसर्च के लिए आइडिया चाहिए और आइडिया हमको गली गली में मिल सकता है। मैं इलाहाबाद से एक बार कानपुर जा रहा था तो बीच में एक दुकान थी जिसमें पेड़ा बिकता था, स्वीट। तो वो बड़ी मशहूर दुकान थी, इसलिए मशहूर दुकान थी कि उस पेड़े का टेस्ट स्पेशल था। तो मेरा स्टूडेंट CRO2 नैनो पार्टिकल सिंथेसाइज कर रहा था केमिकल मेथड से, और CRO2 को किसी लिक्विड में मिला करके GMR मटेरियल बनाना चाहता था, जो कि बहुत सिंपल टेक्निक थी। 6th मंथ उसने डिवोट किए, लेकिन CRO2 नहीं बना। CRO2 तुरंत ऑक्सीडाइज होकर के CR2O3 बन जाता था। 6th मंथ मेरा स्टूडेंट परेशान हो गया, मैं भी परेशान हो गया। तो मलवा के पेड़े से मैंने पूछा दुकानदार से कि भाई ये बताओ तुम्हारा ये पेड़े का टेस्ट स्पेशल क्यों है? बोले साहब एक बताएंगे लेकिन पूरी चीज़ नहीं बताएंगे। तो हमने कहा जो बताओ वही बता दो। तो उसने कहा साहब एक निश्चित टेम्परेचर पर
एक कांस्टेंट टेम्परेचर पर हम जो है तो मिल्क प्रोडक्ट बनाते हैं, खोआ बनाते हैं, इसलिए इसका स्पेशल टेस्ट आता है। यानी एनी साइंटिफिक पैरामीटर, very popularly known scientific parameter like temperature is maybe most important for your major discovery, cutting edge discovery, research। तो उसको मैंने याद कर लिया। फिर मैं स्टूडेंट के पास आया और डिफेंस मिनिस्ट्री की कृपा से मुझको 60 लाख पैसा मिला हुआ था, जिसमें मेरे पास 0.1 डिग्री सेंटीग्रेड के रेजोल्यूशन से टेम्परेचर पर सिंथेसाइज करने का मेरे पास अरेंजमेंट था मेरी लैब में। तो मैंने पूछा स्टूडेंट से कि भाई तुम कितने रेजोल्यूशन से ये केमिकली सिंथेसाइज कर रहे हो? तो बोले सर 5 डिग्री सेंटीग्रेड रेजोल्यूशन। मैंने कहा थोड़ा कम कर दो, 1 डिग्री सेंटीग्रेड का रेजोल्यूशन हो। मेरे पास तो मशीन थी ही डिफेंस मिनिस्ट्री की कृपा से। तो आपको जान करके बहुत इंटरेस्टिंग लगेगा, और ख़ास तौर से मैं यहाँ पर स्टूडेंट्स को बताना चाहता हूँ, इस बात को ज़रूर याद कर लेना कि 1 डिग्री सेंटीग्रेड के रेजोल्यूशन से उसने ट्राई करते करते एक ऐसा टेम्परेचर मिल गया जिस पर कि CrO2 Cr2O3 ऑक्सीडाइज नहीं हुआ, CrO2 नैनो पार्टिकल बन गया। और फिर जैसे मलवा के दुकानदार ने सावधानी रखी थी, तो हमने भी सावधानी रखी। मैंने एक फॉरेन जर्नल में मैंने पेपर भेजा, और जिस टेम्परेचर पर हमारा CrO2 बना था, मैं बताना नहीं चाहता, आप अदरवाइज ना लें, उस टेम्परेचर को एग्जैक्टली मैंने नहीं लिखा, दूसरा लिखता ताकि कोई उसको चोरी ना कर सके।
थैंक यू सो मच।
हाँ, तो इसलिए मैं यंग जनरेशन को बताना चाहता हूं कि जॉब की कोई कमी नहीं है। आप ईमानदारी से रिसर्च करो, ईमानदारी से बीटेक एमटेक करो, MSc करो, जॉब आपको मिलेगा। प्रोफेसर CB रामन को कलकत्ता यूनिवर्सिटी ने अपॉइंटमेंट नहीं दिया था, लेकिन वो अकाउंट ऑफिसर बने। अकाउंट ऑफिसर बने, घर में लेबोरेटरी बनाई, उस पर जब 4 पेपर उन्होंने इंटरनेशनल जर्नल में पब्लिश किए, तो कलकत्ता यूनिवर्सिटी ने उनको ऑफर किया प्रोफेसरशिप। इसलिए आपको मिलेगी प्रोफेसरशिप। तो इसलिए आयल एक्सप्लोरेशन, मैं ONGC में था, तो अल्ट्रासोनिक अटेन्यूएशन से जिससे आयल का एक्सप्लोरेशन किया। देखिए क्वांटम साइंस कहाँ कहाँ कैसे यूज होती है, इसका ऑब्जर्वेशन बताना चाहता हूँ कि अल्ट्रासोनिक के अटेन्यूएशन से आयल को हम एक्सप्लोर करते थे कि ज़मीन के अंदर कहाँ पर है। लेकिन उसमें क्वांटम साइंस थी कि एकॉस्टिकल फोनॉन और लैटिस फोनॉन्स दोनों के इंटरेक्शन से अटेन्यूएशन होता है, और अगर वो हायर टेम्परेचर पर है, मतलब वो लेयर, इफ इट इज इन लोअर टेम्परेचर, तो उसमें इलेक्ट्रॉन फोनॉन से इंटरेक्शन होता है। तो क्वांटम साइंस आयल एक्सप्लोरेशन में थी। इसलिए जो है, तो आपकी जो साइंस है वो कहीं पर भी अप्लाइड हो सकती है, केवल आपको आइडिया लेने की जरूर होती है, और आप ईमानदारी से काम करो। मैंने एज ए वाइस चांसलर जो अपॉइंटमेंट किए थे 40-50, तो आपको जान करके बड़ी खुशी होगी कि जब प्रॉपर स्टूडेंट को प्रॉपर पोजीशन मिलती है तो सारी समस्या का समाधान होता है। तो हमारे साइंटिस्ट ने 1 साल पहले DST नई दिल्ली को रिसर्च प्रपोजल दिया रिन्यूएबल एनर्जी में। तो DST नई दिल्ली ने 10 करोड़ की मेजर रिसर्च ग्रांट की दी, जो उत्तर प्रदेश की किसी यूनिवर्सिटी को नहीं दी। पूर्वांचल यूनिवर्सिटी के रज्जू भैया इंस्टीट्यूट ऑफ फिजिकल स्टडी फॉर रिसर्च एंड उसके लिए दिया। अब तो ये भी हमें जो यहाँ पर एडमिनिस्ट्रेशन उनको देखना चाहिए कि हमारे जो प्रॉपर स्टूडेंट हैं, जिसमें प्रतिभा है, टैलेंट है, उनको सही जगह लाएं। और बहुत ज़्यादा मैं और एक और पॉपुलराइजेशन के लिए कि मुझको जिन्होंने क्वांटम मैकेनिक्स पढ़ाई थी, प्रोफेसर विपिन कुमार अग्रवाल जी ने, उन्होंने एक किताब लिखी थी क्वांटम मैकेनिक्स एंड फील्ड थ्योरी। हर चैप्टर के ऊपर एक हिंदी में दोहा लिखा रहता था। तो जैसे ये है ना क्वांटम साइंस, तो एक दोहा लिखा था कि कैसा है वो फोनॉन, कैसा है क्वांटम, कैसा है कि राजा के घर रानी हुए बैठी, नौकर के घर नौकरानी। यानी वो क्वांटम जब जैसी परिस्थिति होती है तब तैसा वो बिहेव करता है। ये उनकी किताब में लिखा हुआ था हिंदी से, हर चैप्टर में लिखा कि राजा के घर रानी है बैठी, लेडी तो वही है लेकिन राजा के यहाँ जाती है तो रानी कहलाती है, और जब नौकर के यहाँ जाती है तो लेडी नौकरानी कहलाती है। तो इन्हीं शब्दों के साथ मैं प्रोफेसर मेघनाथ साहा जी का, चूँकि मेरा डिपार्टमेंट ही ऐसी है कि मुझको भी प्रोफेसर मुरली मनोहर जोशी जी ने बनाया, जो सेंट्रल में कैबिनेट एजुकेशन मिनिस्टर थे, और प्रोफेसर मेघनाथ साहा भी जो FRS थे लेकिन लोकसभा में पार्लियामेंट मेंबर, वो लोकसभा के मेंबर ऑफ पार्लियामेंट थे वो। तो उन्होंने एक लोकसभा में भाषण दिया था जो कि यहाँ पर थोड़ा सा मतलब बहुत इम्पोर्टेंट है। लोकसभा में उन्होंने उस समय भाषण दिया था कि सेंट्रल गवर्नमेंट को एजुकेशनल इंस्टीट्यूशंस, इन पर्टिकुलर यूनिवर्सिटी एजुकेशन को 10% टोटल बजट का एलोकेट करना चाहिए, और स्टेट गवर्नमेंट को टोटल बजट का 20% एलोकेट करना चाहिए। तो हम सब सरकार पर प्रेशर डाल सकते हैं कि एटलीस्ट कम से कम 10 और 20% के बीच में 15% टोटल बजट का, और साइंस एंड टेक्नोलॉजी के डेवलपमेंट के लिए, रिसर्च के लिए हमको मिलना चाहिए। इन्हीं शब्दों के साथ, और मैं आप सबसे क्षमा मांगता हूं कि मैंने थोड़ा सा ज़्यादा समय ले लिया, लेकिन इतना कितने हजार खर्च करके साहू साहब ने बुलाया, तो 10-5 मिनट तो मुझे बोलना मुझे जस्टिफाइड था ही। थैंक यू वेरी मच। फिर से मैं डॉक्टर मनोज पटेरिया साहब को, साहू साहब को और अपने बनाता हूँ, और स्टूडेंट्स को एज ए फॉर्मर वाइस चांसलर एंड प्रोफेसर ऑफ फिजिक्स इलाहाबाद यूनिवर्सिटी मैं गारंटी लिख करके देता हूँ कि आप क्वालिटेटिव बट यूजेबल टू द विलेज बेस्ड सोसाइटी। भगवान परशुराम का उदाहरण है कि उनमें क्षत्रिय भी गुण थे और ब्राह्मण के भी गुण थे। उसका कारण क्या था कि हमारे साइंटिस्ट ने पुत्रेष्ठ चरु बनाया था, उसको जब पीपल के वृक्ष में देते थे तो क्षत्रिय गुणों का बालक पैदा होता था, और भुल्लर वृक्ष के साथ में उसको देते थे तो ब्राह्मण गुणों का। तो स्मार्ट मटेरियल की तरह स्मार्ट मैन की ज़रूरत है, जब जैसी कैरेक्टरिस्टिक की ज़रूरत हो। इस रिसर्च को आगे बढ़ाइए। ना अमंत्र मक्षरम नास्ति नास्ति मूल वनौषधम। हमारी टेक्नोलॉजी बहुत कॉस्ट इफेक्टिव होनी चाहिए। कोई ऐसी वनस्पति नहीं है जो औषधि नहीं बन सकती है। केवल यंग रिसर्चर्स को आगे आने की ज़रूरत है कि हम ऐसी दवा बनाएंगे जो किसी भी वनस्पति से बनती है और हमारे देश के लिए कॉस्ट इफेक्टिव जो है, तो और हम दवा बनाएंगे जिससे साधारण आदमी को, आजकल अस्पतालों में कितना खर्चा होता है। इन्हीं शब्दों के साथ मैं अपने यंग स्टूडेंट्स के लिए, यहाँ बहुत स्टूडेंट्स हैं, वो मैं गारंटी पत्र देना चाहता हूँ कि आप ईमानदारी से रिसर्च करो, आपको जॉब की कोई समस्या नहीं, जब होगी तो मेरे पास चले आना। जय हिंद, जय भारत।
Thank you so much. So, final.
Yeah, and let me tell you, I will not take more than 2 to 3 minutes because you have listened to a great communicator, and you know, we generally say communication has to have something known as Sthan, Kal and Patra. So I think we should learn from him. And before I'll start, grateful to Sahu sir because you know, a fellow state cousin brother from Odisha. So we know each other, so therefore he said I am a person of economics, public policy and communication में थोड़ी बहुत इंटरेस्ट रखता हूँ। therefore साहू सर से जब मुलाकात हुआ था आज से 7-8 दिन पहले, सर ने बताए थे आ जाने के लिए, इसीलिए मैं क्वांटम साइंस इसके ऊपर तो नहीं जाऊँगा। एक्सपर्ट बोले हैं, आपने सुने हैं, इतिहास बताया सर ने सुने, 20 मिनट तक बोले, आपने सुने हैं। सो मेरा यही कहना है कि मेरे टीचर को, साहू सर हमें जहाँ सब पढ़े हैं उड़ीसा से, हमारा टीचर भी बहुत कॉमन होते थे। मैं यंग रिसर्चर और मेरे प्रोफेसर साहब जो है बैठे हैं उनको बोलूँगा, जितना हम सिंप्लीफाई करके पढ़ाएंगे, जितना सिंप्लीफाई करके समझाएंगे, उतना पॉपुलैरिटी होगा। एंड आई वॉज टेलिंग हिम, आई शेयर माई एक्सपीरियंस, स्टडीड फ्रॉम ए गुड कॉलेज इन भुवनेश्वर। सो हमारे टीचर वहाँ पे जो क्वांटम साइंस की बात करते थे 12th स्टैंडर्ड में, आई एम टॉकिंग अबाउट 86-88, जब हम पढ़ते थे साइंस, 11-12 साइंस, 3 मार्क का सवाल आता था क्वांटम साइंस के ऊपर। हमारे टीचर समझाते थे कि भाई जब आप कॉइन टॉस करते हो, जब वो नीचे गिरता है उसका प्रोबेबिलिटी पता चलता है, हेड एंड टेल पता चलता है. जब ऊपर रहता है, जब घूमता रहता है, वी डोंट नो दी हैपनिंग्स. वही आगे चल के क्वांटम साइंस, क्वांटम फिजिक्स जब आप जो जाओगे पीएचडी करोगे पता चलेगा. हमें उतना ही मालूम था उस टाइम में क्वांटम फिजिक्स के बारे में, मेरे टीचर पढ़ाए थे. एंड आई रिमेंबर, वही मैंने साहू सर को बताया कि सर जब मैंने आपने कहा, मैंने जब मेरी 1-1.5 पेज की तैयारी किया, मैंने वहीं से शुरू किया क्वांटम फिजिक्स, क्वांटम साइंस क्या होता है. फिर उसी के साथ थ्योरी ऑफ रिलेटिविटी का भी हमारा टीचर ने बताया थे, मैं भी सर को कहा. नाउ टू द माई रिसर्च कलीग्स एंड द फ्रेंड्स, प्रोफेसर्स, साहब लोग ने तो बोले हैं, एंड द स्टूडेंट्स, थोड़ा बहुत जब आप क्वांटम साइंस, क्वांटम फिजिक्स इसके बारे में पढ़ते हैं, थोड़ा सा हिंदुस्तान का पॉलिसी उसके ऊपर क्या होता है वो जानना जरूरी है. आजकल क्या होता है, रिसर्च करने के चक्कर में हम फंड के पीछे चले जाते हैं, लेकिन हिंदुस्तान का पॉलिसी क्या होता है, हिंदुस्तान में क्वांटम को लेके आगे क्या फ्यूचर है, वो थोड़ा सा उसके ऊपर ध्यान रखिए. आई विल गिव एन एग्जाम्पल. जस्ट दिसंबर 2025 ये नीति आयोग एक IBM के स्पॉन्सर, IBM के जरिए से एक 45-50 पेज का एक ने इंडिया का हाउ इंडियाज क्वांटम प्रोग्रेस इज गोइंग टू टेक अस टू द नेक्स्ट वर्ल्ड, नेक्स्ट इकोनॉमी लेवल, उसके बारे में एक अच्छा रिपोर्ट दिए हैं. वहाँ पे देवजानी घोष जो है कंसल्टेंट है, उन्होंने एक अच्छी रिपोर्ट निकाले. मेरा जो वॉट एवर आई एम टेलिंग यू ऑन द बेसिस ऑफ दैट. एंड यू नो, बहुत सारे लोगों ने कहा है कितना पैसा का नेशनल क्वांटम मिशन में डाला हुआ है. पीपल हैव ऑल्सो सेड that how the quantum is going to help in the other industry, and all of us are aware digital public infrastructure में देश नंबर 1 है, AI के बारे में बता हुआ है. So मैं यही कहकर कंक्लूड करूँगा कि जो यंग स्टूडेंट है, जैसे सर ने बोले कि बेसिक साइंस की तो ज़रूरत है, वो आप पढ़ेंगे. एंड जितना सिंपल आजकल AI का आ गया है, भाषिणी है, सरकार AI मिशन के जरिए भाषिणी भी आ गया है. भाषिणी में आपने कोई भी लैंग्वेज में क्वांटम फिजिक्स के बारे में कितना सिंपलीफाइड लैंग्वेज में समझाना चाहेंगे, समझेंगे, सब अवेलेबल है. वो हमारा उतना इंटरेस्ट होना चाहिए भी कि हम फॉरेन ऑथर बुक पढ़ें, इंग्लिश बुक पढ़ेंगे, ऑल दिस थिंग, हिंदुस्तानी बुक पढ़ेंगे, लेकिन हमको पब्लिक को कैसे समझाना है. अगर वो आपने जब यंग स्टूडेंट के हिसाब से उसी हिसाब से आपने शुरू करते हो समझना एंड समझाना, देन यू नो, जैसे साहब लोग ने बोले, देर आर 40 odd institutes are there who are promoting quantum, the higher studies in quantum science, quantum technology, and also keep a track of the research development that is happening in the field of quantum science. So popularization of the science is important, science communication, the background of the seminar. And nowadays हम बात करते हैं popularizing quantum science और quantum science communication. जितना से keep it simple. So जितना हम रख सकते हैं उतना हमारे लिए भी अच्छा है, आने वाले पीढ़ियों के लिए भी अच्छा है, एंड देश के लिए भी अच्छे है. चलिए सब लोग खाने के लिए जाएंगे. थैंक यू वेरी मच. आई सेड आई विल नॉट टेक मोर देन 2-3 minutes and I stick to my point.
Okay, thank you so much. So thank for all speakers. So I have some small question for you, Mr. Sai Baba. So the question for you is, what skills as young researchers need to remain relevant in the quantum science and technology workforce? And you can give some advice for young people.
Yeah, I think a part of it I covered in my address. I think what is important to understand for students is quantum science and technology is not an independent the discipline which you should pursue. This is one clarity should be there. I told you the basis of quantum science and technology progress will be based on physics, mathematics, computer science, electronics, and mechanical engineering, which sometimes we ignore because all these cryogenics. So I would suggest that young students should keep awareness about the development in the quantum science and technology by attending meetings like this, or what is the progress that is happening in the domain of quantum science and technology. When you're doing that, strengthen yourself in any of these disciplines which I mentioned, so that you can pursue this as an expertise at a master's level. This is something which I want to appeal to all the students who want to pursue this. So basic understanding about these disciplines, and then specializing in this at a master's level. And then there are a lot of avenues where you can pursue masters in this in very reputed institutions, and that should be the way path ahead.
Thank you so much. So the second question, I would like to invite Dr. Chaksin, political, right? about you think that how can state-level innovation ecosystem, such as Central Excellence, Innovation Hub, scholarship, have to bring a future-ready quantum workforce?
Okay. Yeah. Sir, actually, like in our Gujarat state, the number of engineering students taking admission, say 1,000 students per year. Out of that 1,000 students, 40% of the students are taking admission in computer related courses like computer science, information technology, ICT, electronics, etc. And the rest of the students are taking admissions in our core branches. So now this particular quantum is a buzzword for all of us, including us also. So what we have to do is, we have to, as Sai Baba sir has mentioned, it should be introduced in a very gradual way. Say for example, our council has introduced this minor subject of quantum computing. So creating awareness in a small baby step would be desirable, would be better, because the faculties of computer science and information technologies are might be aware about this technology, but the faculties of other branches are not much aware about this. So first what we have decided is to give training to our faculty members. So in the month of February we will be having 5 days program for this quantum computing, which creates awareness about this technology for particularly faculty members of core branches. Those faculty members then will give, kind of ideas to the students about this technology. Moreover, what we are planning is, as sir has mentioned, about multidisciplinary approach. Like in the final semester, the students of undergraduates are having internship. So in that cases or before, in place of a student doing some kind of work alone, it is better that student of chemical engineering, mechanical engineering, electrical engineering, computer engineering combined together, jointly do some kind of work, and where this kind of technology would be incorporated. So that would be helpful them to think in the direction of innovations in quantum technology and computing. Thank you.
So thank you so much, sir. And the next question, I think that I'm going to ask Dr. Tucker and also Dr. You can say a little bit about economy. Okay. And the next lesson, let's focus on collaboration and real-life impact. And how can academic, government, and industry work together more effectively to turn quantum research in the real life for opportunity for young researchers? And you?
So it's a very good question. It is need of an hour also. So in India, we have that culture, but we need to really make golden handshake where industry and academia do a lot of collaborative projects. And by taking up these collaborative projects, actually they target the industry problems or the societal problems. Because any technology or any innovative solution, if it is not addressing the larger masses or the manufacturing need of a nation, it is not worthy of pursuing. So more collaboration, more industry-sponsored laboratories, more joint programs, more joint solution-based approaches will ensure that the entire ecosystem gets built up, and once the ecosystem starts building up, the academia and industry professionals will rub their shoulders together and will ensure that proper solutions get rolled out in the shortest possible time with the best of the optimizing industry or engineering approach. Thank you.
Now, my take to your question will be, as Saraj pointed out, industry, academia are definitely going to work, and they will rub their shoulder and all. But what is more important, I find, is how meaningfully it is being communicated or told to the citizens of the country. Now, industry academia will work, and who are the beneficiary? All of us are talking about Viksit Bharat 2047, and where the quantum science is going to be utilized more, and how it is going to improve, and what are the prospects in that particular sector, and if that can be communicated or that can be informed to the young researchers or young students, then I feel that will act as a icebreaker for the country. Mere doing a laboratory research, yes, it is good, and also industry academia partnership is good, but we have to go and find out where lies its importance, where is the interconnectedness, and how it is being communicated to the large part. If these three can work together, I think 2035 we are talking about some of the year for India. So another 6-7 years to go. If we can find it out that which are the sector going to benefit out of that and communicate accordingly, I think it will do a good things for the country at large.
I think I just want to add, as a role of a science communicator, is that today quantum science and technology possibilities are known, but the path to achieve is not publicized. I think you should not think that today we give money, tomorrow it will happen. I think it's very important for science communication community is that there are possibilities, but please be aware about the challenges to achieve it. I think this is very important. Otherwise, we all get impatient after some time. Arey, 6 crore de diya, 6,000 crores have been given, nothing is happening. So I think it's important to bring awareness about the difficulties or the challenges that are there in the path to achieve it. We have begun. That is something which you can communicate, but please bring awareness that yes, there are challenges, and we are all putting efforts to achieve, and then breakthroughs can be achieved. This is something very important to reach it out to the society.
Okay. So thank you to all panelists. So I would like to open the floor for question from our audience. So any question for speaker today? Okay.
Okay. I would just like to make a short comment. We have been paying so much of attention to this technology part, that is engineering courses, and this thing, introducing this new, technologies, quantum technology or quantum science in engineering. We are paying very little attention to basic sciences. See, it's really, technology is nothing but, it's applied science. So it's the basic science which we really need to, pay attention to. Today, just to cite an example, say in St. Xavier's College in Ahmedabad, in physics department, there are only about 15, 16 students. Just 15 or 16. What do we expect from them? So we really, unless we have some emphasis on basic sciences, unless some discovery or invention takes place in basic sciences, that can give rise to several technologies and several industries. It doesn't happen. I think our emphasis is lopsided. I think we need to pay more attention to basic sciences. And unless we do that, I don't think we are going to get anywhere. The students in science, our children, they have never experienced the thrill of science or a scientific career. Not that they are not interested, but then the kind of environment that we have in schools and colleges, we know, I don't have to say that. Say, but then I say now so that really, I mean, so rather than returning them, that really pushes them away from the school system or a college system. So they don't take up basic sciences. They prefer engineering because that gives them jobs. It happened in IT. When IT came, we have produced, I mean, say, perhaps thousands of, I mean, say, white-collar laborers for other countries. Okay. Well, I won't delve into it. I'll just make it a very blank comment. But then the point is that, say now, if some discoveries which has taken place in, say, Europe or, say, USA, that kind of basic discovery had taken place in India. Okay. Probably, I mean, say, now India could have been the world leader in that case. Why don't we do it? I think it's necessary to introspect on the part of the government, on the part of every individual. And then I will say now pay basic, attention and emphasis on basic sciences. That's more important as far as I believe. Thank you.
Thank you so much. Okay. Okay. So if we don't need to sum up. So due to time limited, if you have any other question, can you discuss together during lunch time? And I have give a conclusion for this section. And it is clear that young researchers have opportunity that but they need strong skill, adaptability, and cooperate with the industry. And I hope that in partner have the inspire young researchers to be confident and proactive in the future career. And thank you for all and enjoy your lunch now. Right? Thank you.
Thank you to the chair and panelists for offering practical guidance and inspiration to the next generation of quantum researchers. Now I would like to request the chair, Dr. N.T. Lan, Vietnam Institute of Science Information, Hanoi, to felicitate our esteemed members on the dais, starting with Dr. Sachin Parekh, Joint Director, CTE. Thank you, ma'am. Next, Dr. Chirag S. Thakur, Professor and Head, Computer Engineering, LD College of Engineering, Ahmedabad. Next, Professor Rasananda Panda, Mudra Institute of Communications, Ahmedabad. Dr. Sai Baba, Professor, National Institute of Advanced Studies, Bengaluru. Dr. Raja Ram Yadav, former VC, Purvanchal University, Uttar Pradesh. Thank you, ma'am. Now I would like to invite Dr. Narottam Sahu, Advisor GUJCOST, to felicitate Dr. N.T. Lan, Vietnam Institute of Science Information, Hanoi. Thank you, sir. Once again, I would like to thank all the panelists and chair. Thank you, everyone. With this, we break for lunch. An important announcement for the poster presentation participants that they are informed that the poster number 8, 13, 17.
We are ready to commence our next sessions. So, If I may be heard at the back, kindly have your lunch fast and come back. A young student who is in class 11 but a great enthusiast in quantum science. So he has prepared a small presentation for you all. So I would request you all to please look into his presentation and motivate him to make a career in quantum science. Utsav, you can begin.
चालू करना Namaste, I am studying in 11th grade. My name is Utsav Karya and I have done research on quantum physics by myself by studying at home through books. I have read books such as Nelson and Chuang in quantum physics, and as my path is quantum biology, I have studied Tortora and Campbell in biology. So we'll start with the presentation. If you think you understand quantum mechanics, you don't understand quantum mechanics. Richard P. Feynman. It is a very famous line by Feynman. No one understands quantum mechanics, he says. So to begin with, to try to understand quantum mechanics, we need to know how quantum mechanics came. What is the history of quantum mechanics? So in around 1890s, light bulbs were invented and it was the hot topic. So a German institute, PTR in Berlin, it plotted this graph using light bulbs. It is intensity versus wavelength at different temperatures. People tried to explain this graph. Rayleigh-Jean's law was given. Black body radiation laws were given. Next. This is the Rayleigh-Jean's law. It's derived using classical electromagnetism, and this law failed. This is the graph that was plotted through the law, and that is the experimental graph. We can see at longer wavelengths the law is followed, but at shorter wavelengths the law fails. So no one was able to explain why. Here we needed to introduce quantum mechanics. So as you can see, here Max Planck came and he tried to explain this graph so much, he was not able to explain it. And then out of act of desperation, he considered E is equal to h nu, where h is a constant and nu is frequency and E is energy of one quanta. This is the distribution, as you can see here. This is the distribution of quantas that are available, photons available over the energy or equal to the energy of a specific quanta. And using that graph, we were able to satisfy this graph using that equation. Then Planck gave this formula, and through this formula the H value was determined experimentally. Actually, the value is 6.626, but I have just kept another value of H and shown that this was how it was determined experimentally, the value of H. Then came de Broglie. De Broglie said that why we already knew that light showed dual nature, particle nature and wave nature. Then de Broglie came and said that matter waves, matter is itself a wave. Matter shows particle nature and wave nature both. But as the matter is huge, we everyone we have high mass. That's why we can't see our wavelength, and this is the formula for wavelength. Because our momentum is large because of the mass, we can't see our wavelength, we can't see our wave. Then came quantum states, dynamics and measurements. We'll move on to this is the Born rule, and this is the Schrodinger equation. This is the wave equation used in quantum mechanics. We are not diving into the maths. And this is the Born rule, where probability is equal to the amplitude square. Then we will talk about double slit experiment. When we don't observe in double slit experiment, we evaluate the electrons as wave functions. But when we observe, the wave function collapses and we don't see the fringe pattern we'll normally see in Young's double slit experiment. And here at any point, the probability of finding an electron is equal to psi 1 plus psi 2 the whole square. Here psi 1 and psi 2 are wave functions, and you can consider it as amplitude by keeping in mind the phase. Then came Feynman. Feynman said, if it's a very interesting fact, if you throw a light beam from there, point A to point B, then normally what we'll see is the light will travel in a straight line. But it is not actually true. Light will go to the sun and come back. That is one path. Light will go around me and go there. Light will go around you, everyone, and go there. All the possible paths are taken by light. And this is even experimentally proved. It is proved by this formula, and where S is the action function, and S is equal to L dot dt. L is the Langerian. Langerian you would have known if there is standard Lagrange model 2, if anyone knows. This is the derivation I have included in case anyone wants to see. This is how Feynman's path integral was derived, and he proved this is also experimentally proved, not only by formula. There was an experiment where we have a table, we put a mirror on that table and cover the mirror. Then when we pass laser through that mirror, we can experimentally prove that light takes all paths, not only the path that follows a straight line. Yes, and why do we see the path that takes the straight line, or the path of least action, I might say in science language? When it travels through air to water, different mediums, Snell's law is followed. Everything follows this because when S is very small, action is very small, the amplitudes line up, and what we see is the path of least action. Now we'll discuss the mathematical structure of quantum mechanics. Everything we observe is in Hilbert space. State vectors are in Hilbert space, and the observables are actually operators. We'll not move deep into the maths because we are running out of time. Bits, now we'll check on quantum computing. There is bits in classical computers, qubits in quantum computers. In quantum computers, psi is the state vector, alpha is the probability or the component of the state vector, I might as well say. along the 0 axis, and beta is the component of state vector along 1 axis, and alpha square plus beta square is equal to 1. This is just the probability because alpha is amplitude and beta is amplitude. So probability, the net probability is equal to 1. Then psi of this is just how we apply operators on state functions, state vectors. U is the operator, psi of 0 is the state vector before applying the operator, and psi of t is the state vector after applying the U. And unitary preserves probability. Ut is nothing but just the inverse of U, can say, of U, the operator. So there always exists U, and I have included examples of gates. There is head-mart gate, poly-X, and C0. I'll describe one. Head-mart gate rotates the axis of Hilbert space, you can say, by 45 degree. And we'll see further, head-mart gate and C0 gate are used to generate quantum entanglement. Then we have BBBV's theorem. This is in quantum computers. This is the limit to which a quantum computer can operate. It is the fastest it can operate is when it's proportional to under root of n. It is a standard symbol. People also use O of n instead of ohm of n. This is how fast a quantum computer can operate. Now, if we want to operate a quantum computer to this speed, we use Grover's algorithm. I'll describe Grover's algorithm here. No need to be scared of these equations. I'll explain. The first equation is initial superposition. This basically makes all the components of the state vectors equal to each other. This is you do not need to dive deep into the math, but you can know that yes, this it basically makes the state vector symmetric in the Hilbert space. Then there is the second equation. This is the Grover's operator. We are not diving deep, but I'll just say some. The first one operator is diffusion, and then it is oracle. Diffusion rotates the state vector about an axis, and oracle rotates the state vector about a different axis. That's how we move the state vector towards the answer. And this is the this is just the answer and of the Grover's algorithm, and this is the answer we get after the iterations. Yes, so this I have depicted a diagram. Omega perpendicular is the axis perpendicular to the answer, and omega is the axis of the answer. We rotate the state vector in such a way that the state vector moves towards omega, which is the answer. When it moves towards omega, the probability of getting the correct answer will increase. That's why you would have heard quantum computers can never always give the correct answer. There is always a probability of giving a wrong answer. Because it cannot go to omega directly, exactly. Then we'll see quantum entanglement. There is Bell state and classical analogy. This is not followed in quantum world. This one is followed. This, what I have depicted, is a superposition of qubits, you can say. That is how qubits exist actually. This is the entanglement non-separable state. This is the quantum state, and this is the classical state, as I said. This is it is not psi of AB is not equal to psi A XOR psi B in quantum state, but it is equal to in classical state. This is the Bell inequality. We don't need to know what is Bell inequality, but we can say Bell inequality proved, if Bell inequality was true, EPR would have been proved true. EPR said that EPR were basically protecting or defending relativity, because quantum entanglement was challenging relativity. EPR published a paper saying there is hidden information in quantum particles, and if Bell inequality is followed, it will be proved that yes, there is hidden information in quantum entanglement. Then, but Bell inequality is not proved in real life. So it was proved that quantum mechanics didn't follow the rules of relativity, and EPR were proven wrong. EPR are scientists, Einstein and two other. Then we'll see entanglement as a physical resource. Where is entanglement used? It is used in superdense coding, quantum teleportation, quantum cryptography, which is in QKD, then quantum computing. Then we'll see in quantum teleportation, this is basically the no cloning theorem I have said. We need to destroy the original state to teleport a particle. If I wanted to be teleport from here to there, what will happen is I will be destroyed and formed in the same way there. I will not see any change, but actually I will be dead and reborn. Then we'll check decoherence. Decoherence is actually what happens in real life. This first term is from the Schrodinger, I by h dash and whatever you can see. That is from the Schrodinger equation, and this another term is of decoherence. There is a loss of coherence in actual real life. Because it's not ideal conditions in real life. Some quantum entanglement energy goes in the environment through decoherence. Then I have included some quantum noise channels. The people who would have studied this would be familiar with this, but I am not diving deep. This is cross representation, trace preservation. This is amplitude damping channel, phase damping channel, and depolarizing channel. These are just the two forms of this. This is the matrix form. And the 5 equations we just saw are combined into one equation, which is the Lim-Blatt master equation. Then we have quantum error correction. So as I said, in real life, there is error in quantum computers. Bits are spin, 0 becomes 1 sometimes, 1 becomes 0. So to not do that, we make copies of the quantum qubits, and that corrects the copies. So we make 3 copies of this qubit. In the same way, this qubit has 3 copies, and we do. This is actually a big challenge in making quantum computers, because there is a large quantum error in real life. A qubit survives hardly microseconds, and we need to continuously correct the error for operating of quantum computers. And even after that, we are able to operate quantum computers hardly for 5 minutes after investing millions of dollars and maintaining the temperature very low, like 1-2 Kelvin. Then I have just included the basic state, the 2 qubit pure state. We will not dive deep in this. Then we'll check quantum effects in real living systems. This is where I have researched most, and this is where I want to research quantum biology. As I said, quantum computers can hardly operate till 5 minutes, but plants, these examples I have included: photosynthesis, avian magnetoreception, enzyme reactions, and olfaction. Here, everywhere, quantum entanglement is used at body temperature. Nature is able to use quantum entanglement at body temperature, but we are not able to achieve that. And nature prevents quantum error. We are not able to achieve that at room temperature. If we achieve that at room temperature, then there will be a big revolution. Today, sir was saying in virtual from Lucknow that there is we can't use quantum computers at our home. But if we take inspiration from plants, we can use quantum computers at home. We can operate them at room temperatures. We just don't know how plants do that. So if we find that, there will be a big quantum revolution and it will be a quantum age. This I have just included some formulas how it is done in photosynthesis in radical pair systems. Then, as I said, what are our limits? It operates hardly microseconds. There is quantum error in microseconds, so we can't operate quantum computers in real life at room temperature. The big picture. So quantum mechanics is not strange. It is fundamental, powerful and limited. From light bulbs in 1890, we went to the Lagrangian model and different theories which governs the real life. I would like to acknowledge everyone. I am representing Sri O.V. Shed Lokvigyan Kendra Rajkot and Dr. P.C. Vedya Center for Astronomy and Astrophysics. I would like to acknowledge C.A.K.T. Hemani, founder, trustee of Saurashtra Education Foundation and OVS Lok Vigyan Kendra. Dr. Anamik Shah, ex-Vice Chancellor of Saurashtra University. Dr. Mihir Joshi, Professor of Emirates Atmiya University. Dr. Ramesh Bhai Bhayani, Director OVS Lok Vigyan Kendra Rajkot, who have inspired and supported me for research and study. Minesh C. Meghani, Center Coordinator of Sri O.V. Shet Regional Science Center, Rajkot. Next. Thank you everyone for giving me this chance, and special thanks to GUJCOST for giving me the opportunity to give this speech in front of you everyone. Any questions? I would be pleased to answer. Anyone? Okay, thank you.
Thank you, Utsav. With this, we now proceed to an interactive session. It is our honor to invite Mr. Harish Yadav, a seasoned science communicator, for an interactive session focused on educators and students. His work emphasizes simplifying complex scientific ideas, fostering curiosity and engaging young minds. May I request Mr. Harish Yadav to kindly begin the session.
Check. Up. दोनों उस साइड थोड़े
हेलो हेलो और बाहर है
Magic can read your thoughts. Crazy, right? But what if I told you it's not magic? It's all about understanding the mind. Watch closely as I scan the audience. I see a thought. It's something personal, isn't it? You're thinking of a loved one. Now focus on that memory. Feel the connection, let it flow. And just like that, I reveal your thought. Want to experience this for yourself? Join me on stage and let's unlock your mind together. Imagine this. I can read your thoughts. Crazy, right? But what if I told you it's not magic? It's all
For our last interactive session of the conference, we have Mr. Harish Yadav, a seasoned science communicator since the last 35 years. He's retired from Dena Bank as chief manager. He has also authored 53 books and over 1,500 articles. Since last 25 years, sir is doing magic, and from the last 10 years, he's doing mind reading and mentalism. Sir is known for communicating science through magic. I kindly request you to, sir, to begin with the session. Help us in welcoming sir with a big round of applause.
हेलो, जय श्री कृष्णा। केम छो अहमदाबाद? सारो कुछ मजा हो जाए, कुछ एंटरटेनमेंट हो जाए आप लोग। यू आर डूइंग द ब्रेन स्टॉर्मिंग सेशंस सिंस यस्टरडे, तो आई थॉट कि थोड़ा सा आपको लाइट मूड में कर लिया जाए। इफ़ आई स्पीक इन हिंदी, ठीक है ना सबको? मुझे गुजराती नहीं आती है केम छो के अलावा। फर्स्ट, मैजिक आपने सबने देखा होगा, लेकिन यहाँ आपने एक मेंटलिज्म वर्ड देखा है। तो मेंटलिज्म और मैजिक में क्या अंतर है, और हाउ वी कैन कम्युनिकेट साइंस थ्रू द मैजिक, इसको थोड़ा सा हम 5-7 मिनट की एक पीपीटी देखते हैं, उसके बाद में शो शुरू करते हैं। आई लव साइंस, I love magic. Science is like magic but real. आर्थर सी क्लार्क बहुत बड़े वैज्ञानिक हुए हैं, उन्होंने कहा साइंस यू डोंट नो लुक्स लाइक मैजिक। और उनका जो थर्ड लॉ है वो कहता है एनी सफिशिएंटली एडवांस टेक्नोलॉजी इज इनडिस्टिंग्विशेबल फ्रॉम मैजिक। Magic like technology is a tool. One man's magic is another man's engineering. अब आप देखिए, डेविड कॉपरफील्ड दुनिया का सबसे रईस और सबसे महान वैज्ञानिक हवा में उड़ रहा है। अपने थिएटर में लिटरली वो हवा में उड़ता है, और यहाँ इस लड़की के पेट में से भाला निकला हुआ है। बट ये लग रहा है आपको मैजिक, बट इट्स अनदर मैन्स इंजीनियरिंग। यहाँ पे इंजीनियरिंग है, साइंस है, सब कुछ छिपा हुआ है। तो मैजिक के पीछे बहुत सारी साइंस छिपी हुई है। मैजिक इज द परफॉर्मिंग आर्ट क्रिएटिंग द इल्यूजन ऑफ इम्पॉसिबिलिटी ऑफ सुपरनेचुरल। शुरू से ही हम सिंस जब से प्रकृति का हमारा एडवांसमेंट हुआ है, सूर्य, चंद्रमा, ज्वालामुखी, तूफान, सबको हम एक मैजिक की तरह समझते रहे कि जाने क्या हो गया, सूर्य उदय हो गया, सूर्य ग्रहण हो गया, मैजिक की तरह मानते रहे। वन शुड नोट दैट अनलाइक सो कॉल्ड साइकिक्स, मैजिशियंस डू नॉट क्लेम टू पजेस सुपरनेचुरल पावर्स। मैजिशियन और मेंटलिस्ट के पास कोई सुपरनेचुरल पावर नहीं होती है। दिस इज ए डिस्क्लेमर। हम कोई तांत्रिक, कोई बाबा, कोई सुपरनेचुरल पावर वाले नहीं है। इट्स एन स्किल, इट्स कैन आर्ट, मैजिक एन आर्ट, एंड इट कैन बी लर्न। आई हैव लर्नड इट, यू कैन लर्न इट। Magic tricks are very useful because they help scientists understand how the human mind works and how we perceive phenomena. मैजिक और साइंस में क्या तारतम्य है, साइंस के लिए मैजिक क्यों जरूरी है, मैजिक के लिए साइंस क्यों जरूरी है। एंड साइंस कम्युनिकेशन, जो मेरा काम है, साइंस कम्युनिकेशन, थैंक्स टू डॉक्टर पटेरिया मुझे इस क्षेत्र में लाए। साइंस इज नॉट फिनिश्ड अंटिल इट इज कम्यूटेड। जब तक आप साइंस को कम्यूट नहीं करेंगे, जब हम 2 दिन से यही कह रहे हैं कि जब तक साइंस को कम्यूट नहीं करेंगे, साइंस का काम अधूरा है। इफ़ यू कांट एक्सप्लेन इट सिंपली, यू डोंट अंडरस्टैंड इट वेल एनफ, अल्बर्ट आइंस्टीन कह गए हैं। एंड मैजिक कैन बी यूज्ड फॉर कम्युनिकेटिंग साइंस through various social and scientific messages. हाँ, मैजिशियन के पास में आपने देखा होगा कि बहुत सारी चीज़ होते हैं, डब्बे वब्बे होते हैं, सब कुछ होता है। तो मैजिशियन क्या करता है? विजुअल इल्यूजन्स। विजुअल इल्यूजन्स क्या है? खाली डब्बा आपने मैजिशियन ने दिखाया, छोटा डब्बा है तो काफ़ी सारा सामान निकाल दिया, फ्लावर्स वगैरह निकाल दिए, रैबिट निकाल दिया। अब बड़ा डब्बा है तो लड़की निकाल दी। तो कहाँ है लड़की और सब डब्बा सब सामान वही है ना, आसमान से तो नहीं आ रहा, बट दैट इज द विजुअल इल्यूजन्स एंड ऑप्टिकल इल्यूजन्स. दे आर यूजिंग विजुअल इल्यूजन्स एंड ऑप्टिकल इल्यूजन्स. यहाँ पे हमारी साइंस काम आती है. एंड कॉग्निटिव इल्यूजन्स, ऑफ कोर्स वी यूज कॉग्निटिव इल्यूजन्स. स्पेशल इफेक्ट्स होते हैं, सीक्रेट हमारी डिवाइसेज होती हैं कई बनी हुई, मैकेनिकल गिमिक्स हैं, और इन दिनों इलेक्ट्रॉनिक्स का भी काफ़ी यूज हो रहा है. हाँ, अब आ गए हम मेंटलिज्म में कि व्हाट इज मेंटलिज्म. मेंटलिज्म इज ए ब्रांच ऑफ स्टेज मैजिक. मैजिक का ही पार्ट है मेंटलिज्म. इट्स ए परफॉर्मिंग आर्ट दैट गिव्स द इल्यूजन ऑफ द यूज ऑफ साइकिक पावर्स. मेंटलिज्म क्या है? दिस इज एन इल्यूजन. आई क्रिएट एन इल्यूजन इन योर माइंड दैट आई कैन रीड योर माइंड. वैसे तो कोई किसी का माइंड नहीं पढ़ सकता है, नेवर, बट ए मेंटलिस्ट क्रिएट्स एन इल्यूजन दैट ही कैन रीड योर माइंड. ट्रूली स्पीकिंग, मैं मेरी पत्नी का माइंड आज तक नहीं पढ़ पाया. यस, माइंड रीडिंग हम क्या काम में लेते हैं? माइंड रीडिंग, डिविनेशंस, प्रेडिक्शंस, टेलीपैथी, साइकोकाइनेसिस, मेमोरी फीड्स, रैपिड मैथमेटिक्स, क्लेयरवॉयंस, ट्रांजिशन, ट्रांसपोजिशन, टेलीकाइनेसिस, मीडियमशिप, आदि इनमें से कुछ चीज़ें हम यहाँ देखने वाले हैं. एंड की स्किल्स जो हम काम में लेते हैं: सजेशंस, मिसडायरेक्शन, बॉडी लैंग्वेज, वर्बल एंड नॉन वर्बल डिसेप्शन, साइकोलॉजी, ड्यूअल रियलिटी, शोमैनशिप, इन्फ्लुएंस, एंड और जो मैं आपको बताना नहीं चाहता वो लास्ट हुआ है. सो लोग आप पूछते हैं कि आपने कैसे किया, कैसे किया, क्या किया, तो उस बात को ये समझ लें कि हम इन चीज़ों का उपयोग एक एज ए माइंड रीडर करते हैं. कुछ चीज़ें जो हम करने वाले हैं, जहाँ साइंस को मेरा काम है साइंस को उसके अंदर इन्वॉल्व करना, क्योंकि मैं एज ए साइंस कम्युनिकेटर हूँ, तो मैं थोड़ा सा आपको बताऊँगा कि इनविजिबल टच, इलेक्ट्रोमैग्नेटिक रिपल्जन, क्वांटम साइंस. अब क्वांटम पे हम बात कर रहे हैं 2 दिन से. तो quantum science reveals that our sense of touch is not true contact, but electromagnetic repulsion between electrons and invisible force keeping atoms apart, creating a sensation of solidarity. हिंदी में कहूँ, हम अगर किसी को टच करते हैं तो हमें टच तो महसूस होता है, ये सॉलिड महसूस हो रहा है, लिक्विड महसूस हो रहा है, लेकिन क्वांटम साइंस के अनुसार जो हमारे इलेक्ट्रॉन्स हैं बिल्कुल हमें आपस में रिपल्जन करते हैं और एक सॉलिडिटी का इफेक्ट देते हैं. इस कारण हमें टेक्सचर और दूसरी चीज़ पता पड़ती हैं. यहाँ हम क्वांटम साइंस का उपयोग करते हैं. ये पॉलीज एक्सक्लूजन प्रिंसिपल, क्वांटम से रिलेटेड मेरे सब साइंस स्कॉलर्स बैठे हैं. तो दिस प्रिंसिपल फर्दर प्रिवेंट्स इलेक्ट्रॉन्स फ्रॉम ऑक्यूपाइंग द सेम क्वांटम स्टेट, एडिंग द रिपल्सिव फोर्स दैट फील्स लाइक सॉलिडिटी. ये पॉलीज एक्सपेरिमेंट, इसके साथ जो इनविजिबल टच है, एंड इसके साथ परसेप्शन है. साइकोलॉजी का बहुत यूज होता है. परसेप्शन, योर ब्रेन इंटरप्रेट्स दीज पावरफुल इलेक्ट्रोमैग्नेटिक इंटरेक्शंस एज प्रेशर, टेक्सचर, टेम्परेचर, गिविंग द इल्यूजन ऑफ टच. आपको लगेगा इन चीज़ों का उपयोग होता है. एंड लास्ट में मैं बोलूँगा टैक्टाइल गेटिंग, सजेशन, एंटिसिपेशन आर ऑल्सो इंक्लूडेड हियर. टैक्टाइल गेटिंग जो सीनियर्स हैं मेरे वो सब जान जाएंगे. एंड ESP, एक्स्ट्रा सेंसरी परसेप्शंस. ESP is called paranormal ability pertaining to reception of information not gained through the recognized physical senses but sensed with the mind. ESP का बहुत उपयोग होता है इसमें, और 1930 में डॉक्टर J.B. राइन ने इसको आविष्कार किया था. और इसमें ये 5 कार्ड होते हैं, सर्कल प्लस वेवी लाइन्स, square and star. We will do something with that ESP also today. Ghost bell, अपने बेल जो बजती है, mentalists exploit cognition biases like expectations and inattention blindness to create the illusion of supernatural ringing. अभी आप इसको भी एक एक्सपेरिमेंट हम इसका करके देखेंगे घोस्ट बेल के लिए. एंड क्वांटम फिजिक्स टेक्स इट फर्दर. बेस्ट थ्योरम proves spooky actions at a distance where entangled particles react instantly no matter the gap, your thought entangled with the bell's hidden resonance. No matter the gap word को याद रखिए, electromagnetic particles जो आप generate करते हैं, and today your brains EMFs like weak Wi-Fi and infrasound हम trigger to bell the ring, एक experiment करके हम देखेंगे. And hacker आप जानते हैं कि बहुत hacker से हमें रहना चाहिए, तो hackers पे बाद में बात करते हैं. And disclaimer शो शुरू करने से पहले, I do not claim nor possess any psychic powers. मैं दोबारा बोलता हूँ, I do not claim nor possess any psychic powers, and the act you are going to witness is achieved by the techniques of magic, illusion, mentalism, psychology, trickery, and verbal deception. So that's it. So friends, enjoy the science, enjoy the magic, enjoy the mentalism, enjoy the magic in your life. Enjoy. Now the enjoy part starts. Thank you very much for the PPT. इस पे फर्स्ट पे प्रीवियस पे ले आए. बस that will do. मैं एक चीज़ बताना चाहूँगा कि मेरा शो मैजिक नहीं है कि डब्बे में से निकाल लिया कर लिया. इट्स एन इंटरैक्टिव शो. मेरा हर चीज़ इंटरैक्टिव है. इसलिए जब मैं आपको बुलाऊं तो मेरी आपसे रिक्वेस्ट है कि एक बंदा, दो बंदा, तीन बंदे, जितने भी मैं बुलाता हूं, वो कृपया मंच पे दौड़ के आएँ, भाग के आएँ. हमारे पास समय कम रहता है. हम चाहेंगे कि आपको अच्छे से अच्छी चीज़ दिखा सकते हैं. सो शैल वी स्टार्ट? आर यू रेडी? आपसे जोर से तो मेरी आवाज़ है. आर यू रेडी? यस. आई नीड 5 persons. Ladies may be there, gents may be there. Any 5 persons are all invited. आइए. 5 persons, please come. Please join the stage. एक हैंड माइक दे दीजिए मुझे प्लीज, और एक जना मेरे असिस्ट करने के लिए आ जाएं, मेहरबानी होगी. 3, 2 more. Yes, ma'am. Please. I welcome you on the stage. Thank you for coming over here. These are my business cards. And ma'am, I am giving you my business card. थोड़ा थोड़ा स्पेस लेके खड़े हो जाओ. हाँ, श्योर. थोड़ा सा प्लीज. माइक आप हाथ, हाँ नहीं, यू डोंट नीड इट. उनको दे दीजिए माइक. बस
उनको नहीं चाहिए,
किसी को नहीं चाहिए. आप रखिए, मैं मांगू जब आप यहीं खड़े रहें प्लीज. मैंने आपको अपने बिजनेस कार्ड दिए हैं. एंड दीज आर 5 कलर पेन्स. क्या करना है, अपनी जगह पर खड़े रहें. आप आना आगे, जिसको जो पेन चाहिए दे देना. ठीक है? यू कैन चूज एनी कलर. ओके. उसके बाद में आपको क्या करना है, बिजनेस कार्ड के पीछे की तरफ यू कैन राइट एनीथिंग, व्हाट एवर यू वांट. क्वांटम फिजिक्स लिखेंगे तो चलेगा, केमिस्ट्री लिखेंगे चलेगा, मेरा फोटो बनाएंगे तो चलेगा, राम नाम श्याम श्याम सब चलेगा. व्हाट एवर यू वांट. आप कोई डिजिट्स भी लिख सकते हैं, एनीथिंग. 1 या 2 भी लिख सकते हैं. इस पर इतनी जगह, 2 से ज़्यादा की जगह नहीं है. तो आपको ये कार्ड करना है. उसके बाद में आप क्या करेंगे, पेन ले लेंगे, सबसे वापस मिक्स करके यहाँ रख देंगे. फिर उसके बाद सबसे बिजनेस कार्ड ले लेंगे, मिक्स करके शफल करके रख देंगे. मुझे पता नहीं कि किसके पास कौन सा बिजनेस कार्ड है, किसके पास कौन सा पेन था. उसके बाद में हम सोचेंगे क्या होता है. तो आई विल टर्न माई हेड ओवर. आप कोई सा भी पेन एक एक सेलेक्ट कर लीजिए, कुछ भी लिखिए, थोड़ा सा स्पेस लेके खड़े हो जाए मैम, थोड़ा सा, इट विल लुक बेटर. हाँ, है ना. और बाद में आप कोई कलेक्ट करना है, सबसे कार्ड दे दीजिए. आई डोंट लुक. तो हमारे दोनों विदेशी मेहमान चले गए बाहर. एनीवे, हो जाए तो मुझे बता दीजिएगा. अपनी जगह खड़े रहें। ये बच्चा सबसे जो लास्ट में है ये ले लेगा आपसे। पेन मिक्स करके टेबल पर रख दीजिए, मुझे पता नहीं किसने कौन सा पेन लिया है। और कार्ड मिक्स कर दीजिए, मुझे भी पता नहीं किसके पास कौन सा कार्ड था। डन? कैन आई? ऑलमोस्ट। आप पूरा हो जाए जब बता दें। हो गया जी? पेन तो रख दीजिए, पेन, आई डोंट नीड पेन्स। यस, ये आपने शफल कर दिया, मैं और शफल कर देता हूँ। ठीक है, एक उसको राइट में रख लेते हैं, ये लीजिए। ठीक है, अब मुझे पता नहीं कि किसने क्या लिखा है, किसके पास कौन सा कार्ड था, बट आई विल ट्राई टू रीड द माइंड। दिस इज द फर्स्ट कार्ड मेरे पास जो है। और कई बार क्या होता है कि बड़ी पुरानी कहावत है कि खरबूजे को देख के खरबूजा रंग पलटता है, लेकिन ऐसा नहीं है। कई बार ये होता है कि जो पड़ोसी है ना, उसका इफेक्ट आपके ऊपर डालता है। ये किसी ने हरी शाही से लिखा है, लेकिन उन्होंने हरे कपड़े नहीं पहन रखे हैं, वो हरे कपड़ों के पास में खड़ी हैं, उन्होंने लिखा है साइंस सिटी। एंड ये दूसरा कार्ड है, शी हैज चूजन द ब्लू कलर। ब्लू कलर वेरी कूल, शी माइट बी वेरी कूल इन नेचर। अब इन्होंने जो एक नंबर लिखा है, पता नहीं क्या लिखा है, बट आई थिंक कि वी आर लिविंग इन 2025। इन्होंने लिखा है 25। इज दैट करेक्ट? ये जो मुंह फाड़ने वाले है ना, यही एक्शन चाहिए मुझे। फोटोग्राफर साहब मिल जाएंगे तो आई विल बी थैंकफुल, पर्सनली थैंकफुल टू यू। ये तीसरा मेरे पास है। आहा, क्या बात है, ये तीसरा मेरे पास है। और किसी जवान बच्चे के पास ये गया है, और कलर बड़ा इन्होंने रोमांटिक लिया है, और एक इन्होंने सुपर जो पावर्स, जो सुपर कैरेक्टर्स होते हैं फिल्मों के, उसके बारे में लिखा है। एंड इन जनाब ने लिखा है बैटमैन एंट्रोपी गुलाबी कलर से। इज दैट करेक्ट? तालियां इसके लिए। ये कार्ड मेरे पास है। क्या बात है, बड़ा लाल कलर चूज किया है इन्होंने। और मुझे पता नहीं कि लाल कलर क्यों चूज किया है, लेकिन इन्होंने बड़ी कहानी सी लिख दी है। पेंगुइन के बारे में कुछ लिखा है। आई विल वांट टू राइट हियर, मुझे पता नहीं क्या लिखना है, लेकिन उन्होंने लिखा भी यही है कि मुझे पता नहीं क्या लिखना है, और ये हंस रहे हैं, इन्होंने ही लिखा है। थैंक यू। और आपके लिए तो कोई चॉइस बची नहीं, सॉरी जेंटलमैन, आपने क्वांटम लिखा था, लेकिन क्वांटम का नंबर सबसे लास्ट में आया है। थैंक यू जेंट्स, जेंटलमैन एंड लेडीज कमिंग ओवर हियर, यू कैन कीप द कार्ड्स। थैंक यू। Again 5% please, come fast. Ladies may also come. Yes, gentlemen, please make a line. अरे आओ यार, जो आ जाए वो कृपया करके दोबारा मत आए, क्योंकि दूसरों को मौका मिलेगा। आ जाइए, आ जाइए। हाँ, प्लीज प्लीज डू कम। 1 2 3 4, 1 मोर। एक और आ जाओ, पीछे से क्यों शर्मा रहे हो, आ जाइए। Please, yes. Well, I welcome you on the stage. Thank you for coming over here. And here is a bag. It's empty. कुछ है तो नहीं इसमें, देख लीजिए by the way, वैसे कुछ है नहीं. And here I have, gentlemen, 5 balls here. 4 are marble balls, 1 is black, 4 are white. Okay, I'll put them inside it, roll it. You can take any one. लेकिन आप क्या कीजिए, हाथ डालिए, मुट्ठी से बंद रखिए, और आपको भी पता नहीं, मुझे पता नहीं, अंदर से मुट्ठी बंद कर लीजिए, अंदर से निकाल के हाथ को स्ट्रेट रखिए. I don't know, you don't know कि which ball you have chosen. Okay, I will not see also. Take anyone, दो मत लेना. हाँ. Don't pick, please. Please don't pick. Anna, please don't pick. Okay. So look towards me. We'll start with 2. कपड़े आपने ब्लैक पहने हैं, लेकिन आपके पास ब्लैक बॉल नहीं है, आपके पास व्हाइट बॉल है. ओपन योर हैंड. सी. Oh, yes. बोलिए ब्लैक वाइट बोलिए. ब्लैक, अरे ब्लैक वाइट दोनों बोलिए. अब आप वाइट बोलने जा रहे हैं तो वाइट ही है आपके पास. खोलिए. यस. मैं बोलता हूं, मेरी तरफ देखिए. ब्लैक वाइट ब्लैक, ब्लैक वाइट ब्लैक. नहीं, ब्लैक नहीं है, वाइट है. Yes, 2. Last 2. Both are wearing black trousers. One is having a black ball, one is having white. Sir, you are having white, you are having black, ma'am. Yes. Yeah. Thank you. Thank you for coming over here. Thank you. You can. How did you find it? वो मैंने बताए थे कैसे तरीके हैं. वो पहले बताए थे. Now, one boy, one girl, please. One boy, one girl, please. या एक लेडी भी आ सकती हैं. एक लेडी आ जाइए, कोई भी एक लेडी आ जाइए प्लीज. अगर आप देर से आएंगे ना तो अभी सर कह देंगे सेशन का टाइम खत्म हो गया है. हर्षद भाई कहाँ हो? हाँ आओ, इधर आओ जरा. ये सब निकालो एक बार प्लीज. हाँ वेलकम. नहीं हर्षद भाई, ये सब निकाल को उधर लगा दो, इसकी जरूरत नहीं है. हाँ, वन बॉय मे कम. एक लड़का आ जाए तो अच्छा है. आ जाइए. आ जाइए, आ जाइए. आप आ रहे हैं, क्या बात है. आ जाइए, आइए, वेलकम. ये अगर गुजकोस्ट वाले आएंगे, दूसरे नहीं आएंगे तो फिर कहेंगे ये मिली भगत कर रहे हैं. हाँ कैसे भी लगा दीजिए फटाफट. हाँ हो गया होगा, लगा दो. राजस्थान से आया हूँ, कुछ रंगीन पोटलियाँ लाया हूँ. और मैम, अगर आपको कुछ पीने को दिया जाए, फ्रूटी, मैंगो फ्रूटी और लीची, व्हाट विल यू लाइक? क्या पीना पसंद करेंगे, फ्रूटी या लीची? मैंगो फ्रूटी, यू विल लाइक द मैंगो फ्रूटी। ओके, मेरे पास ये 10 बैग हैं, 10-12 जितने भी हैं, मुझे पता नहीं कितने हैं। और अब हम दोनों एक खेल खेलने वाले हैं। आप कोई भी एक निकालेंगे, अगर उसमें से फ्रूटी निकलती है तो यू कैन कीप इट ऑन योर डेस्क चेयर। अगर फ्रूटी नहीं निकले, लीची निकले, तो ये डस्टबिन में जाएगा। ऐसे ही आपके पास लीची है, उन्होंने फ्रूटी ले ली तो लीची आपके पास बची है ना। तो अगर लीची निकलती है यू कैन कीप, और नहीं है तो इस डस्टबिन में डाल दें। यस, एक बाई एक, 1 by 1, यू कैन चूज एनी बैग, फास्ट खोलिए। इट्स फ्रूटी, यू कैन कीप इट, यू कैन थ्रो इट हियर, आप वहां रख दीजिए अपनी फ्रूटी। यस सर, नेक्स्ट। मुझे पता नहीं किसमें क्या, इनको भी पता नहीं है। लीची रखिए। यस, लीची आप इसमें जाएगी। यस, एक मिनट, 1 by 1। लीची यू कैन कीप इट, फ्रूटी यू कैन कीप। यस, keep it, यस। बराबर चल रहे हैं दोनों, 4-4, 3-3, वो हार रही हैं मैडम। फ्रूटी बराबर हो गए। फ्रूटी यू कैन ड्रॉप इट हियर, you can keep, you can keep, you can, and then last, leave it here. So how many fruity you have? 6. And how many lychee?
5.
There were few bags here. मुझे पता नहीं था किसमें कौन सा है, फ्रूटी है यह है, और आपने अपनी मर्जी से उठाए हैं, मैंने आपको फोर्स नहीं किया। मुझे पता नहीं था कि आप कौन सा बैग उठा रहे हैं, कौन क्या कर रहे हैं, ठीक है। एंड सिंस द स्टार्ट ऑफ द एक्ट आई हैव दिस इन माय हैंड, ओके, डस्टबिन। लेकिन ये डस्टबिन बड़ा काम का है। मैं इसमें से ये जो फालतू चीज़ ये निकालता हूँ, और इसमें से एक प्रिडिक्शन मेरा पहले रखा हुआ, और तो नहीं है, 2 तो नहीं है, देखना एक ही है ना, एक ही है। My prediction says the lady will start with mango fruity. इनको mango fruity पसंद आएगा। The lady will win, यही जीतेंगी, and the lady will win by 1 mango fruity. मुझे पता था कि एक से जीतेंगी। ये कोई सा भी चुन सकते थे, कितना भी रह सकते थे, इनके पास कुछ भी आ सकता था। A very random number, very random choice. Thank you for coming over. You can leave. ये सब, and you can distribute them. बच्चों को दे दीजिए, मुझे तरफ से कोई, मुझे I don't need it. You can बाकी ये मेरे बैग्स इसमें डाल लें प्लीज, बैग से डाल दीजिए। Yes, I need 1 boy, 1 girl, please. Please come fast. आ जाइए, 1 boy, 1 girl. Please do come. एक लेडी आ जाए प्लीज। आ जाइए मैम, आई वेलकम यू। योर गुड नेम? वीना पटेल मैम के लिए तालियां बजा दें। एंड योर गुड नेम? बलवन। बलवन जी, बलवन जी के लिए भी तालियां बजा दीजिए। एंड मैम, मैंने अभी यहाँ पे जो ऑडियंस बैठी हुई है, आई डोंट नो कि ये आपके पास गए थे कि नहीं गए थे, कुछ लोगों से हिंदी फिल्मों के गाने लिखवाए, नए पुराने, they were asked to write any song, a one-liner song, any one line, है ना? And I don't know what they have written, okay? And we are trying to do one experiment of telepathy with these. तो मैं रिक्वेस्ट यू कि इसमें से आप कोई भी एक दो चुन के देख लीजिए कि भाई ऐसा तो नहीं कि 10 के 10 लोगों को मैंने कह दिया कि आप सेम गाना लिखना, है ना? तो आप एक या दो उठा के और वापस इसको पर्ची को बंद कर देना, देख लीजिए, गाने का नाम देख लीजिए, देख लीजिए, मुझे को आई डोंट नीड इट, ठीक है? जो भी जिसने लिखा है, जैसा लिखा मुझे पता नहीं, और डिफरेंट है ना, डिफरेंट है, ये 10 के 10 पर्चियाँ डिफरेंट लोगों ने लिखी है, अलग. नाउ प्लीज sit over here, please. And gentlemen, हाँ, एक आप आ जाइए माइक लेके प्लीज. You can sit over here. आप इधर बैठिए. मैम, ये 10 पर्चियाँ मैं इस बॉक्स में डालते हैं, ठीक है? और ये शफल कर लेते हैं अच्छी तरह. आप आइए इसमें से और कोई सी भी एक पर्ची जो आप चाहती हैं, आंख बंद कर एक पर्ची निकाल लीजिए, कोई सी भी. कीप इट विद यू, ओके? एंड बैठिए प्लीज, माइक लेके यहीं खड़े रहें आप. ये पर्ची खोलिए, क्या नाम लिखा हुआ है गाने का मुझे पता नहीं है, कौन सी पर्ची है. कीप इट विद यू, डोंट शो मी. ये अगर आपको समझ नहीं आ रहा तो ये बता देगा, आपके कान में बता दीजिए इनके, डोंट टेल मी कि क्या किसी ने क्या हिंदी अंग्रेजी में क्या लिखा है. क्या नहीं आया समझ में? आ गया है ना? 2 लाइन बस, जो भी है एक या 2 लाइन लिखी हुई है. हाँ. आपको क्या करना है मैडम, ये पर्ची तो बंद कर लीजिए आप. आप अपने मन में ये गाना रिपीट करेंगी. मुझे पता नहीं आपने गाना सुन रखा है नहीं सुन रहा, आई डोंट नो, बट फिर भी आप रिपीट कीजिए एक बार अपने मन में जो लिखा हुआ है. अब मैं कोशिश करूंगा कि टेलीपैथी से इन सज्जन तक ये बात पहुंचे. मुझे तो पता भी नहीं, आपने पता नहीं कौन सी पर्ची निकाली है. सो जेंटलमैन, प्लीज क्लोज योर आइज, प्लीज बी रिलैक्स, ट्राई टू लिसन व्हाट शी इज सेंडिंग टू यू. मैडम आप भी आंख बंद करके जरा मन में रिपीट करते रहिए कि क्या वो भेज रही हैं, और यू ट्राई टू लिसन इट. ये कुछ भेज रही है गाना आपके मन में, और आप इस गाने को सुनते रहिए अपने मन में. आपको आ गया होगा समझ में गाना? आ गया सर? कुछ पल्ले पड़ रहा है? नहीं आया? हाँ या ना तो बोले. कुछ गाना समझ में नहीं आ रहा आपको? वो मैडम कंसंट्रेट कीजिए प्लीज कंसंट्रेट थोड़ा सा. आपको क्या प्रॉब्लम क्या है कि आपने वो गाना सुना हुआ नहीं है, इसलिए उनको प्रॉब्लम आ रही है. अगर वो आप गाना सुना हुआ होती तो आपको इतनी प्रॉब्लम नहीं होती है. प्लीज कंसंट्रेट लिटिल. इनको ये गाना आना चाहिए समझ में. नहीं? और कोशिश कीजिए. क्या? मैडम प्लीज ट्राई. मुझे लग रहा है थोड़ा मुश्किल है आपके लिए, पर मुझे भी मुश्किल है थोड़ा सा टाइम टेकिंग प्रोसेस है. यू माइट हैव हर्ड इट, आपको समझ में आ गया होगा वो गाना. मुझे पता नहीं क्या गाना है क्या नहीं है, बट प्लीज.
आई एम रिपीटिंग 3 वर्ड्स.
हाँ, कोई बात नहीं, ठीक है. नाउ प्लीज स्टैंड अप. और क्या गाना था मुझे पता नहीं है, मुझे भी पता नहीं है, बट अगर मैं 1 2 3 जब 3 बोलते हैं तो आप उस गाने की पहली जो उसमें लाइन लिखी हुई है बोलेंगे. आपने जो गाना सुना है आप वही गाना बोलेंगे और साउंड मिस्टर साउंड आवाज़ वाले नंबर 1 गाना मैं जब कहूँ जब चलाइए प्लीज़, नंबर 1 सॉन्ग प्लीज़। मैं आप कर लिए, अभी तैयार कर लिए, चलाना मत, मैं कहूँ जब चलाइए। यस मैम बोलिए क्या गाना है माइक पे।
अर्जन बैली में पैर जोड़ के
गंडासी मारी।
गंडासी मारी।
आगे क्या लिखा हुआ है? फिल्म एनिमल का गाना है। क्या गाना, आप यही गाना सुन रहे थे? यही गाना सुन रहे थे? साउंड प्लीज। लेकिन चलिए देर कर देते हैं जब तक मजा चला जाता है। लेकिन ये देखिए, इनको तो पता भी नहीं, ये दूर बैठे हैं। ये गाना याद आ गया, ऐसे क्यों याद आ रहा था? अगर आप थोड़ा जल्दी सुन लेती तो ये काम जल्दी हो जाता। कोई बात नहीं, कोई बात नहीं, कोई बात नहीं। लेकिन ए सॉर्ट ऑफ टेलीपैथी, इन्होंने गाना अपने मन में पढ़ा है एंड ही हैज रिसीव्ड इट। एंड जेंटलमैन, मैं यहाँ पे जो साइंस का जो बताना चाहता हूँ उपयोग, सिर्फ एक वर्ड कहूँगा, बीथोवन वाज डेफ। उसने 7 सिम्फोनी रची थी, लास्ट के 7 साल वो पूरा बहरा था, फिर भी उसने दुनिया का सबसे शानदार क्लासिकल म्यूजिक रचा। किस कारण रचा? वो कैसे सुनता था गाने? वो सुनता था बोन कंडक्शन के थ्रू। उसके पियानो से एक स्पेशल इंस्ट्रूमेंट उसके दांतों में लगाया जाता था और बाद में वो मॉडिफाई कर दिया गया था एक फ्रेंच साइंटिस्ट द्वारा, बोन कंडक्शन। एंड ये जो आज एक्ट हुआ है, कहाँ साइंस है मैं बता रहा हूँ कि आई हैव यूज्ड टेलीपैथी थ्रू द बोन कंडक्शन। थैंक यू फॉर कमिंग ओवर हियर। वन बॉय वन गर्ल प्लीज, वन बॉय वन गर्ल आ जाएंगे, आ जाइए। यार ये तो बड़े सुस्त हैं। मैं आप लोगों से ज़्यादा आपकी मजाक तो नहीं कर रहा, आ जाइए ना, पीछे से उठ के क्यों नहीं आ रहे हैं? एक आ जाइए, वन जेंटलमैन प्लीज, आओ दोस्तों। अगर नहीं आएंगे तो फिर मुझे बंद करना पड़ेगा, क्योंकि आई डोंट हैव चॉइस। मैं जादू नहीं निकाल रहा, सामान नहीं निकाल रहा। इफ यू आर नॉट इंटरएक्टिंग, सीनियर पर्सन्स कैन ऑल्सो कम, दे आर ऑल्सो वेलकम। प्लीज वेलकम। वन जेंटलमैन प्लीज। यस वेलकम। क्या नाम आपका? है जी? हितेश जी के तालियां बजा दें। वेलकम। आपका मैम? समीना मैम के लिए तालियां बजा दें प्लीज। एक टेलीपैथी का और दूसरा प्रयोग करके देखते हैं हम। आप अपना हाथ यूं रखिए और थोड़ा सा पीछे, इस चेयर को पीछे कर लें प्लीज, और आप भी अपना हाथ थोड़ा सा आगे करके रखिए, ठीक है? और आपको क्या करना है कि मैं आपको आंख बंद करेंगे आप, मैं कहूँगा जब, मैं आपको कहीं टच करूँगा, जब मैं पूछूंगा तब आपको बोलना है कि हाँ टच हुआ या नहीं हुआ कहीं पे, ठीक है? उसके पहले आपको ज़रूरत नहीं है बोलने की, मैं पूछूंगा तभी आप बताएं कि हाँ कहीं टच हुआ है, ठीक है? आंख बंद कर लीजिए। आप हाथ आगे रख सकती हैं चाहे तो, नहीं तो कोई बात नहीं। हाँ ठीक है, बी रिलैक्स। हाथ रख लीजिए, आप भी हाथ रख लीजिए, एक टेलीपैथी का हो जाएगा। चलो रखिए जरा, हाथ रखिए आप प्लीज। एंड कहीं आपको टच हुआ? हुआ, बस इतना ही बोलना है कि क्या आपको कहीं टच हुआ या नहीं हुआ। ओके? नहीं, मैं पूछूं जब, ठीक है? टच हुआ? आपके बाहर हाथ ले रहा हूं। आपको टच हुआ? हाथ पे टच हुआ अभी? कैसा लगा आपको? कुछ थ्रेड बाल लग रहा है आपको? ऐसा कोई बाल टच किया हो मैंने आपको? यस, यू कैन ओपन योर आईज। मैं तो आपके पास भी नहीं हूं। अभी तो 3 बार टच किया ना। मैं मैडम के बाल अपने हाथ पे टच कर रहा हूं सर। मैडम के बाल मैं अपने हाथ पे टच कर रहा हूं, आपको मैं टच भी नहीं कर रहा। आई एम स्टैंडिंग हियर। थैंक यू फॉर कमिंग ओवर हियर। थैंक यू। एक रिसर्च स्कॉलर आ जाएं फटाक से, एक बढ़िया सा काम करते हैं। आ जाइए। हाँ, वेलकम सर। क्या शुभ नाम है आपका?
दुष्यंत सिंह।
दुष्यंत सिंह जी के लिए
IIT गांधीनगर।
IIT गांधीनगर से। अच्छा, प्लीज वेलकम। बैठिए दुष्यंत सिंह जी, बैठिए आप। दुष्यंत सिंह जी, क्या आपकी क्वालिफिकेशन क्या है?
राइट नाउ आई एम पोस्टडॉक।
पोस्टडॉक हैं?
फिजिक्स।
इन फिजिक्स हैं।
PhD फ्रॉम IIT बॉम्बे।
गुड। IIT बॉम्बे से हैं, फिजिक्स में हैं और पोस्ट डॉक्टरेट की हुई है। अच्छा, एक काम करें मित्रों, अगर आप कहो, कितनी उम्र है आपकी? 33। अगर 33 इयर्स वाले को मैं मान लीजिए 3 साल 4 साल का बच्चा बना दूं तो कैसा रहेगा? कैसा लगेगा आपको, ये बताइए। कि मैं इनको एक छोटा बच्चा बना देता हूं तो कैसा लगेगा आपको, बताइए। यू विल फील गुड। ठीक है मित्रों, क्या होता है, हम जो बड़े हैं, किसी भी जो अंग्रेजी का को वर्ड लिखा हुआ है मैजिक फॉर, पूरा पढ़ सकते हैं, लेकिन 3-4 साल का बच्चा क्या होता है, वो अल्फाबेट तो जानता है बट ही कैन नॉट मेक ए वर्ड प्रॉपरली। वो अटक अटक के बोलेगा या उसको समझ में नहीं आएगा क्या लिखा हुआ है। ठीक है, तो जेंटलमैन आप अपनी आंख बंद करिए, थोड़ा सा रिलैक्स हो जाइए, पैर सीधे रख लीजिए आराम से। मैं आपको एक छोटा बच्चा बनाने वाला हूं और मैं आपको कुछ लिखा हुआ दिखाऊंगा। आपको वो पढ़ के, मैं कहूं जब आंख खोल लेना, अभी नहीं, और आपको वो क्या लिखा हुआ है वो पढ़ के बताना है। ठीक है ऑडियंस, you can see it, you can read it very well I think, and let me see कि what my friend sir, आँख खोलिए, पढ़िए क्या लिखा हुआ है। आँख खोल लीजिए, हाथ में रख लीजिए, कोई बात नहीं। क्या लिखा हुआ है? what word it is? Mike please, क्या वर्ड है?
SQPOG।
कंक्लूड। अच्छा 5 मिनट, गिव मी 5 मिनट्स। क्या नहीं समझ में आ रहा? एस्पिरिनोलॉजी। इनको कुछ समझ में नहीं आ रहा कि क्या वर्ड लिखा हुआ है। कोई बात नहीं, हम एक ट्राई करते हैं दोबारा और दोबारा आंख बंद कीजिए। ऑडियंस, यू कैन रीड इट प्लीज। वेरी वेल। देखें हमारे दोस्त क्या कर सकते हैं। लॉफिंगली, ये बहुत अच्छी बात है। अभी इनमें अभी आराम से पढ़ने में आ रहा है इनको। और अभी देखिए,
Matenuonka।
ये कौन सा वर्ड है?
This is unknown to me।
दिस इज नॉट
Unknown to me।
नॉट प्रॉपर वर्ड। लेकिन मैं अगर इनको ऐसे ही छोड़ दूंगा तो अच्छा नहीं लगेगा, और मुझे कंक्लूड करने के लिए चाह रहा है तो मैं थोड़ा सा जल्दी इनको सम कर देता हूँ। अभी हमको वापस ग्रोन अप मैन कर देते हैं, और वही कार्ड जो इनको अभी समझ में नहीं आ रहा था, अभी वो आराम से पढ़ेंगे। ऑडियंस, क्या यही वर्ड था?
मेंटेनेंस
वर्ड ही था जो इनको पढ़ने में नहीं आ रहा था। तो थैंक यू फॉर, अभी मैं इसको कंक्लूड करता हूँ।
But that was the different.
हाँ, यही तो डिफरेंस है कि दैट 2-3 साल के बच्चे का था और ये पूरा ग्रोन अप का है ना। अभी मैं इसको प्लीज, आई हैव टू कंक्लूड। नो, इट वाज सेम वर्ड बट रिटन डिफरेंटली। यू कैन प्लीज लीव द स्टेज, थैंक यू। अब मैं सिर्फ, अगर मुझे पटेरिया सर कहा तो गया था कि 1 घंटे का टाइम मिलेगा, पर इट्स वेरी स्ट्रेंज कि मुझे 20 मिनट में बंद करने को कहा जा रहा है। कोई बात नहीं, मैं कंक्लूड करूँगा। अच्छी चीज़ दिखाना चाहता था, रह गई है कुछ। लास्ट में मैं चाहता हूँ कि प्यार मोहब्बत की बातें कर ली जाएं। कौन आएगा मेरे साथ प्यार मोहब्बत की बात करने? हाँ, अच्छा, धवल जी आएंगे, क्या बात है, आइए। धवल, यू कैन टेक ए माइक विद यू। ये लीजिए, मेरे पास तो है। हाँ हाँ, हाँ सर
बोलिए।
धवल, आप क्या काम करते हैं?
सर मैं गुजकोस्ट में प्रोजेक्ट असिस्टेंट हूँ।
प्रोजेक्ट असिस्टेंट, कितने साल से नौकरी कर रहे हैं?
सर 6 महीने हुए।
6 महीने से नौकरी कर रहे हैं। और कॉलेज किया था आपने? कहाँ से?
यस, गांधीनगर IIT, इंडियन इंस्टीट्यूट ऑफ टीचर एजुकेशन।
अच्छा अच्छा, गांधीनगर IIT से। तो कॉलेज में लड़के लड़की काफ़ी होंगी, को एजुकेशन था?
हाँ सर।
प्यार व्यार भी किया ही होगा?
हाँ।
क्या है? और अगर धवल मैं आपको यह कहूं कि आप ये अपने मन में सोचिए कि आप कहाँ घूमना जाना चाहते हैं, देश विदेश कहीं पे भी, ठीक है? डोंट टेल मी, मैं जब तक नहीं कहूं। आप किसके साथ घूमना जाना चाहते हैं? जब आप घूमना जाना चाहेंगे तो आपको नगद चाहिएगा। कितना रुपया खर्च करेंगे? और अगर पिताजी दे रहे हैं जब तो कोई बात नहीं, नहीं तो आपको ATM से निकालना पड़ेगा। तो अपने ATM का पिन सोचिए। 4 चीज सोचिए, कहाँ घूमना जाना चाहते हैं, किसके साथ घूमना जाना चाहते हैं, कितना रुपया उस पर खर्च करेंगे, और आप का ATM का पिन भी हमें चाहिएगा, ठीक है? मन में सोच के रखिएगा। सोच लिया?
यस।
नाउ आइए मैदान में आ जाइए। यस, हाँ, मेरी तरफ देखिए। मुझे ऐसा लग रहा है कि आप इंडिया में तो नहीं घूमना चाहते, पता नहीं क्यों, है ना? गुजराती मानस है तो कहीं अभी जो छुट्टियां आएंगी, दिवाली के बाद नया साल, कहीं आप आउट ऑफ इंडिया जाएंगे। एंड आई थिंक दैट कंट्री इज इन एशिया। द नेम ऑफ दैट कंट्री स्टार्ट्स विद M, but it's not Malaysia. And you want to go to Maldives?
Yes, sir.
Yes. And आप किसके साथ जाना चाहते हैं? गर्लफ्रेंड के साथ?
Of course, sir.
Of course.
अभी शादी नहीं हुई है तब तक।
हाँ, शादी नहीं हुई जब तक। Yes. माँ बाप तो नहीं ना यहाँ पे? हाँ, ठीक है। So, the name of your girlfriend is a 5-letter word. Is that correct? है? ये नहीं है मतलब हैदराबाद स्टाइल में हाँ या ना क्या है?
नो सर।
नो, कोई बात नहीं। अंग्रेजी में, अंग्रेजी में कह रहा हूँ, हिंदी में नहीं कह रहा।
हाँ, अंग्रेजी में ही सर।
अंग्रेजी में अंग्रेजी में 5-letter वर्ड है।
अंग्रेजी में
हाँ, बस 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 इतना ही वर्ड। Last word is A.
Yes.
Last word is A. First word is D.
Yes.
Keep repeating in your mind. Repeat कीजिए, दिव्या दिव्या दिव्या, I want to go with you. Is that correct?
No.
दिव्या नहीं है? क्या नाम है?
मैं बता दूंगा तो सर आप क्या बताओ?
दिव्या नहीं है, मुझे तो लगता है कि आपका नाम दिव्या ही होना चाहिए था, पर हो सकता है कि आप कुछ और चाहते हैं। तो मुझे लगता है कि मुझे कुछ दोबारा कंसंट्रेट करना पड़ता है। दोबारा कोशिश करें। था तो 5 डिजिट वर्ड है ना? और क्या हो सकता है? लेट मी ट्राई। दिव्या नहीं है यार, थोड़ी सी गलती कर दी मैंने। दिया है।
यस सर।
ठीक है। अब पैसा बड़े इकोनॉमी गुजराती माने बहुत ज्यादा खर्च नहीं करेगा। मालदीव जाएगा, बीबी को लेके जाएगा, सिर्फ 1 लाख रुपया बस। बहुत कम है। एंड हियर कम्स द मोस्ट डिफिकल्ट पार्ट ऑफ द getting the ATM pin from your mind. Okay. Now, friend, this is 0, this is 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There is a 0, and look here. 0, 1, 2, 3, 4, 5. There is a 0 also again. एक 0 और है उसमें.
Yes.
एक 0 और है. बोलिए जरा 1, 2, 3, 4, 5, 6, 7, 8, 9 बोलिए.
1, 2, 3, 4, 5, 6, 7, 8, 9.
दोबारा बोलिए.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
8, 9. 8 is also there. Yes. अटके थे आप 8 के ऊपर अभी. सबने देखा आप 8 के ऊपर अटके थे. है ना? And again, keep the repeating 4 letters, 4 digits in your mind. Repeat. 0805, 0805.
Yes, right.
Please change it. मेरी जिम्मेदारी नहीं है, सबके सामने बोल दिया है. So, I have been asked to conclude. मेरे पास तो बहुत सारी चीज़ें थी, रह गई हैं मज़ेदार चीज़ें. एक लव स्टोरी और थी, पर रह गई है. खैर कोई बात नहीं. So, with your permission, मैं कंक्लूड करता हूँ. हो सकता है पसंद आया हो, और खास चीज़ें, अच्छी सी चीज़ें रह गई हैं. थैंक यू वंस अगेन गुजकॉस्ट. थैंक यू साहू सर. थैंक यू पटेरिया सर. एंड थैंक यू ऑल द एसोसिएट्स. And friends, thank you very much watching me. Thank you.
Thank you, sir. We extend our sincere appreciation to Mr. Harish Yadav, sir, for an engaging interaction and for presenting the magic of science. Now I would like to invite Dr. Narottam Sahu, sir, Advisor GUJCOST, to felicitate Mr. Harish Yadav, Science Communicator.
ये हो जान दो, फिर अपन साइड में रख के पैक कर लेंगे. एक बार रुक जाओ. ये इसको हटाओ, इसको पैक कर. Thank you, sir. Sir, my pleasure. Thank you. No problem. No problem. Sir, thank you.
Thank you, sir.
सबसे पहले माइक ले लो भैया. सबसे पहले तो
journey, I warmly welcome you all to the valedictory session of the Science Communication Conference on Public Understanding of Quantum Science and Technology, organized by GUJCOST under the Department of Science and Technology, Government of Gujarat, in collaboration with national and international partners. This conference has brought together scientists, communicators, educators, and young researchers to deliberate on how quantum science can be meaningfully communicated to the society.
I request our respected delegates to kindly take their seats on the dais as we announce their name. I request Chief Guest Shri B.S. Talati, IAS, Commissioner of Technical Education, Government of Gujarat, to kindly take their seat on dais. Guest of Honor, Dr. D. Pallam Raju, FASC, Senior Professor and Dean, Physical Research Laboratory, Ahmedabad. Dr. Manoj Kumar Pataria, President, Society for Information Science. Dr. Narottam Sahu, Advisor, GUJCOST. Dr. Poonam Bhargava, Principal Scientific Officer, Gujarat Council on Science and Technology. Again, help me welcoming all the delegates on the dais with a big round of applause. Thank you, everyone. To mark our respect and warm regards, we shall now proceed with the floral welcome of our distinguished guest. Now may I request all the dignitaries for the floral welcome. I request Dr. Narottam Sahu, Advisor GUJCOST, to welcome Chief Guest Shri B.S. Talati, IAS, Commissioner of Technical Education, Government of Gujarat, with a bouquet as a token of our respect and gratitude. Now may I invite Dr. Narottam Sahu sir again to kindly present a floral tribute to our guest of honor, Dr. D. Pallam Raju, FASC, Senior Professor and Dean, PRL, Ahmedabad. Thank you, sir.
To revisit the ideas, dialogues, and the milestones of the past 2 days, we now present a brief glimpse of the conference, capturing its spirit, discussions, and the collective learning. I request the technical team.
Thank you to the technical team. Now, to formally welcome the gathering and set the tone for this concluding session, I would like to invite Dr. Narottam Sahu, Advisor GUJCOST, to deliver the welcome address.
Good evening to everybody. Respected chief guest of today's valedictory session, Sri B.H. Talati sir, very senior government administrative officer. And presently, sir is taking care of Commissioner of Technical Education, Higher Education, Government of Gujarat. Our guest of honor, Sri Dr. D. Pallam Raju sir, Senior Professor and Dean, Physical Research Laboratory, Ahmedabad. President, Dr. Manoj Pataria sir, Society of Information Science and India International Science Writers Association. All our dignitaries, our guest speaker, panelists, our delegates, my colleagues from GUJCOST Science City, and our members from the media. So we are coming to this concluding session. We welcome from our the score knowledge support from these two days science education, quantum science education, research, development, innovations, as well as its intellectually property rights, plus science communication part and societal impact. So on this front, we would like to welcome our chief guest and our guest of honor and all our faculties. This 2 days program, as we are discussed from last day in this campus, it's a year-long collaborative approach with a different organization, different institution, different departments in the broad theme of International Year for Quantum Science and Technology. As we are coming to close this year 2025, but the program will be continued to, as per the UNESCO calendar, it will be continuing up to March 26. So that we will be not going by this calendar year, whether it is December or it is March, but our quantum communication will keep on going and keep on moving and keep on. We can also expect that quantum, we have to, sometimes we have to take the quantum speed. So these 2 days brainstorming session or the science communication conference, whatever we say, it opened the door, it is opened the platform for a common dialogue and discussion, how to discourse and discover new pathways to march ahead. We are very thankful to Government of Gujarat, Department of Science and Technology, and all Department of Education, Department of Technical Education. With this 2 days theme, we have imbibed the thought process and interact with the respective department heads of the institutions. So I think with this context, our process and our practice and our action plan will continue with the Department of Science and Technology, NQM, National Quantum Mission, our Technical Education, Higher Education Department, and all our science network communication that we have the networking this 2 days program here in Science City. So I once again congratulate all our young participants, those who are also come forward with a very short span of time and presented beautiful ideas and thoughts through posters. 2 of our young students from class 10 and class 11, they are also our colleagues, become this very good colleague in this quantum mission. So similarly with them we can capture a large number of young minds, just like a catch them young, so that all we can take or inspire or everybody can take that path of this quantum path, so that this 2 day program become a stepping stone or a game changer in our practice and our process. So I once again thank to all of you, all the delegates, all the dignitaries from Gujarat, from different states of India and different parts, different countries also, those who are here. And together we can make our quantum mission, as our Honorable Minister has expressed, that shared future for all. So let us work together and discuss together and try our best to convert all challenges to a very good opportunity for our our generations and for the years to come. So with this, I hope that this valedictory session will not concluding the thing, but it would be giving an action plan for our next mission. Thank you.
Thank you, sir. Reflect on the objectives, deliberations, and the outcomes of the conference. I now invite Dr. Manoj Kumar Pataria, President, Society for Information Science, to brief us about the two-day conference.
A very good evening to all of you. I am delighted to be at the last mile of this program, wonderful program, put together by GUJCOST, Department of Science and Technology, Government of Gujarat, all coordinating agencies. And I have the pleasure to have the privilege and blessings of Dr. Pallam Raju, FASC, Senior Professor and Dean, Physical Research Laboratory, Shri B.H. Talat, IAS, Commissioner of Technical Education, Government of Gujarat, my friend and colleague, Dr. Narottam Sahu, the coordinator of this program, very dynamic person sitting beside us, Dr. Poonam Bhargava, and all the team. Let me also place on record the cooperation of these partnering organizations like Indian Science Communication Society is represented here by its chief coordinator, Dr. V.P. Singh. The Society for Information Science is also represented here by Mr. Tariq Badr. The Indian Science Writers Association is also represented here by Dr. B.K. Tyagi of its Secretary General. And of course, the International Science Writers Association represented by me. So these are the 4 professional bodies who are interested in science communication, not only in India, but also collaborating abroad. I am very happy this collaboration with Gujarat Council of Science City is going well, and it will go a long way as far as the science communication, and especially the quantum communication is concerned. The 2 days program had a number of sessions, plenary talks by the experts. We have listened from the horse's mouth, those who are really involved in hardcore research and academics of quantum science and technology. They have been the expert, like Director PRL, other experts, professors, one working scientist from United Kingdom, London, he joined online. 2 of our colleagues from Vietnam and Nepal, they also graced the occasion, chairing a couple of interactive sessions. We had the honor of having a number of dignitaries like Vice Chancellor of some universities, professors, deans, academicians, scientists, our former advisor and head director Vigyan Prasad, Dr. Kamble is also here. I am very happy to meet all of them, and a kit developed by Dr. Kamble and Kathan Kothari and Abhay Kothari also worth mentioning, and that gives a lot of insight, especially for the youngsters, how to communicate quantum science to the students. And we would like to see that it is being translated in various languages, especially in Gujarati language. I was told that it is already there, the work is on. And some very good interactive session was also held under the chairmanship of Honorable Minister of Science and Technology, Government of Gujarat, in the forenoon. And certain very interesting and workable recommendations have emerged, especially from the participants, like constitution of a high-level advisory committee that can advise on various activities on quantum science and technology development, as well as its communication, international collaboration as far as research and academics are concerned, especially in quantum science and technology, startups, support for patents, teachers training program, quizzes programs involving lot many students and children from the various nooks and corners of the state, as well as having face-to-face programs with the scientists, involving them for essay writings, and not least but very important is a kind of networking of the people who are interested in taking part and contributing in such kind of activities. I think under the able guidance of the department, able leadership of Dr. Sahu, these things are going to be accomplished in near future. And with these words, I once again convey my heartfelt gratitude for all the organizations who have come together for this wonderful program. The program is organized. One icing on the cake was a mentalism show by our colleague, Mr. Harish Yadavji from Jaipur. The program also had a feature like puppet show, quantum communication by a puppet. So all these efforts needs kudos. Once again, thank you very much and wish you all the best. This is not, as Dr. Sahu has said, this is not the closing, this is beginning of our new mission, new vision and new programs to encourage especially youngsters for converting this country from developing country to the developed country. Sooner the better. Thank you very much.
Thank you, sir. It is now my privilege to invite our guest of honor, Dr. D. Pallam Raju, FASC, Senior Professor and Dean, PRL, Ahmedabad, to share his insights with the audience.
Chief guest, Shri B.H. Talati, IAS, IAS, Dr. Narottam Sahu, Dr. Poonam Bhargava, and Dr. Manoj Patariaji, dignitaries of the dais, students, educators, research scholars, invitees, ladies and gentlemen. Sadar Pranam and a very good afternoon to all of you. At the outset, I would like to thank Dr. Narottam Sahu for this kind invitation to me to participate in this wonderful conference on public understanding of quantum science and technology. This topic is highly timely and pertinent as we are celebrating the International Year of Quantum Science and Technology. I would also like to congratulate and commend GUJCOST for hosting this event in collaboration with UNESCO National Quantum Mission of Government of India. Well, probably you would have seen in a couple of days what has happened. Also, you would have studied, several of you, that the discovery of quantum mechanics began in 1900 with Max Planck's proposal that the energy is quantized, which was followed up by Albert Einstein's work on photoelectric effect in 1905. Then with the mid-1920s with Werner Heisenberg's matrix equations, Werner Schrödinger's wave equations, then Max Born with the probabilistic interpretation, and Pauli's exclusion principle, and so on. So we have come a long way. Even at those times, or even until a few decades ago, people would not have imagined the breadth and the science, the depth and the interdisciplinarity of the quantum science that has come about in this past 100 years or so. We stand today at a fascinating threshold. For a century, the principles of quantum mechanics have been confined mostly to labs and a strange, probably abstract construct and it may be a counterintuitive theory used to build the lasers and semiconductors that power our everyday lives. But now, I think after about a century, that is of the discovery of quantum science, I say this is the second quantum revolution, moving us merely from the using the quantum principles from scientific aspects to actively engineering them for unprecedented applications. And no doubt, I think the international body or UNESCO has recognized this importance globally, and this 2025 was nominated as the International Year of Quantum Science and Technology. So our journey into the quantum realm began with the study of nature at the smallest scales, atoms and molecules, how the photons behave, and it has lot of changes from classical way of understanding to quantum way of understanding. We learned about the superposition principles, the quantum bit idea of quantum bit, qubits having 0 and 1 at the same time, and also having possibilities of entanglement, being at two places at the same time. As these are kind of looks very abstract. Probably would have looked abstract a few decades ago, but now they are the reality. And these seemingly abstract things are no longer just a physics experiments, but they are blueprints for our future. It didn't say it, let it may be quantum computing. We are developing machines that harness superposition and entanglement principles to perform calculations that would take today's supercomputers a very, 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 very long time. These quantum computers could revolutionize various applications, drug discovery, climate modeling, material, and improving the energy resources by trying to find out what is the best way a battery can store a larger amount of memory, and also can heat less, and also it drains less. So these are all absolute real possibilities. In communications aspects, I think we have right from quantum key distributions, quantum entanglement, where any attempt by outsider intruder will be deftly known or clearly known, which has a lot of applications, not just from the security point of view, but from the strategic aspects as well. In quantum sensing, I think the sensors offer unprecedented precision, and which we couldn't imagine or think of so far. But there are several things. You put quantum aspects in many aspects of our daily lives. But this revolution is not just about the faster computers or better sensors or a better way of communication. It's about a shift in our human capability. It requires us to abandon our old assumptions and embrace new mindset of audacious aspirations. So the challenges are significant. Qubits are fragile, infrastructure is complex, and we need a new generation of skilled workers. We must bridge the gaps in research and education, fostering international collaboration and inspiring young minds. That's where I think the discussions in this conference would have helped and given a broad flavor of what it is. I was going through some of the topics covered in these couple of days. It's really amazing. I think really right from basics of what is quantum, right from double-slit experiments to the quantum computing and the state-of-the-art quantum applications, the kind of panel discussions over there and hands-on activities. It's really, I'm really impressed by the tremendous efforts put in by the organizers in stitching this two-day event. So quantum science reminds us that the universe is far stranger and more magnificent than we have ever imagined. It shows us that the uncertainty is not an obstacle, but a source of enormous possibilities. So as we move forward into the new age, let us carry the spirit of discovery and use the transformative power of quantum technology for the good of our planet and society. The time to invest in the quantum skills and infrastructure is now, not tomorrow. I think should be the urgency. I trust that this conference would have given you a broad idea of what is entailed in this mission. All of you who have participated are missionaries for quantum, mission, and advocates, or you should try to engage in building up this science, this technology. As you all go back to your respective duties in your schools, colleges, universities, organizations, please keep in mind the great potential that exists in this domain of research and development, so as to generate a human resource that's required to catch up with this, with the future demands. This conference would have also helped you in giving more contacts, have a networking. I would really, advise and encourage you all to keep in touch with each other, with what is happening in your institute or your organization, and then try to build up. As was also said, this is not the concluding ceremony, but this is a kind of initiation into the building up of this quantum mission and quantum science. This century is of India, with the young demographic advantage that we have. So I think we need to really keep up with this, and this is also essential for realizing the mission of Viksit Bharat by 2047 as laid out by our Honorable Prime Minister. With these few words, I would like to thank you all for your patient hearing, and I once again convey my grateful thanks to Dr. Narottam Sahu for his kind invitation. Thank you. Namaste.
Thank you, sir. Now I respectfully invite our chief guest, Shri B.H. Talati, IAS, Commissioner of Technical Education, Government of Gujarat, to address the gathering.
Respected Sri D. Pallam Raju, Professor and Dean of the Physical Research Laboratory, Sri Manoj Pataria Sahab, President of the Society for the Innovation Science, my dear friend Mr. Narottam Sahu, Advisor and Member Secretary of the GUJCOST, respected ladies and gentlemen, students, faculties, researchers, and distinguished guests, Namaste. We live in a moment where the rules of the possibles are now shifting. What are the possibles earlier, now they are all going to change. The last 30 years, we have saw digital technology, how reshaped the work, atmosphere, commerce, science, communication, and in every sphere of the life. But today we stand at the threshold of a second wave, which we can say as a quantum revolution. Before 1980, there is a rule of the, we can say, petroleum and all other things. But with the advent of the computer in 1985 to 1991 and Windows and all other things, game has changed, it's simplified, and from 1991 to 2030, all top 10 companies are coming from the computer field, either Apple or Microsoft or whatever. We can easily say, with the revolution of the AI, coupled with the quantum technology, there are a lot of work for every engineering discipline to make a research points. So there are a plethora of the, I can say, subjects are opening to research in your desired field with the help of quantum computing. So many engineering disciplines are there, so many engineering projects are there, where we are stuck up with the calculations even supercomputer can't do. But now we can chase the protons, we can chase the neutrons, and we can chase at the quantum level, and that will change the game entirely over. Here we can say quantum science offers a new class of the capability the human possesses. Fundamentally different algorithms now we can test. Sensor with the unprecedented precision we can now set. Communication that promise provable security end to end. And material and chemistry now have a new dimension to compute in a way classical machine cannot efficiently do. That we can do now. Here, so we can say revolution is not merely here. Being as a policy maker, This revolution not merely a boutique of the high-end physics labs. Now it comes out of the labs. It will ripple across the healthcare, electronics, climate change, climate science, agriculture. Rightly says about that it's the pharmacy, chemical engineering, finance even, and national security. So equally important, it will either deepen the inequalities. Maybe a richer become a more and more richer. Equality may increase. But if we choose wisely how to use this science, how to deploy this science into the benefit of the mankind, then I can say we can expand the opportunity. That choice depends on two things. One is the inclusive education, first and foremost. And second thing is the clear policy guidelines. So both can be, I think, government has to think, we have to think, and that's why Government of India has set up a mission. Similarly as the California, what USA has the California mission, similarly we have also National Quantum Computing Mission with the expense of the 6,000 crore for the outlay within the 5 years we have to spend. And from there, we have choose the 6 IISC, Indian Institute of Technology, Bombay, Delhi, Madras, and IIT Hyderabad. All that sphere, we are going for a different kind of, different subjects and different pinnacle of the institutions' discovery with the quantum science. Here we can say, policy brief, if I want to say, being as a policy maker, quantum technology, quantum computing, communication, sensing, and materials represent the next foundational shift now. And for this foundational shift, after the digital revolution, if we want to set, then we have to also keep into the mind the nations with, such as China, USA, and Germany, how they've already shaped their technology, how they've already shaped their policy, and how they've integrated the quantum science into the national security, industry, and education strategies. Mainly, I have studied all this. This is generally on this three plethora of the things they have generally work over there. India has taken a decisive steps through the National Quantum Mission, but societal impact will depend on inclusive education, inclusive workforce readiness, and public understanding, not only elite research. Why this matters to the India? Because strategic sovereignty we have with the shark nations surrounding us, quantum impacts our cyber security, our defense, and critical infrastructure. Similarly, economic opportunities also there. We are living in the gift city nearby, so we can say new industries in the sensors, pharma, logistic, finance, and semiconductors. Luckily, all these sectors are much more belong to the Gujarat because we have a pharma, we have a logistic, we have a finance in gift city, and we have a semiconductor now new hub in Gujarat. So all these industries, which is very much sprawling with the help of the quantum, we can take the maximum benefit out of them. Societal impact, we can say application in the healthcare diagnostic, water management, agriculture optimization, and climate monitoring. Yes, definitely we can get the benefit from this. And demographic advantage, almost. Because we are the largest youth population who can become a global quantum workforce for entire world if we can train them early and inclusively. And that's why start is coming from the GUJCOST. We are starting from the standard 9th. I am really giving a congratulations to Mr. Narottam Sahu for the kit, what they have actually prepared and propagated to through all the science. I think you have a social science clubs are there through the 8th and 9th standard students because this is required. We have a quantum, I think, must move from a lab science to a people science. If we can move from the lab science to the people science, I think we can we can win immediately. And for this, we have a key policy challenges are there. One is quantum education remains always elite and urban centric until now. But now we have to reach up to the rural, we have to reach up to the 8th and 9th standard students, and from early we have to give the start. Limited teacher capacity and regional labs. We have not much more regional labs. Even we have not a much more teacher available, not even their capacity we have to expand. Low public awareness leading to the fear or misinformation. Till today, most of the teachers, when we are talking about quantum, generally there is a fear, what is this new things are there? We don't know. Weak industry, academia and school linkage already there, and now we have to make the powerful And this subject we have to propagate through this. And absence of the district level access for students, there are science labs, but they are in a limited, and paucity of the labs are there. I think specifically quantum labs we have to, at the high school level, we have to increase. And for this, I think we have to work towards that thing very hard. And so we can make a policy objectives over here when we are meeting over here in the communication conference. For the next 5 years, 2025 to 30, I think we have to build the quantum literacy across the school, college and society. We have to create a future-ready workforce, which we are already doing in the Commissioner of Technical Education. Our at least 50 to 60 professors, they are now really serious towards this, and we have a next future faculty development programs, and we are now conducting in a near future. So these things already we have started. Align the quantum R&D with the societal problem solving. So hackathon should be made towards this, and we have to invite a problem and how to solve this in all this area, particularly pharmacy, chemical engineering and all other respective things that we have to think. Position the India as a trusted global quantum talent and application hub. That we can do easily, and this is the low-hanging fruit, and we have to catch it up. Quantum education pyramid we have to make first. First, I think, introduce the quantum institution models in standard 8 and 9th and 10th. This should be a conceptual, not a very much mathematical, because in 9th and 10th you can't teach the quantum with the very high dose of the mathematics. Launch interdisciplinary UG and PG programs with the universities, and 1-year conversion program for engineers and software professionals towards the quantum science. Second thing, which is related to the GUJCOST, establish the youth quantum labs in every district by phase rollout. This is really required, and here we can give the facility about the optical and photonics demo kits, quantum simulators, hands-on maker activities, just what you have done, and operated via school, college and industry mentorship. Here, if anything you require, we can also collaborate with the Commissioner of Technical Education, and jointly I think we have to give the awareness towards the district youth quantum science labs. And third thing, teacher and faculty capacity building, which we have already started. But I think in the higher education and technical education, we are doing this and we are committed to do this. But at the school level also, initial quantum knowledge should be imparted, and for that, if you want to make a training for the high school teachers, we can ready to do that under some bridge programs. Third thing is the national certification for the quantum educators. 2 to 4 week immersion program at IITs, IISCs and regional hubs, which we have already undertaken, and incentivize faculty through promotions, grants and sabbaticals. This is yet to done because it is a somewhat a difficult task. Inclusive science communication, quantum content in Indian language, I think we have to make. This should be. Mobile science vans and traveling demos, which with the help of the Science City and GUJCOST we can propagate. Annual National Quantum Week, I think we have to, from the next year, we have to make annual National Quantum Week, and we have to take in a very concentrated manner. Here, I can say industry and startup integration is very much required and must. Already with the help of the iHub and GUJSEC, we can make the quantum startup and grant for India-specific problems, industry problem statement routed to the universities, and particularly hackathons and under industry problems, we can invite and we can work towards there. And public sector pilots for the vaccine, logistic optimization, water and groundwater sensing, which is already, there is some research very good going on in the particularly a groundwater sensing that we can do, and secure health data communication. I think for this governance and implementation in Government of India, already there is a national level, National Quantum Computing Mission with the help of the Department of Science and Technology at the union level and at the state level, and education ministries and mission directors are already there and they are doing their work. State level higher and technical education we can also be part over there. And partners, industry, startup and global research collaboration we can do. For this we have to make some key metrics. Number of teachers, how much we have trained within a year, how much district labs we have make operational, and how much student assessing the quantum tools. I think this is required. And for this I can say, after all these things, quantum leadership is not measured only in qubits and patents, but in how many young minds we have empowered, how many societal problems we have solved, and how inclusive the future of the science becomes. And for this, I can say the quantum age is a challenging if we can make work in siloed. But if it is an opportunity, we can work with the collaboration. Here in Gujarat, PRL's research excellence is with us. Science City's outreach power is already we have with the help of the science clubs, and GUJCOST coordination is there, and our education system scale we can improve. I think through all these collaborative efforts, Gujarat can demonstrate how quantum science serves all society. Education, communication, and policy will empower active contributors, and we honor this conference by advancing quantum science with the society. Thank you very much.
Thank you, sir. Now I would request our respected dignitaries on the dais to launch the conference souvenir documenting key deliberations and outcomes of the conference. Thank you to the dignitaries. Now we shall move forward with the felicitation. I kindly request Dr. Narottam Sahu, Advisor GUJCOST, to present a memento to our respected chief guest, Shri B.H. Talati, IAS Commissioner of Technical Education, Government of Gujarat.
Thank you, sir. Now, I would like to request Dr. Manoj Kumar Pataria, President, Society for Information Science, to present a memento as a token of our gratitude to a guest of honor, Dr. D. Pallam Raju, FASC, Senior Professor and Dean, PRL, Ahmedabad.
Thank you, sir. I kindly request Dr. Narottam Sahu, Advisor GUJCOST, to present a memento to Dr. Manoj Kumar Pataria, President, Society for Information Science. Thank you, sir. I would request Dr. Narottam Sahu, sir, please present a memento to Dr. Suparva Mishra, Founder Director, Om Arts Dance Academy, Ahmedabad, Gujarat, India, for the beautiful welcome dance performance during the inaugural session by her students. All the dignitaries on the dais, I would request everyone please present a memento. I would request the audience, please again give her a big round of applause.
थर्ड से शुरू कर रहे हैं? फर्स्ट थर्ड से
Thank you, everyone. Now the moment has arrived that our poster presentation participants has been eagerly waiting. The prizes will be awarded for outstanding posters in the following two tracks, that is track 1, Communicating Complex Quantum Concepts, and track 2, Tools, Methods and Innovation in Quantum Science Communication. May I request the dignitaries to kindly present the awards to the winners of the poster presentation. Starting with the track 1, that is Communicating Complex Quantum Concepts. It gives us great pleasure to announce the winners of our track 1. The third position in the poster presentation goes to Kaushal Purohit from Silver Oak University. The second position is grabbed by Hem Narendra Kumar Bhatt, SS Engineering College. And the first position is backed by Divya Dilip Rahul, IAR. Audience, please welcome them with a big round of applause. Again, I would request the dignitaries to kindly present the awards to the winners of the poster presentation for track 2. And here, the third rank is secured by Nimish Trivedi from ITRAM. Second position is awarded to Manshi Shukla, Swarnim University. And the first position is secured by Leena Patel from Nirma University.
I request all the winners of the poster presentation competition, both track 1 and track 2, to come forward for a group photo. I request all the winners to please come forward for the group photo, both track 1 and track 2. Kaushal Purohit, Hem Narendra Kumar, Divya Dilip. Please come with your trophies for the picture.
Once again, please give a big round of applause for all the winners of poster presentation.
Thank you, everyone. I request the coordinators of each university to come forward and collect the certificates as they announce their name with their teams, starting with ITRAM. Please come forward quickly to collect your certificates. IIT RAM, from IIT RAM.
All the participants from IIT RAM.
All the participants from IIT RAM, please come forward. Next, St. Xavier's College. दिख नहीं रहा. Followed by Nirma University. Kindly come forward and wait near the dais as I announce the names. Gandhinagar University. Adani University. Kindly applaud as they receive their certificates. PDEU.
I would request the audience, let's come on, encourage our participants and their hard work with big round of applause.
Indian Institute of Teacher Education.
Collect your poster certificates from वो बाद में बोल देंगे ठीक है आना चालू करें ओके poster presenters kindly collect the certificates from outside and your your participant certificate बड़ा confusing है that's right after announcement
Sardar Vallabhbhai National Institute of Technology. Institute of Advanced Research. LD College of Engineering. Gujarat Technological University. Parul University. Anand Pharmacy College.
We are not able to hear the applause from audience.
HPHP Institute. Which one? Indrashil University.
It's okay, it's okay, it's okay. That is none of our job. We are doing our job.
HVHP Institute. Anand Pharmacy College. Indrashil University.
Sakalchand Patel University. अब कौन सी है?
Sakalchand Patel University.
साकलचंद पटेल यूनिवर्सिटी बोलो वापस से बोलना है तुम्हें
Okay.
ताकि उनको पता चले।
Sakalchand Patel University.
आप लोग उस साइड जाना। मैं कैसे बोलूं रेडी होने को? सिल्वर ओक प्लीज बी रेडी।
Silver Oak University, please be ready near the dais. Silver Oak University, please be ready.
We request all the members from universities, please be quick and come in group, please.
ये रेडी रहने के लिए। नेक्स्ट कौन से हैं? ये चौकसी आ रही है SSIU। स्वर्णिम वाला कुछ है?
Swarnim University लिखा था। Swarnim University, please be ready.
Come fast.
Come fast to the dais.
All the representatives from the Swarnim University.
All the representatives from the Swarnim University, please come on the dais. I request all the participants to come in groups when your institute is announced. IIT Gandhinagar.
IIT Gandhinagar. IIT Gandhinagar
भैया बैठ के यहाँ पे देखो प्लीज अभी चुप रहिए प्लीज।
कौन सी है?
ये क्या है? PIAS?
पीडी पटेल बुलाओ।
PD Patel.
पीडी पटेल कॉलेज नहीं है? Is there anyone from PD Patel?
Is there anyone from PD Patel?
CSCIT lab.
Now we request a big team, with a big thanks to sir from the CTE to please collectively come and collect their certificates. Thank you once again, sir, for all members of CTE. Please join us.
ये अनाउंस कर दो जिसको भी सर्टिफिकेट में
Next, I'll request all our CSC coordinators, IP lab coordinators to be ready just after RSC. Please be ready after this so that you can also collect your certificates collectively. Just be ready over here. CSC coordinators, RSC communication managers, and IP officers.
रजिस्ट्रेशन वाले में बिठा दें सर्टिफिकेट के लिए क्वेरी के लिए जिसका है
निबटने दो उसके बाद में क्वेरी हो जाएगी अच्छा अभी सब आ रहे हैं
For any query in individual certificate, we request them to kindly report at registration desk outside the hall.
Now our CSC coordinators, RSC communication manager, and IP officers. Please collect your certificates collectively.
All the poster presenters, please collect your certificates from outside at the registration desk. All the poster presenters.
एक्सपर्ट को फोटो सेशन के लिए बुला लो
And now I'll request all our experts to please come on the dais who have taken the talks and have participated in the panel discussions to please come on the dais. We can have a group photograph. Ma'am, Land Madam, Badar, Tariq Badar sir, Singh sir, I think we can all move for the tea which is served backside, so you can have your tea.
આપણે ડાયરેક્ટરેટ ઓફ ટેકનિકલ એજ્યુકેશનના જેટલા સ્ટાફ છે એ બાજુની ત્યાં આવે કોન્ફરન્સ રૂમમાં. આપણા ડીટીના જેટલા પણ સ્ટાફ મેમ્બર્સ છે એ બાજુની કોન્ફરન્સ રૂમમાં ચા કોફી માટે આવે, કોઈ જતા નહીં. बेचवा वाली